And you can put it in your mouth. There's a clip on the back.
Yeah. Then can I just...
Iemand voor, kom op.
There's a bunch of people who are trying to get into it. If you have a seat empty next to you, please move into that seat.
I picked a really good time to just inhale a whole bunch of water.
Next to the middle, so that people who are still coming in can actually find a seat easily. Morning. Mag dat scherm eigenlijk iets uit, want nu ziet je toch niet geen activiteit. Of is dat mijn?
Question for you. When are the sponsored pitch talk things?
During the Ignite sessions.
Okay, so not this morning.
Yes, this morning.
This morning, after the keynote?
No, so I think we have 3 or 4 keynotes, 3 or 4 opening talks. And after that you have the Ignite, you will be the last one just before lunch.
Okay, what time are they?
Do you remember the times?
Je moet die gebruiken als host van anders al.
Ah, die moet je er gewoon bij houden. Kijk, niet te dichtbij.
Oh, voor de intro, ja.
Kijk, die moeten,
Ja, ik zag jullie wel praten, maar ik hoorde jullie daar niet.
je moet echt gewoon even zo doen.
Oké.
Op deze afstand ook
Zij
houden.
heeft er
Je moet hier niet...
Win heeft een ding, hè? Win heeft die,
Ja, die heeft alleen. Ja, een andere, ja. Je moet niet te dicht in dat dingetje praten, want dan krijgen we vervorming. Dus het is een heel ander soort microfoon dan deze.
Oké.
First, what time is it?
It's after Eric,
Yeah.
so 12 o'clock-ish.
12 o'clock.
Yeah. Did you send me slides already?
Yeah, Red should have sent you slides.
Not seen them yet.
So who did him send them?
Red sent them to Chris. If not, I can.
Poke him and see, because if he says he didn't get them,
I've not seen them yet.
I have them, so I can.
yeah. So send them through, please, as a PDF, please. Okay.
3 minuten. Morning. Who's ready for day 4? 5. Wait, I lost count. 7. No, Walter. No, you're not. Fuck, 7. For those who didn't get the joke, for a bunch of us, this is day 5 of conferences in a row, and we still have 3 days to go. So who's been to FOSDEM? Who never wants to go to FOSDEM again? But that's good, because this is config management camp. And we limit the seats so we don't get the full room problem. If you've never been here before, this is how you get onto the wireless. If you've been here before, your laptop already knows. I lost count. Actually, this year I didn't even keep track of how many tickets we sold up till the point that people started complaining that the waiting list was enabled. Like, okay. There's still empty seats. The overflow room is still not fully full, so I guess we're doing fine. And most of you that are not here are still recovering from yesterday. So, once again, we had 7, I think it was over 15 the last time we checked, but 750 registered. There's about 360 seats in this room. The other one was 336, so add it up. We know that not everybody shows up, so that's it. I like to reuse this picture each year because that is what Config Management Camp really is about. It is about different communities learning from each other, not reinventing the wheel. So we have people talking about Vox Populi, while they'll contribute to MGMT, wearing a Puppet Labs, no, a Habitat t-shirt. This actually was at the Puppet Contributor Summit. And then we have DevOps Days Ghent organizers who basically wrote the picture. So that's what we do. We have open source communities who talk about what they've been building, what they're building next, what they're good at, and where they've been failing. So keep doing that. Keep crashing each other's room. We've been trying to not have tool-focused tracks. So this year we actually have a CI track, we have a monitoring track, we have a security track, we have a track on case studies and all of those things next to the actual tools. For those of you who've been coming for years, you've realized that a couple of years we stopped handing out free food because, well, that just didn't scale anymore. So now the cafeteria is open. It's all the way down in that building. Speakers, organizers, go see Tashan for vouchers. The rest of you you can do whatever you want for food. There's still light breakfast left, there's coffee, there's water, you probably shouldn't be starving. Cafeteria today serves gyros, hamburgers, and vol au vent, and some pasta and whatever, and salads. Wednesday, we have a full day of workshops. This is the fringe of the fringe. Please register. The reason why we want you to register is so that we know which tutorials, which workshops are going to be the most busy, so that we can reshuffle rooms if some of them tend to be more popular than we expected. Because we can still do that now. If we end up on Wednesday morning with a room that needs 100 people and we only have room for 60, it's going to be awkward. If we know that Tuesday evening, that's not going to be a problem at all. So, what are we going to do today? We're going to be slightly late because it's already 9:40. But we have a number of really great speakers. We have Rin, who's going to start. Then Paul Stack told me he has no slides. He's probably still working on them, but at least he's here this time. Oh, you have slides. Oh. Eric is going to talk to us about the history again. No. The future. Oh. This year we have 2 days of Ignite talks. So around 12:20, we're going to have short 5-minute talks. They're going to be fun, and then there's going to be lunch. Tomorrow morning, we have John Willis, who's going to open at 9:30. Berend is hiding in front, is going to continue talking about why we should not be using MacBooks.
That's not true, and I'm talking with Michael Duty at the same time.
And Michael is going to talk about security. For now. There's no schedule changes, but if there are, we'll announce them on Twitter and we'll be updating the schedule.
So, as you saw, we don't give food anymore to everybody, but still we need some money to get this event up and going. So the whole Ghent gives us a venue, which is very nice, very grateful for that. Inuit and Vantosh are the companies we work for, as we are the core organizers. The titanium sponsors are Ansible, currently owned by Red Hat, or IBM, depends on how you see it. SaltStack, iSinga, it's a monitoring tool, they're a platinum sponsor. Then we have a whole bunch of gold sponsors, Red Hat again, with the Foreman Project and Pulp, Rudder, Puppet, Schuberg Phyllis, Suze, Kangaroot, and OTA. So all of these sponsors actually have booths in the main hall. Please go visit them. We have free coffee, we have free croissants because of these people. So just go and say hello, thank them, and then we can do this next year again. There are other sponsors like HashiCorp, CityTV, which does our recording, and SIG.io, which does our streaming and our second room, Axis, Atix, Example 42, and we even have Francis, who has been sponsoring us at a lower level, but at a personal level. So these are people who try to help us out, and yes. Yes. And then Chris will be talking about lies.
Lies, damn lies, and statistics, which is what you're all here for. I know by now the history is completely irreadable now. We've got a bunch more communities, and these are the figures we get from when people register and say, hey, I'm interested in this thing.
Well, we added a whole bunch this year. So we actually added a whole bunch of communities this year. So some of the graphs you will see are not full history yet, and next year we will have better graphs.
There's at least some people who understand the concept of statistics, because these are lies. But Well, we started out with some short of 400 people the first couple of years. We've been stagnating at 750. And this is the evolution of the room sizes. There's a couple of new things that for some reason have been declining since last year, but it looks like everybody's losing interest in everything. Every single community has been... Every single community has been having less interest than what we had last year for some reason. What is clear is that there's a lot more interested people in everything which is containers, and a lot less in everything which is traditional configuration management. So we're evolving, not saying which direction. And if you look at the newcomers, tools like Pulumi and Terraform, well, not really real because they're almost equally old, we see similar patterns as what we've seen with Shell and Puppet before. And really similar patterns. So that's something you all need to think about. Okay.
So we have the beer event this evening. When you go out of the building, you walk completely till the end of the hogeschool, and then you cross the road. The place is called The Zone. You will need a little bracelet which will be in the sponsor area at lunchtime or after lunchtime. And then you get free drinks for a limited time, basically till our sponsoring money runs out. Have fun, but be responsible. Then we organize conferences as a living. Oh, no, sorry, we don't. But we organize another little conference called Load Days on the 28th and 29th of March. The CFP is still open. It's an operations-oriented conference. It's in Antwerp. So if you like Belgium and you like Belgian beers, you like Belgian chocolates, you're welcome to come back. The CFP is still open there. And yes, enjoy our conference, talk to the other communities. The idea is that you get to meet people from other communities and be together with each other and learn from each other. And now I think Rin will do her presentation. You're hooked up, huh?
For the recording, yes.
Oh, we need that one also?
For the audio, we do.
All right, it's thinking about it. All right.
Something wrong with the transmission?
Yes.
Yeah.
1 minute, let them come and check.
Yeah.
Maybe it isn't on.
Yeah, there was a light. Now there's no light.
That's recorded. Press it a little bit longer. That's not the recording.
It's going on now. Take the other one. Where's the other
Where
one?
is this one? So this one is for the room, and that one is for the
This one is more easy. Put on. Yes. Okay.
Will this work fine? Or does it need to be closer?
I don't know. Are we good?
I can know this one
Yeah.
for me to hear you.
That's for the recording.
Oh, and this
for the
is-
room.
This is for
Yeah.
Okay.
Okay.
I put it a bit more your way. Watch out! I don't hit you. We have a big audience.
Yeah. Can I just hold it? Would that work?
Of course.
All right.
Of course.
Okay. We'll see how this goes. Can people mostly hear me okay? All right. I am going to tell you some stories this morning about configuration management, and some stories about state, and some stories about geese, and how they can all work together to end up being really horrible. So who in here has played or at least heard of the Untitled Goose Game? Okay, good. So at least a few people in here will get these references. So the premise for those of you who have not played it or have somehow managed to stay off the internet recently is it is a lovely morning in the village and you are a horrible goose and your goal is to cause problems on purpose. So you can break into people's gardens and steal their stuff and break their things and trip them and make them fall in puddles. It's great fun. Now, as engineers, we generally don't try to cause problems on purpose unless you're one of those offensive security engineers. But let's be real, who out there has accidentally caused problems not meaning to? Yeah. So a little bit about me. I'm currently an SRE on the Terraform cloud team at HashiCorp. I spent the better part of a year before this as a developer on the Terraform AWS provider. And then I've done operations for most of a decade before that. So I know at least several to a few things about Terraform. I'm very good at making bad puns and other bad jokes on the internet. And I just changed teams recently. I've been on the SRE team for 2 weeks now, and I have not horrifically broken production. Thanks, thanks. I'm either doing something really right or really wrong. But when I first started out in operations, my career looked very, very different. I was working as a QA engineer for a really small startup in New York. And they had one sysadmin who quit for reasons that would later become obvious. And the managers kind of said to me, they're like, Rin, you've used Linux before, right? Can you go to the data center and keep it from burning to the ground? And I was like, I mean, I've used it, but I'm not a sysadmin. And they were like, that's nice. Here's your access card. Good luck, have fun. And so I inherited 200 Snowflake servers, beautiful and unique, absolutely zero automation, no config management, not even a bash script to keep me company. And somehow I was the least underqualified person who was now in charge of this data center. So at this point, I was basically a very new horrible goose who had gotten into the data center, and I was ready to cause problems. I mean, make things better. So 200 servers is not a lot by any sort of, modern standards, but it is a big number for when you have to do everything completely by hand and have absolutely no idea what you're doing. There's a lot of state involved. So, talking about state for a minute, if we take kind of a simplified look at the world, we can say, okay, we're doing things that are building and running applications for people, applications of some sort. So we care about application state, what is the application doing? And then the system state, so what is the system doing that is running the application? And if you kind of look at the history of configuration management in software, you see that really, really early tools focused on being able to compare and reproduce state. So you have things like diff that can compare state, or make to try and reproducibly build the state that is needed to execute a program. CVS or SVN would give you ways to version state, and if you're sitting up there saying, well, those aren't config management, there is a Wikipedia page that says you're wrong. Now, application state is always going to be a thing, but luckily there are application developers who can worry about that sort of thing, so we'll just talk about system state for now. So back in the day, you might have had, your one server running your entire LAMP stack sitting under somebody's desk somewhere, getting dusty. And then things were relatively easy because you just had the one system to configure. But as soon as applications and infrastructure started getting more complex and you had multiple systems to run everything, things got more complicated. So we have system state. What is the system doing? What is the system supposed to be doing? Because, ideally those would be the same thing, but as we all know, they always aren't. What versions of things exist, what is and is not installed, early configuration management kind of gave us the ability to set up a baseline. So let's get the system into this known good state, and maybe it'll stay there for a little while. We also want to know what has changed in the state, so getting some sort of diff. Ideally, maybe knowing when things changed, who made those changes, so you can go talk to them and be like, why did this change? Can we talk about this? And maybe there were some change control processes to try and prevent unapproved changes. So trying to take all of these things that go into system state, and with config management, maybe we can make them a little less horrible. So, back to my data center with my 200 beautiful and unique Snowflake servers, my precious, precious children. One of the first things I did was start trying to set up any automation at all. Actually started with doing some sort of physical inventory, because when I went in, people were just like, here's the badges to the data center. We don't know what's in there. Maybe you could tell us. I found things like a load-bearing Xserve. That was an adventure. And so I'm in here trying to sort out, what is the current state of the system, and then figure out, working with the engineers, what is the system state supposed to be? And again, I inherited absolutely no automation or configuration management, so it was really just me running around with like a fire extinguisher, except the fire extinguisher is also on fire. One of the first things that I did was set up a cobbler server, because when I started, I had a USB DVD drive and a pile of CentOS DVDs that somebody had found in a drawer somewhere, and they were like, you should use these to install the servers. That'll work well. So I set up my cobbler server, and then I was like, okay, the engineers keep having me do the same things on all of these servers that I've installed. I'm going to write a bash script. It was better than nothing. The problem with bash scripts is that they don't really manage system state. I wrote a tool that was basically kind of a hammer, that you could like hammer the systems kind of into this given baseline state. But things would fail, or because this was a very professional environment and everyone had root access to SSH into servers, people would SSH into my servers, my precious and unique children, and do things to them, and then my bash script wouldn't work anymore, and then people would say to me, Rin, why is API 12 on fire? And I would say, I don't know, it's beautiful and unique, and its reasons for throwing a temper tantrum are vast and unknowable. What did you do to API 12 to make it so sad? Because I'm pretty sure it was fine yesterday. So yeah, drift happens, our baseline state changes, and I couldn't really get diffs with my bash script. I was kind of having to resort to poking around to see, talking to the engineers, see if they would tell me what they did. There was absolutely no sort of change control or any sort of process around that. And then one day I was complaining about this on Twitter, as one does. And somehow James Turnbull managed to find one of my tweets, and he worked at Puppet at the time, and he said, so I don't want to sound all salesy, but I have this thing called Puppet that feels like it would make your life a little less sad. Would you like a free book and maybe some stickers? And I was like, stickers? I love stickers. Shit, yeah, sign me up. And so he sent me the Puppet book, and I was really excited. I was like, okay, I can learn about this. I can start setting this up. And this all sounded great, because I'm like, now when the devs SSH into my servers and change things, maybe Puppet's going to know what they're supposed to be doing and put stuff back. So here I was, getting ready to do some configuration management and definitely not cause any problems. So I had this data center, this beautiful, lovely data center that was running its website, and okay, there were a lot of problems. It mostly worked occasionally. It was okay. And I'm getting ready to start implementing Puppet. And I started with, some of the easy wins where I talked to the web developers, and I'm like, okay, so it looks like Nginx is running. Nginx should continue to be running, right? And they're like, yeah. I'm like, okay, put that in Puppet, roll it out, Nginx continues to run, everyone's happy. And I'm doing this and I'm doing this, and then one day I come along to Postfix, and I notice that Postfix is installed on all of the servers, and it has some what look like custom configurations, not just the whatever's out of the box, but it's not running anywhere. And so I ask all of the devs, I'm like, hey, should Postfix be running? And they're like, ooh, yeah. Postfix is going to email us whenever there's errors, and we want to know about those errors. We thought it had been a little quiet recently. Definitely turn that on. Okay. So I'm going to turn Postfix on. And this is, you know, I'm pretty sure that I put the changes in Git, and I got a code review and some nice stuff like that. And I was like, okay, we have this known system state. Postfix is off. And this known configuration change, Postfix is going to turn on, and it's going to be the new known system state where Postfix is on and everyone's happy. Except no. So I rolled out this change in Puppet, and Puppet was like, yep, I've applied your change, good job. And then everything fell offline, just completely offline. The site was down, couldn't SSH into any machines. There were emails everywhere. It turned out there had been 8 years of emails. Yeah. Just 8 years of emails sitting on each of these 200 Snowflake servers. And then they all sent at once, and it just saturated literally every link in that data center, and it all just caught on fire. What? So our known state was not actually as known as we thought it was. We knew the system state that Postfix was off, but we didn't know the application state where we had 8 years of queued emails. And like, yes, in retrospect, maybe we should have checked that, but nobody thought to do that at the time. Configuring the system state change didn't account for this unknown application state, and it was one of those things where there really wasn't an undo button. Like, sure, I could have reverted that commit in the Puppet repo, but you couldn't unsend those emails, and we were just like, okay, so we can't SSH into any of the boxes. I guess I could go to the data center and take my keyboard and plug it into each server individually and like turn off Postfix, clear the queue, do all of that. But there were so many emails that eventually we just decided, let's just leave the emails. They'll finish sending eventually. Look how many errors they are. We found them. So if there's one thing we learned here, it's that we can't be rid of application state so easily. Turns out we don't have to be application developers, but we do sometimes have to have some sort of idea of what the application state is and how that is going to interact with system state. So we care about similar sorts of things for application state as for system state. What is it doing? What does it care about? What is its view of the world? A lot of this stuff can be internal to the application that we don't have to worry about, but sometimes we do, and we don't always know in advance when we do have to care about it. Again, we want to know what things changed, when, who changed them. An application state can be especially fun because there's things like caches or queues that add more layers of complexity that definitely never cause things to go unexpectedly. Okay, so we've learned that Puppet is how I set things on fire, and we should just never use computers, I'm pretty sure is the lesson here. More realistically, don't forget about your application state, and don't forget about the unknown unknowns. Because, you know, the known knowns and the known unknowns are relatively easy, but it's the things where you don't know until everything has caught on fire, and you're like, in retrospect, we should have thought of that, write that down for next time. So, we've done some horrible things. Now, to be fair, a non-zero amount of that particular story was, that was my very first ops job. I was a very small, horrible goose. I had no idea what I was doing. I think it's safe to say that if you as an engineering org leave just 200 beautiful smoldering Snowflake servers on fire, that maybe there's some lack of rigor overall. None of us knew exactly what we were doing there. So let's fast forward a few years to a time when I knew a lot more. Now, I'm telling these stories not just so you can laugh at my pain. It is numerous and hilarious, though. But to illustrate that, like, these are complex systems that we're dealing with, and even teams full of smart people who ostensibly know what they're doing can end up doing things that we don't intend to. So, several years later, I'm working at Etsy. I've got a team of really smart people. Like, the ops team at Etsy was fantastic. I was was working on a thing called Project Indigo, which was Etsy's provisioning for hardware in the data center. So at the time, Etsy was almost entirely in their own data centers, had data center teams who would go and rack the servers and plug everything in. Project Indigo was then designed to, it was a Peter Gabriel naming scheme. Etsy was really into fun names, don't worry about it. This was a tool set that was designed to get to the point so when the data center team had racked up a server and cabled everything the right way and powered it on, it would bootstrap itself and install an operating system and configure itself in the network and do everything to get itself to the point where it could be a useful server in the world and do something nice and productive with its life. So I was working on this infrastructure, this server provisioning, and that meant I needed a test server to do some of the end-to-end testing to make sure that it actually did the thing and provision the server. And I'm going along and I'm doing this, and it's mostly working, except for my code keeps breaking because, I don't know, I keep writing bugs in it. Why would I do that? And then one day, right after lunch, I'm running my provisioning, and Chef fails. I'm like, oh, it was so close. Chef is at the very end of this provisioning. We're getting really close. Why is it failing? I don't want to downgrade the Apache version. So we had a local yum mirror that pulled down the latest versions of various packages, and at some point, while we were at lunch, it had pulled down a point release of Apache, and that was 1 point release newer than the version that we had configured in Chef. And I said, okay. We've run into this before because this was what the yum repo did, is it pulled down all of these changes and then deleted the old ones. You can debate whether or not that was the smartest thing to do, but that's what we did. And so I'd seen this before, we'd seen this pattern before, and I was like, okay, it's a point release, test it locally, does the right thing, great, gonna bump the version in Chef, and the way that Chef was configured was that this change was only gonna impact new machines. This had the side effect of there was a lot of version drift across the fleet, so servers that had been provisioned months or years before had older versions of Chef or whatever package than newer provisioned servers. But we knew this, and this was the trade-off that people had decided to make. Point was, we had done this before. So we had this perfectly nice website, all of these Apache web servers, just running the website, doing their thing. Again, we had done this a bunch of times before, and it had always been a no-op before, so we were relatively unconcerned about how this change was going to go. Had this known config state, we had this no-op, and so we were going to end up with the same known config state. And then I was going to get to move on with my provisioning testing, and everything was going to be fine. Except no. So what happened was I rolled out the change, and then I was like, just for fun, I should log into one of the web servers and make sure that Chef is doing a no-op. You can see where this is going. I logged into one of the web servers, and Chef upgraded Apache, and then Chef and Apache fell over. It couldn't start Apache back up, and I'm like, oh, this is going to roll out everywhere in the next 10 minutes. And I turned to the guy sitting next to me who was our on-call person at the time, and I'm like, so you're about to get paged a lot. That's my bad. Sorry about that. Let's try and fix it here. And everyone was really wonderful and supportive. But Chef had done this upgrade that it was not supposed to do, and then it was complaining about this config file that was or was not supposed to be there, and everything is on fire, except somehow the site was still up. It was really incredibly slow, but it was still up. We were just like, what? What just happened here? So, a bunch of really smart people all jumped in to help. It was, nobody yelled at me and was like, why did you do this? We just got back from lunch. Why are you this horrible goose? Everyone, jumped in and asked, how can I help? How can we troubleshoot this? Eventually, what we think we figured out is that there was an Apache submodule that had an unpinned version, and somehow these kind of colluded with this Chef change to cause the upgrade across the entire infrastructure, even though it was a pinned version that was not supposed to be upgraded. That was our best hypothesis. Now, I mentioned that the site stayed up. It turns out that there were 7 servers where the Chef run was failing before it got to the Apache cookbook. Those 7 servers were running a test of PHP 7 at the time, and we discovered accidentally that 7 PHP 7 servers could keep Etsy.com running in the middle of the day. That was an adventure. And then there was this, so we had this unknown and inconsistent configuration state across all of the infrastructure, which, okay, it turned out to be good in this particular instance, but also it might have been good to know that, Chef isn't running everywhere that we think it is. And then we had, obviously there is no root cause, but a big part of this issue was the fact that this source repo, this yum mir, was kind of unattended and uncontrolled, and it just kind of did its thing and upgraded packages and deleted the old ones. And so this pattern of, oh, there's a newer thing in the mir that's in Chef, now we have to bump Chef, blah, blah, blah. This happened a lot, but it had never been catastrophic enough that people were like, we should fix this. But these two things got out of sync a lot. So you had the version in Chef and the version in Yum, and they collided, and sometimes that went better and worse than other times. So now we can add kind of 2 new types of state, configuration state, and here we're talking about the various components of configuration management systems. So you have, your Chef recipes in this case. We had the, Chef server's database, what it knew internally is its state of the world, and then various versions of, the Chef client. And due to historical package drift related reasons, there may or may not have been different Chef client versions in play here too. Always a good time. And we have source state, so whatever inputs to not just the configuration management system, but the system as a whole that ultimately help create, the application as it runs. So Yum repositories, Git repositories of the app, Git repos of Chef, whatever. And this whole system, when it is executed, creates the application state. So, configuration state, what have humans put into, Chef recipes? What are the people trying to tell the configuration management system to do? What does it know internally about its state of the world, and kind of how is it running? And this can be internally inconsistent if you aren't careful. And then source state, like I said, all of the inputs to the system. Whatever you can put in source control really can become a part of your source state. So that's all going to come together to create the application state. So we have some more things that can go into state that can cause problems here. That particular incident with the Apache upgrade was so epic that I won an award for it. Etsy had a thing called the 3-armed sweater award that was given out every year to the engineer who broke production in the most interesting way. And despite the fact that, okay, technically I didn't break production because those 7 web servers meant that the website was still up and running, but apparently that counted enough, and I got a lovely 3-armed sweater for my trouble. So some things that we learned here: monitor your configuration state. Again, just because having 7 servers where Chef was failing ended up kind of saving our butts a little bit in this particular case does not mean that you should do that as a general rule. Please make sure that you don't leave 7 servers out just in case. And don't leave your states unsupervised. This would have been a very different situation if we had been, at least manually confirming that, like, oh yes, this is pulling down a new version. Let's have some sort of sensible process for putting that new Apache version into production, aside from, well, the Yum mir said we're going to upgrade, so I guess we're going to upgrade today. So I'm going to move on now to a slightly different class of this infrastructure as code configuration management. I'm going to talk about Terraform. And I feel like I should put on my HashiCorp hat right now and be like, Terraform is great. Not going to cause any problems with it at all. So this story is from when I was working at Travis, and again, I had a team full of really smart colleagues, and we had some tested tooling, some tested deploy processes. I was not actually the one who pressed the button on this, but I was working with my teammate who did, and she gave me permission to tell this lovely story. We were working on our Mac infrastructure, so for every time that you were trying to do a Mac build on Travis CI, it ran on this infrastructure. And at the time, this was using a company called Mac Stadium that I think essentially had a bunch of like Mac pros in a data center somewhere. And we got to use some of them as our infrastructure. So ultimately, I mean, yes, it's all servers there somewhere, but the Mac infrastructure was always a lot closer to the servers than like Amazon Cloud or Google Cloud that we used for the Linux part of the Travis infrastructure. So we didn't touch it that often because, you know, it was hardware, it was a lot more of a pain to deal with. But one day we were like, okay, more customers are using this, that's great, we need to up the capacity of the infrastructure a little bit. We need to make a config change, but it was hardly a config change. Like, we were making one number bigger, just one number. It's a really nice Mac infrastructure we had there. It would really be a shame if some horrible goose were to happen to it. So we had this known system state where we had the Mac infrastructure of a particular size, and this known config change, which was barely a config change, just one number. It was just going to get a little bit bigger. Everything was going to be fine. And we were going to have this new system state where there was just going to be slightly more of the system, right? Except no. We did the Terraform plan, and the Terraform plan looked okay. And it said, oh yeah, we're going to add some things. We're going to destroy 0 things. And we were like, great, 0 to destroy, some things to add, that sounds good. Terraform apply. And then the Mac servers started going away, and we were like, what are you doing? You said you weren't going to destroy anything. And the servers just keep going away, and then we try and rerun Terraform, and Terraform is just like, no, absolutely not, cannot do that. We were using like Terraform taint and Terraform untaint. Nobody's super clear at some point, like in the Terraform config, it was like Mac infra -v2 final please work.tf state. So this goose is just over here. Terraform's just like, no, this is my infrastructure now. You can't have any. What? What we ultimately kind of figured out must have been the thing that happened is some wildly and unknowably different configuration states that were not fully captured in the source state. So what we eventually kind of figured out is that somebody had done a Terraform apply from some changes that never got checked into Git. So normally we tried to be like, okay, we should deploy from the head of master, so you know we're applying a known state, a known set of changes. This had apparently not happened at some point in the past. So we had completely unknown changes that had gotten applied to the infrastructure and trying to like reverse engineer the diffs of what had changed. And then there was the fact that whoever had done this had used Terraform 0.9 and we were on 0.10, and if you don't know anything about Terraform numbering, those are major versions. Like, that was a very big difference. And Terraform was just like, excuse you, no, I cannot handle this. What are you even trying to do? It was very upset by those version differences. And because, you know, there was no Terraform server, like a chef server that had its one view of the world, we were stuck trying to like reverse engineer this from this state file that was in S3. And then on top of all that, we couldn't discount the fact that something in the Terraform plan output might have told us this, and it got lost in the scroll back because we kind of glanced over and it was like 10,000 lines of output, but it said like 2 to add, 0 to destroy, and we're like, that looks fine. So now on top of everything else, we have to add Terraform state, which is like the application state that's holding your configuration state and all of the info about your system state. And then you just take that and you put it in an S3 bucket because there's no problem in the world that can't be made better by putting it in S3. Fun fact, all 3 S's in S3 stand for sadness. That is our sadness, sadness, sadness bucket. Thank you. I'm mostly kidding about that. Terraform state, despite being called Terraform state, is really just configuration state. I'm not kidding about the sadness. The sadness is real. Okay, great. So we've caused a lot of problems in a lot of data centers now. A lot of that particular story could have maybe been prevented, again, hindsight bias, if we had done things like have a central deploy server, or failing that, some sort of check that said, hey, you should really be deploying from the master branch and not whatever random uncommitted changes you have on your laptop, YOLO. or by making sure that everyone was running the same Terraform version. And eventually we put some of those checks into the makefile that we ran as part of this. But ideally, you would make those sorts of, whatever constraints you feel like you need to have in place, have that be done by design and not by punishment. So blameless, blame-aware culture, we know that even really well-intentioned, smart people can mess up. Even processes that we think we know can have unintended consequences. So I think building awareness of that into your tools and workflows from the beginning is important. Don't do things like take away permissions and lock things down more and more and more after every incident, because you don't learn from that. It makes everything harder, and it creates this really broken and toxic culture of fear. One time I worked at a place many, many years ago where the ops team had to use Puppet exec to execute like any command that we needed to do our jobs, because the executive and management team after every incident basically just took away sudo access to whichever command had caused the problem. And so the only thing that the ops team had sudo permission to do was to run Puppet. Except they forgot about Puppet exec, so we just Puppet exec everything. But that was not exactly a healthy culture. So we've talked about a lot of different things that you can do with configuration management to cause problems. Again, we should just throw computers in the bin. They're not worth it. But the important thing to actually take away here is to realize that, like, yes, these are complex problems in complex systems. And that for the most part, people don't come to work trying to do a bad job. People are, again, except for those offensive security engineers, people are generally not horrible geese. None of these situations happened because people were trying to mess up. Like, I didn't come into work on any of these days and be like, you know what I'm going to do? I'm going to make everyone have a real bad day. So even with more and more robust configuration management solutions, and there were a lot of details that I glossed over in here for the sake of time, but there were things like staging environments and tested deploy processes and tests that ran. It's not like we actually were YOLOing everything except for that very first time. But things can still go wrong. So in addition to all of these kind of computery sources of state, we have to add in human state. What is the state of the humans who are interacting with these tools? Are they tired? Are they stressed out? Is it 3 in the morning? Is it 3 in the afternoon and they have been firefighting since 3 in the morning because something went horribly, horribly wrong? Like, the reason that we went from nothing to bash scripts to Chef to Terraform to whatever is to hopefully make it easier for ourselves to do the right thing, but also harder for us to do the wrong thing. So I'm going to stop talking about state for a minute and talk about human factors instead. I'm going to have a human factors picnic. Human factors is about considering the behavioral and psychological characteristics of humans and how those characteristics interact with the jobs that people are trying to do and the tools they're trying to use to do those jobs. It is a whole field of study. I don't have time to do it justice here. But when we are looking at these stories of horrible configuration geese, we can try and come up with a few human factors considerations that we should think about when we are designing configuration management tools and workflows. So fewer sources of state, I think, is a good one. I've seen places that are saying, like, oh yeah, we've got Chef and Puppet running, and then we put some Terraform, and then we put some Ansible in there. Maybe don't do that. Like, I'm not going to come up here and say like, there's a blanket statement and there's never any exception to this. There might be an exception. I am struggling to think of one. The fewer different tools that you have that are working on the same state, probably the better. Looking back at like the Chef example, we could have had one config that managed the versions that were available in both Yum and Chef, one source of state instead of two. Maybe a centralized Terraform in the Travis Mac infrastructure example instead of everyone doing it from their own laptop. This is when I put on my Hashi hat again and be like, this is why Terraform Cloud exists, to stop horrible geese from doing this exact thing. And then watch out for things that are providing incorrect state, because sometimes that can be even worse than just having no state information available at all. here has been dealing with an incident and you fall back to SSHing into a machine and poking it with a stick. Yeah. People can say on Twitter all they want that if you have people SSHing into servers in production, something has gone wrong and you should just take away their SSH keys and nobody should do that. But there is a reason that we keep falling back to this, and a lot of times it comes down to the tools, the other tools that we have don't feel reliable. Like they don't feel like they're surfacing all the information that we need, or they're feeling too difficult to use when everything is on fire and you can't remember, you know, whatever commands you need to run or something like that. So we had things like Puppet wasn't surfacing all of the information we needed, Chef behaving inconsistently, Terraform being its inscrutable, mysterious self. And it's this struggle of just like SSHing into the computer and be like, why are you doing this? Like, what is happening? So we need to find out, when we look at our tooling, what engineers are actually trying to do in the day-to-day, and what tools and processes they're using and which they're working around. Again, finding ways to surface incorrect or inconsistent state. Ideally, so you can know that things are about to go horribly wrong and then maybe make a different choice where they don't. But it's hindsight bias is always going to be there. But there is something to be said for trying to find ways to surface this information, especially in bigger and more complex infrastructures like we tend to have these days. So in the Chef example, we had a graph. We hypothetically could have known that those 7 servers weren't running Chef. That information was technically available, but every developer had their own VM, and they tended to turn off Chef on their VM so that they could test changes and not have Chef come stomp all over them. And so in the graph of Chef runs, just across the top, there was this little line of red that was all of the developer VMs. And so we got used to that. We're like, oh yeah, don't worry about that red stripe. If the red stripe gets bigger, then we should worry. But when you had a couple hundred developer VMs as this little red stripe, 7 more servers not running Chef, it was a pixel maybe at that. So we didn't have useful ways to surface that kind of incorrect or inconsistent state there. And this is kind of about balance, like trying to figure out how to surface information in a way that is actionable but not overwhelming. And finally, making sure that we're writing tools that make sense to humans, not just to computers. So if you have a Terraform plan that spews thousands and thousands of lines of output, and you have to scroll through and try and figure out which 2 lines in that output is going to tell you that, by the way, you're about to break everything. That's not superhuman friendly, even in the best of times, let alone when something is going wrong and you're in a hurry and you just want to get the site back up. We want to make sure that our tools have useful output that's somewhere in between no output and 70 bajillion debug log lines. Good luck, have fun. So again, it's designing about human readability and human usability in mind, but not just in the day-to-day. Make sure that these things work, test these workflows in, not emergencies, but, game days, that sort of thing. So that when things are on fire, you know that your tools are going to be working with you instead of against you. So we have thought about a lot of ways that people might use configuration management tools and how we can make them more usable by humans. What does the future of configuration management look like? What are we going to put on our little Yoda spatulas next? I've seen teams do things like write more and more custom tooling around existing config management tools. So if you have, for example, a bunch of different environments that are each managed by Terraform, each one having a little customized wrapper script. So you have a similar workflow, but slight separation under the hood. Or I've seen people go kind of a different way and do everything being really, really short-lived, immutable infrastructure, so lambdas or containers that only last as long as a few requests. So there's less running state that you have to try and manage and juggle up in the air, and more, we can just build it fresh from the source state and go kind of more directly from source state to application state. Maybe it looks like something else. I don't know. So we want to get rid of tools that are unreliable, or find ways to make them more reliable by the people actually using them. And then remembering that we use configuration management to try and make our lives less horrible as human operators. We're not trying to mess up. We're not trying to be horrible geese and do a bad job and set things on fire. But these are complex systems that we're working with lots of inputs and interactions and states. And so we should try as much as we can to design the systems and tools with that in mind. Make it easier to do the right thing, make it harder to do the wrong thing, and make it easier to use if a horrible goose gets into your data center. Thank you. Thank you.
Next up, Paul Stack. Does anybody know what he's going to talk about?
Computers.
Computers, yeah.
Full stack.
There's the mic if you need that.
This talk is called Can TypeScript Really Make Infrastructure Management Easy? No. There's a couple of caveats. The first thing is TLDR, yes it can, but it's easier to have this talk title than Can Python Really Make Infrastructure Management Easier, because not many people would have came to that talk. This talk has sort of evolved even further in the past few months. It's now actually really called Modern Infrastructure as Software, but it's about Pulumi. So my name's Paul Stack. I'm Stack72 on Twitter. I work for a company called Pulumi. Everything you see here today is open source. It's free. You do not have to pay for it. It's not a sales gig. But if you do buy it, it will help me feed my future children. So please do. Future children. Okay, so we're in the era of the cloud transition right now. And we have a few different versions of infrastructure in the wild. And I'm going to say V1 infrastructure is pretty much people have picked up what they had in an existing data center and moved it to the cloud. It's very N-tier style architecture. There's VMs, there's database servers, and you're not really using anything connected, anything different. You know, it's just a bunch of compute, and those compute are talking to each other in a different way. Then you have the people that are in the V2 infrastructure that have moved on, and they're starting to be less monolithic. They're maybe starting to take advantage of containers. They have a little bit of public cloud, a little bit of private cloud, maybe even a hybrid. They're taking advantage of everything that's dynamic in the world right now. They're starting to integrate tooling into their clouds. They're starting to integrate all these different pieces in. And then you have, I'm going to call them the trailblazers, the V3 infrastructure people. So they are fully dynamic. They are very connected. They're running containers. They're running serverless. They're probably running orchestrators. They're using machine learning. They're using different tools in order to feed different pieces back. And this is the state of the way that everyone tells you the world has to go today. That we're heading towards this microservice-based architecture, and this is how people build things. Now, there are lots of tools in this space as of today. Okay, and the tools are very good. And the tools do a lot of different things. But because, unfortunately, they don't take advantage of actually programming constructs, they have not been able to offer a more of a realistic approach into actually what's happening in the world. Now, Pulumi is a tool that very much targets V3. Okay, we have created a number of APIs which make life much easier for people deploying these types of systems in production or in whatever environment they want than some of the other tooling that's available. Now, we like to say it's... Where have you gone? There we go. We like to say Pulumi is modern infrastructure as code. Okay, because it's built on languages, we like to say that you can actually, you define it in your declarative way that you would actually tell it the desired state, but then it's written using imperative languages. You can review it, you can test it, you can version it like everything else, but you can build it up into your CD pipelines because you can start to run tests in different ways. Now, as it uses common languages, and I'm going to call them common languages, and the languages we support today are Go, Python, TypeScript, JavaScript, all of the .NET Core stuff, so that includes C#, F#, and if you hate your life, VB. Sorry any VB developers, but why would you write in VB? I'm joking, I'm kidding. So, and what we like to say is that different teams can actually take advantage of using the languages that they know within their team and then provide different APIs that other teams outside it can use. So software developers for years have been using APIs. Okay? They've been building and writing code against packages that they've downloaded from the internet or packages that have been shared from other places on the internet. So they're used to using this black box style approach where they know what the API and the shape of the API looks like. So we're starting to enable the same thing to happen within the operations world. Okay? Boring. Okay, so I told you it's not a sales talk. I don't really mind if you don't buy it or you don't like it. It's new. It's a new way of thinking. So Pulumi has built on top of the providers that are currently available for all the major clouds, but then we actually add different libraries on top so that you can actually do things in a simpler manner. And then across the top of all the patterns and practices libraries, we have developed these systems called Crosswalk. Now, Crosswalk, I will show some demos of this, are actually very simple APIs that will allow you to build well-known defaulted architectures. So for those who are in Amazon, you know that a VPC is made up of a VPC, an internet gateway, a route table, route table associations, and all of these different pieces. Now, of course, if you have to have multiple people within your organization bringing pieces in and up, or up and down all the time, they're going to forget pieces of it, and sometimes pieces of what is happening will fall through the cracks. Now, if you go to the AWS console and you create a VPC, it's a very simple wizard that will stop that from happening. So what we're trying to do is create that same style of being able to build on top of the well-known libraries that are available in order to do that. So we have one for AWS. But more importantly, and here's my sales pitch, you can come to my talk this afternoon and see this, I am actually going to show how we do this with Kubernetes, because the Kubernetes ecosystem is massive. Who uses Kubernetes? Who really needs to use Kubernetes? Kidding, just trolling. So it's there, right? It's there, okay, it's there. Now, Pulumi integrates with a load of different things, and it allows you in different languages and CI/CD tools and environments and all these different things. Now, let's just go to actually seeing what it does. That's the salesy pitch done. So you can declare your state, as I told you, in exactly the same thing as Terraform, okay? But of course, it looks different because it's in real code. You can include conditionals and loops in real code. You can have your multi-provider workflows exactly like Terraform can. And you can start to build up and package and reuse all your different pieces just like Terraform can. Now, here's where we start to differ. We can write tests. We can have a tested approach to all of our code within the same language, within the same application. We don't need supplementary tools or wrapper scripts around it in order to bring these things together. And my favorite piece of the lot is that we can have advanced orchestration. We use code. Because we use code, if you have an API or you have an SDK, you can talk to those APIs or those SDKs. This is a very simple example right here. What it does is a 3 replica canary deployment of your Kubernetes app. After it has been deployed, the 3 nodes, it actually calls the Prometheus API. And it calls Prometheus API for a check that you have written inside your code, which says check app metrics. Once check app metrics has been satisfied, the rest of the 10 replicas within your Kubernetes deployment will actually continue out. Okay, so it's not, let's do step 1, let's go and check our metrics tool, let's go back and do step 2. It's, let's just run step 1 and let step 1 run to completion. So it's very different here. And then lastly, the big thing that we differ on is secret management. In the world today, we suck at secret management. Honestly, we may think we're good, we're not. We continually leak systems all over the place, and we have secrets all over the place. I used to give talks where I told people, hey, passwords are sometimes in plain text, but you should have another thing that runs after it and then changes the initial password. The reason I used to tell people that is because I didn't have another way. Pulumi actually has a secrets engine built in. Okay, and this is, again, part of the free tool, where you can do it in 2 things. Firstly, you can set your configuration into Pulumi using the secret engine. And the secret engine, by default, is Pulumi KMS. It's built on top of KMS and Amazon, or you can support the other clouds plus HashiCorp Vault, which I think you should use because it's awesome. Okay. Or secondly, and I can show you in a demo, that there is a part of the secret engine where you can mark any property that comes back from the API as a secret, and it will actually encrypt it in the state. So we differ a little bit more because we have this idea of an organization is broken down into projects, and projects are broken down into stacks. For those who actually have used Terraform Workspaces, this is a similar concept, but in Terraform you're not actually forced to use workspaces because there are some people in the wild who do not like them. Somebody sitting across the front row. But for us, it's just a bucket of resource IDs and some states. Okay? It allows you to have different people, different environments, everything running on the same code, but their state is segmented. Now, people traditionally used to say that stacks are for environment. So you have your dev environment, your test environment, your staging environment, production environment, whatever. I actually will push that a little bit further, that each individual developer can have their own stack as well. So they can bring things up and take it down and not actually have to independently break people. So let's just go and look at some code. It's easier this way. Oh, great. You can see what I can see. Awesome. OK, so can you read me at the back? Awesome. And I'm not even going to type that, so it's easier. So let's just make a demo, OK? So demo 1. Now, Pulumi is a CLI. It is not a remote execution engine, so you have to run it from either work machines or what I would suggest better is a central location that actually controls and has the correct access rights to do it. But today I'm going to say Pulumi new. Okay? Pulumi comes baked with templates that are built in that are cloud specific and language specific. So today we're going to choose AWS TypeScript. And it'll ask me some questions. What do we want to call it? Demo 1's fine. Description's okay. Stack, I'm just going to call it dev. And lastly, because it's in Amazon, I'm actually going to say EU West 1. So you actually take it and it will ask you where do you want to deploy this stuff as like a thing. Now it's JavaScript, so it's going to take about 15 years to download every package on the internet. But it does finish a little bit faster than you would expect. Okay, so it's just doing some extra crap. And it's JavaScript, right? And this is what happens. So what we have right now is we have a pre-scaffolded project. Okay, so demo 1. Okay, and it has our node modules, of course. It has a git ignore, it has package.json, it has package lock, it has a pulumi.yaml, but then it also has a pulumi.stack.yaml. So in my case, I chose dev. So each of these YAML files, if you treat them correctly, can be checked into source control as long as you adhere to the secret management, which I will show you in a little bit. And then lastly, we have an index.ts. Now the simplicity of this is always kind of nice. Firstly, it imports the correct pieces. And then we actually declare that we create a new bucket, which is a new aws.s3.bucket. Okay, now everything inside Pulumi is actually namespace. So if I say constant x equals new AWS dot, and then I get all the packages that are available inside AWS. Okay, now of course we can go a little bit further with that, and we can move things around and create our own APIs, which I can show you in a little while. We differ a little bit here than anything else out there. This is a name that is not only applied to the resource within our state, but this is also named as part of the resource itself by default. So we will get a bucket if I run Pulumi up right now that says my bucket. Okay? But we also append a random ID on the end. The reason by default that we do that is that there are lots of operations in the cloud that will not allow you to create before destroy because you're using a direct name. Okay? A launch configuration is a very good example of that. You cannot create two launch configurations of the same name. So you have to auto-name them in some way. So this is what we do by default. Now we can turn that off. We can turn that off by saying bucket, and we can say testing bucket. Okay? And now the bucket will be strongly named as configuration management camp testing bucket. Okay, it's that simple. And then lastly, we can export any IDs that we actually need. So let's just go and run a Pulumi up. So again, what it'll do is it'll check what's it. Now it doesn't create a DAG. It doesn't create the graph that Terraform creates. Okay? What it does is an imperative program, so it works its way down the file. If there are relationships between the objects, it understands that they have to be created first. But it doesn't try and walk the tree, because there is no tree. Okay. So it'll give me an update to tell me what it's going to do, and I can have a look. Now, there is the ID of our bucket. The ID is broken down to be extremely simple. What it is dev, which is the stack name, demo 1, which is the project name, AWS S3 bucket, which is the type, and then the random ID, or the identifier that I gave the resource called my bucket. Now what this means is that it is no way, shape, or form tied to any classes or any modules or anything around. It can be refactored as much as you want. It doesn't matter. Okay, so once it's there, as long as it stays in the project and in the stack, and as long as the ID doesn't change, the my bucket, then anything else can happen to it. It can be renamed, it can be moved around, it can be refactored, it can be referenced in different ways. And we're going to say yes, and we'll roll it out, and it will actually create. Now, I'll come back to that in a second. So I said that we can write like tests around this. So let's create a new folder, and let's call the folder specs. Now, anyone ever heard of BDD, behavioral driven development? So it's like a way that you can declaratively suggest what should have happened in a human readable format that then can be executed as specs. Okay, so we're going to do that style of testing right now with something called Mocha and Chai. Okay, so we're going to create firstly index.ts, and I'm going to say Mocha test spec. So this is pre-code that I've created that will basically act as a test generator. And what it does, you don't need to worry about any of the details except this. For every current file in this directory that ends with .ts and is not index.ts, we are going to run the Mocha generator across it. Okay, this is, for those who are in development circles, this is actually like bog standard how you would write your tests in JavaScript. Okay, and then we're going to create a spec. And a spec will look like, let's say, bucket.spec.ts, and I'm going to say bucket spec. Okay, now the specs look like this, and these are extremely readable. What you can do is you can say, let's come back to the Pulumi dry run in a second because that's something slightly different. You can say, describing my S3 bucket, it should have an exact name. It should be in US East 1. It should have a private ACL. Now, as soon as I start including in my code, if I go to the bottom of my code and I say run tests, then my ID has included straight away my specs. And as part of my code output, I can actually start to run this and do this. So I gave a talk on testing at FOSDEM, so I'm not going to go into the ins and outs of testing, but you can go and check that talk out. So, and then lastly, we can Pulumi destroy. Okay, so see, we have the output here, and we can Pulumi destroy. And if I don't want to wait and see what it's going to do, I can say yes, which will force the prompt. But if I don't want it to do a plan first, I can say skip preview. And then I can actually remove the stack. Okay, so if I don't remove the stack, Pulumi will say, hey, you have no resources there. Maybe you just want to remove the stack because it's just pointless having that stack sitting around. Now, not an interesting demo. It's pretty basic. It's nothing there of substance. So let's create a new one. Okay, let's make their demo 2, cd demo 2, Pulumi new, and I'm not going to ask the wizard this time. I'm actually going to suggest that it should be a TypeScript, and it will again ask me the same questions. Of course, this is an interactive CLI because it's 2020, right? So, you know, there's nothing should be CI and CD proof, but you can turn off the interactive CLI. So we're going to say dev again, and we're just going to say US East 1 because I want to show you some actually like real code around built-in resources. Come on. So we're going to set some stuff up. In demo 2, which should be here, I am going to compute, if it ever finishes indexing. There we go. Compute -1. Come on. There we go. So I've created some resources here. Okay. And the resources I have created are, firstly, we need to go off to Amazon and get an AMI ID. So we have exactly the same style of data sources as the other tool. We have a key pair. Please don't ever hard code your SSH key like this. Please don't. It's not the point. That's why I even said not a real key. It is a real key, but I had to remove it when I gave a demo. We have a security group, and we have an instance. Now, we have a little bit more syntactical sugar than anything else. Like really a little bit more syntactical sugar. I hate magic strings. I absolutely and utterly hate magic strings so much. So we wrote this library or this module in TypeScript, which basically allows you to take every one of the AWS instance sizes and actually just makes it easy to read. And we have the same for RDS and so on and so forth. But I don't know if you saw that we're actually using the power of the language right now because we know that the instance that I have written here, RDS instance type T2 small, is not assignable to an EC2 instance type. So we're not doing anything special. We're using the power of the language runtime in order for us to be told that we have errors straight away. And of course, let's just change that back. And if I removed a property, undo that, I apologize. But if I removed a property, again, we would actually see that we're having a real problem because we're not adhering to the object, the struct that we're, so the strongly typed object that we're doing. Now, I joke about the fact that Python wouldn't be an interesting language to do this. You can do exactly the same in Python, but some of the syntactical sugar, because it's a little bit more dynamic, isn't available as it should be. So we are adding enum support for Python for all of these like syntactical sugar values to make life a little easier. So let's just pretend that I have to somebody has to wake up. I hear an alarm. Let's just pretend that we have to like add a loop, okay, a loop of web servers. Any JavaScript developers in here? Okay, JavaScript, you can do some mental shit. I apologize, but you can, right? So I can say let web servers equals an empty untyped array. Literally, it's like a bucket. You just throw crap into the bucket and then you see what happens. It's perfect for a demo. Absolutely perfect. And I can say for let x equals 0, x is less than 100, x plus plus, and oh my god, I'm in a loop. Okay, a real programming loop. Stuff that we learned many years ago, if it was me. But yeah. And of course, because we're in a loop, we can do things within the loop. So I can say web servers dot push, and I can push every object that is created inside that loop, or inside that array. So right now, we have a web servers, a promise for a web servers collection that is 100 items in size. And then we know that web server doesn't exist anymore. But because I'm in a real language, I can say web servers dot map, which is like iterating in the map. And I can have a small lambda which says x to x dot. And I can pull the public DNS of all 100 servers out. Again, don't create instances that are publicly available on the internet. Please, that's one of the things is, again, this is just demo code. Now we can take this a little further. Right now, oh, I apologize, there's one thing I need to do here. We need to call it web server dash $x because every web server resource needs to have a unique name. Now let's take it a wee bit further. Let's pretend that we have operations people who hate developers. We're going back 40 years now, and those pesky developers are not allowed to create real code without being strictly adhered to within the operations team, because that doesn't happen anymore, right? So we're going to create a file called webserver.ts, and inside webserver.ts, I'm going to say webserver1, I have pre-created it, and I'm moving the key pair and I'm moving the security group. Again, don't create open-bounded security groups. But the most important thing here is I've created a class. Okay, so I have a class called web server, and the web server returns a read-only VM, which is of type AWS EC2 instance, and it has a constructor. So it has name, AMIAD, instance type. And because we're in a typed language, because it actually allows inheritance, you can create like a base class, and then you can actually inherit from your base classes, and therefore you don't have to create these classes that have hundreds and hundreds of inputs. Okay, so this is right now, this is only going to take 3 inputs, and because it takes 3 inputs, it's pretty actually simple to change to. So in my code, instead of a new AWS instance, I can say a new web server, which we'll take web server dash X. That's the name. Okay? And because the name hasn't changed, I am still refactoring the same code, and no instances will be harmed in the creation of this code. Okay? And after name, I can say AMIAD, which will actually be ubuntu.id. And then lastly, I can say aws.ec2.instancetypes.m5 large, for example. And let's just add that. Now, of course, this is not well formatted, but you can imagine how it looks. Just move some stuff around and lint it to your heart's content. Now, my code already knows that my lambda is broken at the bottom because web servers is no longer a collection of EC2 instance types. It is actually a collection of VMs, which under the hood are EC2 instance types. So I can say x.vm.publicDNS. Now I've refactored that into much simpler, much cleaner lines of code that can actually be controlled and packaged. Now, as operations people or infrastructure people, that web server class can be packaged as a pip package or an npm package or a NuGet package and pushed around your organization so people have an API to adhere to. Right, demo 3. We've got like 7 demos. You're going to be bored of this right now. Make their demo 3. Who likes IAM management? Who loves JSON for IAM management? Who really needs a hobby? Awesome. Okay, JSON is another one of these things that I hate. Like, it's a language that has, I'm going to call it a language. It has sort of existed and people have been forced to use it for a number of different things. But it's a pain in the ass. It is literally a pain in the ass. Now, we have APIs. So we can take that pain away from you. You don't need it. It doesn't matter, right? So let's go back to demo 3. Please open. And we can go to index.ts. Let's get rid of this crap. And I can say IAM role. Scaffold for me, please. IAM role. Okay? Now, that's the basis of what an IAM role would be. Can anybody tell me the JSON structure for an assume role policy for AWS? No, because usually we would all go and have to look it up, right? It's just the way it works. So what we can do is we can say assume role policy, okay, which is the parameter that we're creating, and we have aws.iam dot assume role policy for a principal, and the principal will actually be a service which will be ec2.amazon.aws.com. No JSON involved. And that will actually scaffold the correct assume role policy. Now, let's pretend that we're in Kubernetes world. And we need to attach extra policies to our role so that we can actually use that in Kubernetes. So if I say IAM role extra policies, so you usually have like a list of policies like this. Okay. And then if you really need some more, you can say aws.iam.manage policies dot, and you can choose any one that you want because they're all there. But we can loop. Okay, this is the beauty of it. So I can say for policy in manage policies. Yep. Oh, I apologize. For const policy and manage policies, I can say let count equals 0. And I'm glad I spelled that correctly. You would be surprised how my spelling is sometimes. Equals new aws.iam dot policy attachment, role policy attachment, I apologize. And it will be my role dash dollar count plus plus. And in here, I have to say policy ARN is the policy, and I say role is the role. Now, even if you hate the tool, even if you hate the language, what I'm trying to show, you have to see that that is a simpler approach to IAM management than anything else. And we have this idea where we have strongly typed documents, okay? So if I actually say const IAM policy, which is of type aws.iam.policy document equals that, okay? Now in here, we know a policy document adheres to a standard specification. It's nothing new, we know that it's there. Okay, so the first thing is I can say is a version, and I can choose either of the two versions, but if I change something, we'll immediately see that the version is not the correct version. Okay, so let's undo that. And then lastly, it's actually, policy is actually a list of statements. So it is a strongly typed object of a collection of statements, and a statement can have a number of different pieces. So it can have a SID, it can have an effect, it can have, oh, that's why it's not working. Yeah, it can have a principal, it can have an action or a not action, and it can have a resource. Now I can take that exact document, and it will even tell me what's missing from it, and so on and so forth. You can't have empty things on effect. So we can say allow. Principal can be star. And immediately, The IDE has told us before we've even gone to our CLI that something is actually useful and available. Okay, number 4, secret management. Make their demo 4. How am I doing for time? Loads of time. You have at least 3 more hours of this talk. You do. New. So this time I don't need AWS. I just need a new TypeScript project, which I'll just actually just scaffold some things together, and we're just going to create a small thing. Now, Terraform has created this package called the Random package. Random package is one of my favorite packages for demos. It really is, because it allows you to do things like random passwords and random pets and so on and so forth. Now, I just finish here, and I'm going to npm install at pulumi/random, because everything has its own package and it's deployed as its own package thing. Now, if I go in to my code, demo 4, there's only 8 more demos. If I say import star as random from at pulumi/random, and then what I can say is I can say const my secret value, secure value, equals new random.random password, and we're just going to say my password. And I'm going to try and adhere to good password policy, and it's going to be length of 30, and it's going to have special characters true, and we have a password here. Okay. Now, if I took that and I outputted it, it would be in plain text on my browser, and I'll show you. Okay. So if I copy the same code and I say my secure value 2, and I make it password 2, I told you Pulumi has this idea of a secrets engine built in. So I can go into the custom resource options of any resource, and I can say additional secret outputs, and I know that the result of the random password comes out in a parameter called result, and I can say that. Now, if I say const export, export const password 1 equals my secure value dot result, and I can say the same, and I can say 2. Then if I go and actually run Pulumi up, and if I say yes and skip preview because we don't care about this, then what we'll actually see is we'll see that the first value comes out in plain text, the second value actually comes out as a secret value. Okay, now the most important thing here is what it looks like in the state. We have state, okay. As per the last talk, unfortunately we have state, that's just the way of the world, right? But I can look at the state at any point because I can Pulumi stack export. The state is a lot simpler, okay? But the interesting thing is we can see 1 as a random, an unsecured value, but we can see the second result is actually stored using a ciphertext. So, and only the people who have access to this stack and this project will be able to allow their Pulumi app to decrypt it. Now, I can also do it in a different way. Pulumi config set, and we're going to say it's root password, and we're going to say it's my password 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, because I'm trying to be secure. And if I go and actually have a look at that in my source code, if you do something like that in Pulumi, then that will be in plain text in your Pulumi file. I told you that these files, if you adhere to them correctly, can be checked in. Okay, so instead of running that command, we can run exactly the same and mark it as a secret. And because we can mark it as a secret, it will actually generate it using the secure string, again in the format that is actually designed inside the state file. This is now 100% safe that you can check into your source control. Doesn't matter. It's a ciphertext that's built on the project, the stack, and all these different things. I can't even copy that to another project because Pulumi will be like, that was not designed by this project. So it's broken down into something much smaller. So secret management is something that's actually extremely important. And I can show you why it's so important here. Because, so I have AWS account cleanup. So I have a Lambda I wrote that cleans up my AWS account. And I have like a load of different things in here. But the most important thing is that I have a CI account. And I have a dev account. And both of them are all actually in like, I can store those credentials actually in my system because they're actually secured and used in a different way. So, demo 5. We're getting there, we're getting closer. So I promised you that crosswalk. Crosswalk is our opinionated APIs across the top of different pieces. Now, this may worry some people because it actually makes life a little too simple. But again, I'm going to scaffold an AWS TypeScript example. It's okay. He's a Python developer, I can tell. I'm joking, I'm kidding. Okay, so crosswalk for VPC, crosswalk for API gateway, crosswalk for Lambda, crosswalk for all these different things are making life much easier for lots of different people within the Pulumi ecosystem right now. A lot, okay? Just give me demo 5. Come on. Come on. There we go. Now, creation of a VPC, I told you, has many different resources. Many different resources. And of course, if you want to add in like a number of subnets, then you need to do lots of extra different things that goes with it. Now, if I say AWS x-VPC public CIDR block, that is the code that will scaffold an AWS VPC with a default public subnet, with a default internet gateway, with a route table, and a single route table association. Anybody care to argue that that's not cool? For me, it's so simple, right? In fact, you don't even have to pass in a CIDR block. You can just pass in a name, and we will choose one of the supernets that are available for your private VPCs. Okay, now we can take this further. And where we can take it further is we can start to do AWS X. So let's pretend that we actually need to create a more interesting VPC, that the first thing we want to do is get all of the availability zones in the region when we have to deploy the VPC into. Then we're going to create a CIDR block, a top-level CIDR block. We're going to create a number of availability zones based on the length of the VPC. We're going to do the same for the NAT gateways. But I'm actually going to use something super simple here in order to develop my subnets. So what that will do is that will create a private and a public subnet for every one of the availability zones. And every one of the CIDR blocks for the subnets will be a /24 size. Okay? Taking away that hassle, taking away all the different pieces, and it will do all the route table associations that go with it. We even went a little further. We were able to show in a proof of concept to a potential customer that VPCs that need to be peered are the bane of everyone's life in Amazon, especially when you're trying to script it. So we created this idea where we had a VPC class. Okay? Now, inside Pulumi, you can create your own API, and as long as you extend what's called the component resource, then you can actually group as many pieces of information you want inside that API. Now that API, it sets the VPC, it sets the internet gateway, it decides whether you need to turn on or turn off Route 53, it does all the VPC DHCP options, it does the CIDR calculations, it does the subnets based on the CIDR calculations, it does the route tables, it does the route table associations, and blah, 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 blah. Now, of course, to give that to a developer and say, hey, create me 2 VPCs that you can test against, and then peer them together. Most of them, because they don't do it on a regular basis, would have to Google their way through it or Stack Overflow their way through it. Whereas you as operations or cloud infrastructure people can give them a very simple, nice API across the top that allows them to do it. And because it's a strongly typed object, so we have an app VPC and we have a data VPC, we can say app VPC.configure peering against the data VPC. And inside the configure peering method, so it's like an extension method, it will actually do the VPC peering connection, it will work out if it has to auto-accept, it'll do the routes, the route table associations, and blah, 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 blah. So for developers, this is super simple. they don't have to worry about the pieces that they're not strong at doing. You're taking away that pain that allows them to be much more productive, much faster. This is what our goal is as infrastructure people, ops people, right? We need to adhere to making life a little better. Okay, I'm almost done. I'm actually not, but I am, so it's fine. And then we can, and I'll just give a sneak preview into one of my talks this afternoon. You can actually give developers the simplicity that will create a multi-cloud Kubernetes cluster in Amazon and Azure in 14 lines of code. And the only reason it's 14 lines of code is because we're exporting the kube config, but developers that can then take that kube config and start to deploy their applications based on top of it. Okay? These are all public examples. So there's github.com/pulumi/examples, and everything is there. Now, Docker. Anyone use Docker? Yeah. I'm not going to give my opinions on it, but that's for a conversation over a beer, I can promise. Docker is one of those things where you have sort of two external workflows, okay? You have to do the Docker build, and then you ingest the Docker build as part of your work. I don't believe you need to do that. So of course, we have created an API that actually will do a Docker build. So this is in Azure, okay? I can never leave out the Microsoft people because I always get told off for favoriting a specific cloud. So this is going to deploy an application, a Docker container in Azure, okay? You need a resource group. There's people in the room going, Azure, really? So the more interesting thing is that what you do is, here is an application folder called Node app, which is here. Okay, which has my Docker file, and it has a really sophisticated app, like super sophisticated. But the more interesting thing is that as part of my Pulumi application, we say a new Docker image pointing to the Node app folder, and it will actually interact with Docker under the hood and include the Docker build as part of your Pulumi application. So as your CI pipeline, you don't need two different processes. It's one process that does the same thing. And then lastly, there's like some serverless stuff I can show, okay? Serverless stuff is always a very interesting demo because people are like, what? But it's interesting because we can do a lot of very cool things with it, okay? So first thing is we have like a publish folder. We just point to a folder on disk and it'll take care of it. Then we have a DynamoDB table. We have the IAM role policy. And we have a Lambda function. We only have to put the Lambda function at a folder location, and Pulumi will zip it up, and it will actually take care of deploying it for you. But we can start to do interesting stuff. So we can include real code, real application logic code in our Pulumi apps. So here's a Swagger spec. Here's a Swagger route handler. And then in my actual API deployment, I can push in these different pieces. A better example, which we'll show you, will be where's my Twitter? Slackbot. Okay, so we wrote a Slackbot, an example for a Slackbot. Okay, so we have a DynamoDB table, an SNS topic, we have some classes, so some strong objects that we pass around. And we actually will scaffold an API gateway, and each of the routes in the API gateway has the application code embedded in it, which Pulumi will understand that that is actually a Lambda. It will create the associated Lambda, link between the API gateway and the Lambda, and it will actually really deploy in it and actually take that code and really push it up. So we're actually bringing together these teams who have the motto of you build it, you run it. So if they build it and they run it, why do they need these two different ecosystems? Why do they need an infrastructure ecosystem and a dev ecosystem? They're completely separate. They're completely not separate things. So I'll go back to some slides because I've bored everyone with demos. Policy as code is a big thing for us. Anyone heard of HashiCorp Sentinel? Yeah, a few people. Allows you to write specs to check your code and check everything is working. We have embedded that same style process where you can actually create policies in Pulumi. Again, it's part of the talk I gave in FOSDEM, but you have a Pulumi preview, a Pulumi validate, and a Pulumi update, and it will not actually deploy the code unless you actually adhere to the security policies. It'll actually be probably part of my system tonight. or my talk this evening, but you can write policies that look like this, where, for example, everything must have a cost tag, because it's the bane of my life when people actually don't put cost allocation tags in resources. And then you can stop your company doing crappy stuff on the internet, like having open security groups. And then we can actually start to say that the logs on an S3 bucket must be enabled, and that they must be like kicked out in less than 45 days. And we can even say adherence to GDPR. If our application needs to adhere to GDPR, we can write a spec that says, do not allow this to be deployed in US East, okay, or anywhere in the US, and we can actually write that code that does that as well. And there's loads more. You can even do things like, if you have sysadmins and DBAs that don't allow you to run the latest databases, you can write a spec that says it must be less than a specific version of a database because it hasn't been tested and gone through compliance training. So there's like a whole different way, but we really believe that we're starting to be this connected way of being able to easily create like infrastructure in the cloud, and we're big fans of the movement that we're trying to do with regards to Crosswalk. So thank you so much. If anybody has any questions or wants some stickers, I have a lot with me, and I don't want to take them home, so please come and take them from me. So thank you and enjoy the rest of the day. Thank you, sir.
There's a break now, and after the break, basically 20 to 12, we start again with Eric. Any questions for you can comment on the polling line.
Yeah, anybody has any questions, just come down. It's easier. It's easier.
Just come down because there's way too much noise already.
En hoe die dat
guess you're ready.
Sure. People are back. Looks like we lost about 5%, but it's okay.
Lost some. There's still a couple in the other room.
Yeah.
I closed that door, so they're gonna.
Okay.
Come back.
That's fine.
I've been giving talks here for 8 years, 9 years.
8 years, something like that.
So, give a round of applause and
Good luck.
Thank you. All right. Hello. Thank you for coming back from the break. I know you have many entertainment options out there, and I'm pleased that you chose to spend this with me here. My name is Eric Sorensen. I work at Puppet. I've been working at Puppet mostly on Puppet itself for a long time. I've been there since 2012, and I ran Puppet and CF Engine at scale before I started working on them. So I've been in this config management game for quite a while. And it's mostly been pretty great, but I got an opportunity to jump to a new project last year that focused on cloud native infrastructure, and I sort of jumped on that. It was pretty scary, I'll be honest. I had a lot to learn, and I had some trepidation that I wouldn't be able to get up to speed. I was frankly a little afraid that I would be the punchline of like an old man yells at cloud joke. But I did the best I could and learned a lot from the people around me, and this talk is sort of a summary of the things that I've been looking into and investigating over the past several months. I really want to take a moment here to acknowledge that I'm building on a lot of work from a lot of different people. There are a few spicy takes in this talk, I'll be honest about that, but overall I'm pretty just overwhelmed and awed by the amount of brain power in this community, and I'm humbled to be able to contribute to it in any way I can. I do have one quick work plug before I dig into the substance. My current project at Puppet is sort of adjacent to all this configuration management stuff. I've been working on a service that's called Project Nebula. It started out as a way to do cloud native continuous deployment, but our users are finding that it's useful for ops workflows as well. So we're exploring what it would be like to build sort of like a if this then that sort of service for doing operations kinds of things that are more event-driven, so they can receive events and act on them in a way that users define. If that's interesting to you, please come and talk to me over the next few days. I'd love to hear what you would do with such a thing if you had it, or if you were building or working with similar tools. And that's all for the plug. Let's dig into it. So the talk's called Cloud Native Configuration Management, but we should probably start off by asking, what does cloud native even mean? This is a fantastic book by Justin Garrison and Chris Nova. There's a concept that just definitionally I want to pull from this in order to lay the groundwork and frame up the section. In the book they describe what cloud native characteristics are as being things that run on a platform that means that you can interact with it programmatically. It has agility, meaning that you can make changes easily. It's operable, that is, you can control the app from inside of the app. You can tell it to reload or restart itself. It has observability, meaning that it's designed to emit, to exhaust events and log files and traces in consumable manners so that we don't have to treat the application like a black box and poke at it from the outside. And with all that said, you may ask yourself, doesn't that just mean it's architected well? You'd be right to a large extent. And so the question became for me, what do we know about what good architecture looks like here in 2020? I went back to this paradigm. It's the 12-factor app. I had originally written 12-factor with an E because I work on Puppet, and I've just been doing that for a really long time. And I corrected it to say factor, the way it ought to be spelled, F-A-C-T-O-R, and it just looked completely wrong to my brain. So I'm just going to go with this. It's factor. So the concept of 12-factor apps came out of Heroku. It's an early platform as a service company. It's still doing some pretty cool stuff. Adam Wiggins was the person that published this paper in 2011. Describes all of these factors that go into building modern applications. There's some interesting tidbits in here that are that are related to this discussion, I think a lot of these were pretty prescient. They were pretty early for the time. Lots of things we take for granted today were laid out in this paper. It wasn't at all obvious back at the time that they were the right way to do things. For example, the idea of declarative automation. We've heard this part before. To have a clean contract with the operating system. That certainly wasn't the case for the applications that I was running in 2011, where you'd have to work in concert with the developers to make sure the right version of Ruby was installed on the operating system, and woe befall you if, as Rin was talking about earlier, there's some application version that got upgraded under the hood. And so this was really before containers came about too. These apps ought to be built for the cloud. That is, they should be repeatably deployable and operating primarily over network APIs, and they should enable this continuous deployment, continuous delivery types of cycles. So this shows up in the factors as build, release, run, and around having parity between your development and your production environments. And this is pretty forward-looking. It predates all the stated DevOps reports, findings, and all of this sort of research that's come out from folks like Jez Humble and Nicole Forsgren since then around how having continuous delivery built into the way that your business works actually makes the business work better and produces more money for your company. And there's some specific things in 12-factor about configuration. There's a litmus test for whether an app has all of its configuration correctly factored out, is whether you could make the code base open source at any moment without compromising your credentials. And if not, you should probably rethink how you're doing that. Pretty interesting. I wouldn't say it's 100% infallible though, so these are some of the more characteristics. Has anybody found here that using cloud applications has really eliminated the need for systems administration? I don't think so. It has changed from what we need from systems administration, so it's worth examining what exactly is different now from when it was from the last 10 years. In my opinion, there's a few trends that are actually step function different from what came before. We can argue whether these are the right ones, whether there's more or less over beers, but I have the microphone, so this is what we're going with. The first one is ephemerality. So this means a shorter lifespan. Ephemerality just means a short-lived life cycle. But it's if you have your config management camp bingo card, you can now fill in the square where it says cattle, not pets. It should be the center, it should be a gimme, but this is the idea of ephemerality is you can no longer care about any single system. You have to be able to treat them as not as precious snowflakes like Rin was talking about earlier, but around part of a larger system that are easily replaceable. Justin Cormack has been talking about systems when he was working on the unikernel stuff as going from cattle to insects, because their lifespans were even shorter. They're highly numerous. They're very it's less about which server produced a failed login, but whether the system as a whole is healthy. I don't think the real world is going down to those minute life cycles like you think of an insect being, but the life cycle is now tied to the application release cycle. The next one is about cardinality, and this is something that Charity talked about here last year, and it's been beating the drum for quite a while, that these events have characteristics that you're interested in, and it's not about what server they came from. It's about how fast they're coming and whether you can dig into the information without having a predefined notion of what it is that you're looking for. The interesting bits of data across these distributed systems tend to have high cardinality, or the idea of like the user ID is going to have a low degree of uniqueness across your data set. Our infrastructure really isn't traditionally set up to handle tracing a single user's transactions across a number of services, but that's the place we need to get to. Next important principle is around immutability. You can't change the state on these running systems, particularly true in container world, but in general, we want to get away from the idea that we're, and this is difficult for me to say as I work at Puppet, and we've kind of made our bread and butter off of this for a long time, but the idea of running an agent on a system and having that agent make live changes to the state of the system is a no-go. We just can't do that anymore. At Puppet, we've sort of been shifting away from doing agent-based stuff to more agentless kinds of operations, still trying to provide some of the same model-driven approaches and reusability around modules, but to do that in a way that doesn't necessarily require a long-running agent on the system. Sometimes there's no system to run an agent on if we're talking about a network device or API endpoint, so that idea totally has to change. The paradigm shifts to, if we want to change configuration, we change it upstream in the Git repository, build a new system, and deploy that new system, tearing down the old one. And yeah, I think that's a pretty different approach. This one I couldn't fit into this same grammar, so I'm sorry about that. But it's the idea about having a declarative data model for the applications that we're configuring. Brian Grant was one of the early Kubernetes developers. He wrote an awesome paper that's called Declarative Application Management in Kubernetes. If you haven't read that, I highly recommend it. We'll talk more about it in a minute. The central point relating to this topic is that configuration for these tools should move beyond code and back into the data. The quote from it, and I'm sorry, I'll just read this part. "We do not want to express configuration as code or some other representation that's restrictive, non-standard, or difficult to manipulate." So this is a concept that is probably familiar to Puppet folks, but the Kubernetes philosophy goes even further than that, in that it consumes YAML. So in Puppet land, it would be like if you were writing catalogs directly instead of writing manifests that became catalogs. So what's the outcome of all of that list of properties as it relates to config management tools? Last year I talked about this evolution from infrastructure as code. I think this is probably preaching to the already converted here into infrastructure as software, which we've talked about a little bit already today. Pulumi obviously is very heavily into the infrastructure as being representable as actual application code, which is good, but I think it comes with a new set of problems, like you have to learn test frameworks in order to understand, in order to reason about your infrastructure. But if we're moving beyond the provisioning layer and moving into serverless architectures where there's no provisioning step, maybe it's better to think about being the infrastructure represented as a data layer that doesn't have code per se in it. So maybe infrastructure as data is the next evolution. Kelsey Hightower's been talking about this a lot recently. He did a great podcast on the Go Time podcast where he talks about infrastructure being representable as data. The abstraction moves into the runtime is the way he put it. And implementation details, whether that's a Kubernetes controller or the cloud service, are not really visible to the user. So you're manipulating data and feeding that into the runtime, but that's a fundamentally different situation than authoring Chef or Puppet code. You still have problems though, like how do you feed the right data into those APIs? I think the tools that we use have been trying to change as a consequence, and my hope is to help make sense of those changes in this talk. Incidentally, it ended up that this is a tour and a preview of many of the other talks that are going on around the conference. So I'm going to try to point out where people are giving more deep dives and more specific tool talks around this. I may have missed somebody. If so, I sincerely apologize. Also, if I've gotten some details wrong about the thing that you have been working on, that is entirely my fault. I've been trying to, like I said at the beginning, come up to speed on these things. I guarantee you I've not gotten everything right. In most cases, I've gone through the tutorials and gone through as much online documentation as I can, and I do have some comments about that, but I'll save them for the individuals, save them for the end. Yeah, apologies if I miss anybody, and hopefully this will provide sort of a guidepost if you're trying to figure out what to do over the next couple of days. There's some amazing talks that'll dive into some of the things that I'm going to talk about. And if you recall, I mentioned Brian Grant's paper a minute ago. In it, it has a list that has a link to a Google spreadsheet where people could sort of crowdsource and register their own tools, and so I found out a lot about these. But I realized as I was scrolling through them that there is sure a lot of them. Like, why are there so many? Why do people keep making new tools? Like, it's still going. I think it stops at like 120 or something like that. And these are just people that cared to go onto the Google spreadsheet and register their stuff. I'm sure there's more out there that people haven't found this particular resource. But I think that this proliferation is a consequence of people trying to come to terms with this new concept of infrastructure as data, maybe without even really realizing that that's what they were trying to do. And so they made some new stuff. So Marcel and I were talking about this last night. This is a concept called the configuration complexity clock that I'll talk through really quickly. Gareth Rushgrove actually introduced me to this. I found this really apt, and so it's sort of the framing for how I'll talk about the tools in this talk. Cedric Charlie also wrote a great blog post that's called the configuration complexity curse, because we're doomed to repeat the cycle over and over. The way it goes is that if you're writing a new program, you start off with some hard-coded values that you just wire them in there. Over time, you have to extract those so that it's more reusable. So you get to the idea of having these configuration values, and so they become parameters, and other people can use it. You might have some schema that get deserialized into configuration. But after a while, the application that started out as a late-night hack has become a key part of the business, and the data injection is complicated enough that it needs its own business logic. In Mike Hadlow's terms, he calls this building a rules engine around it, sort of like the node classification stuff in Puppet, or the attribute system in Chef. And then there's some things that you still can't do quite right in that, so the configuration now has evolved into its own DSL, and then you as the developer spend more time working on the DSL that people use to configure the values that get injected into the system than into the system itself. And then at some point somebody goes, this is all way too complicated, we have to throw the thing away and start over again. So you get back to, and then the cycle begins again. So with respect to cloud-native configuration management, I think it's useful to make a sort of taxonomy and map where these different tools have landed around the clock. But the framing is going to be slightly different. The 12 o'clock is sort of raw config, writing raw. You can just slam in your YAMLs into the configuration. I don't think anybody really likes to do that, and it's not particularly interesting from a tool standpoint, so I'm not going to talk about that stuff. The equivalent to those config values are this set of tools that are really generators, where they take input, combine it with some kind of template, and then produce a static customized output, which you then feed into the remote APIs. And there's some interesting work going on here. These are generally neat because you get an intermediate representation that you can then do cool things with, like check it into Git, trigger GitOps workflows off of that resultant configuration. You can do diffs and comparisons over time. You can validate that and make sure before you actually go live with it that it's going to work. And then the next level is sort of around a set of front ends, where this is the rules engine in the original, but this is an application that you're interacting with that is doing the behind the scenes work for you. And then there are, in fact, full DSLs. At some point, that complexity catches up to you, and people move into either a domain-specific language, or maybe at the 10 or 11 o'clock, a full programming language, like some of the things that we've seen today. I'm going to cover a couple of noteworthy examples, and this is by no means exhaustive, or there's plenty more stuff here. I apologize if you have something that you have been working on and care passionately about that I haven't covered. There's a lot. So let me dig into it. We'll talk about generators first. So we have a Capitan. Has anyone heard of Capitan? Who's using it here? Looks like there's about 10-ish people. I'm going to do quick hand surveys, and I'll read them back because not everybody can see everybody. Plus, it's being recorded for posterity, so that's what that's about. Ricardo Amaro is going to be talking about Capitan, so if you find this interesting, please go look up his talk. To me, Capitan is interesting because it uses a version of a tool called reclass as the source of truth for injecting values into the templates. Reclass was originally written by a guy named Martin Croft, who goes by Mad Duck online. He may actually be here somewhere, I don't know. It's started life as an external node classifier for Puppet, and then became a dynamic inventory source for Ansible, and it serves a similar role for Capitan. Reclass is really powerful because it allows for this composition and inheritance of different values. Capitan then injects the values into Jinja 2 templates or other kinds of, JSON it to produce configuration that you then feed into your system. Like I said, that allows for some nice properties, like it compiles them into neat folders, and then you can perform Git operations, revision control, and those sorts of things on those intermediate artifacts. Another tool that's similar to that, I'm going to give a shout out to Lee Briggs, who's been talking about this problem for a couple of years and has some very good blog posts on his blog about the subject. His writing informs a lot of this talk, in fact, and I really recommend checking it out. Lee tried a number of the tools that were out there, but nobody had quite hit the niche that he was after at the time he started writing this, and the upshot, in his words, was, oh shit, we're going to have to write something. Create uses sort of a two-pass system that builds up YAML from templates and JSON it. In the code example I have here, the top half of this, I get to use my cool green laser pointer now. The top half of this has the definition that needs to be met, and it's underlined in red squigglies there because it's failing the definition that it has provided for those things and generating errors. The bottom half is the actual configuration that gets blended together to make sure that it passes validation. And JSON, it has some nice facilities for manipulating these kind of data structures. So if you can see on lines 2 and 9 on the bottom, there's this plus syntax that's like a merge. You can also do deep merges so that different levels can contribute different keys inside those hashes. When you run the command line, it outputs YAML, and again, you can check that in or feed it into kubectl. Next up is sorry, the builds are confusing to me. I just did those last night, and I probably should have left it be. Next are some front ends. Tanka is a tool that came out of the Grafana organization. They use it for configuring the Kubernetes infrastructure that underpins Grafana Cloud. It's derived from a tool that's called KSonnet, which you might imagine from the name as the Kubernetes application of JSON. If you have a Kubernetes related tool, it's like a law that it has to start with a K. You had to drop some vowels and start with a K. Tank is interesting. It has a K in it, but does not actually start with a K. They loved KSonnet, but wanted to simplify it. Again, I have to give a little bit of a question mark here, because if you love KSonnet so much and it was abandoned by the authors, why not just pick it up and keep working on it? It's an open source tool, had a pretty active community. It seems like, again, we could maybe give up with some of the wheel reinvention and unify around things instead of splitting everything out. The justification, and I do have some sympathy for this, so it's not entirely like throwing shade on them, but the justification was that KSonnet had a number of levels of abstraction that were too complicated, and they wanted to strip down and make something simpler. So in Tanka, the only concept that you have to work with is around environments is how you build up your configuration. So it provides an interesting point of contrast with Create, which I talked about just before. Both use JSON as the thing you actually write, but Tanka doesn't have an intermediate format that you view and check into Git. It just applies the configuration directly, and it has more of a command line interaction loop where you do diff and apply, and JSON is doing most of the work here. And I do like the idea of authoring primarily in JSON. It seems like it's got some neat properties. I had some trouble getting it working personally because I guess there's a JSON package manager like that. I got a little wrapped up in that, but that's probably just me. I did get it going, and I like the simplicity of just having this one layer of overrides and inheritance. It starts, I have the file system tree here. It starts down at the deepest level of the directory tree that has your configuration in it, and merges upwards until it hits the root. And it tries to resolve all those values into one big JSON object, which is then translated into YAML and fed into kubectl. So there's a talk here. Malcolm Holmes will be talking about this tomorrow afternoon at 2:50. Yeah, and one neat feature about this is, again, as I said, it has a command line loop where you do diffs against it. If you're running a new enough version of Kubernetes, it'll use the server-side diff and show you not just what it thinks the diff will be, but actually has a facility against the Kubernetes cluster API to show you what's different from what is actually running in the cluster, reducing one of those sources of drift. Helm is up next. We have some Helm talks too. It's interesting to me not just because it's used by other tools, but because the evolution of Helm itself is like a trip around the complexity clock. Early versions used special, it's sort of a package manager for Kubernetes. Early versions of it, you see at the top v1, you could comment your shell scripts, and Helm would process those and do variable substitution on them. As you might imagine, that didn't go very far. So they moved to doing Go templating in Helm v2, so you can do these sort of mustache interpolations. The problems that people reported was that the syntax is a little obscure, and again, you still had this kind of mishmash of two different languages where you had to reason about both the YAML that you were interacting with and the values and the actual programming logic that was inside of those the templates there, which can get really confusing. Helm v3. This was originally slated to be in 3.0, and it is not, as far as I can tell. I think it was pushed out for a little bit, but there are multiple templating engines even in Helm 2, and they're carrying that forward into Helm 3. The idea, though, is that you can write your Helm charts in Lua as a little embedded language and use that so that you're not switching back and forth, and the language is sort of compact and understandable enough that you're not spending a ton of time worrying about syntax and how things work. You can just do simple programming stuff there. So again, that's kind of like one tool's evolution that took it all the way around to the place where the ecosystem as a whole is landing. The interesting thing to me about Helm is that the ability to supply values into the templates and into your charts hasn't really kept pace with the evolution of the tool itself. The problem of where did the values come from that get interpolated is sort of left as an exercise to the reader. You can provide them in a YAML file, and there's the idea of a little bit of overrides and inheritance in the values. You can supply overrides at execution time. But if you're used to something like Hyra or some of the other tools that do this, it feels a little primitive, no offense. There's a talk today by Tomas about Helm and GitOps, and a deep dive tomorrow afternoon by Martin Hickey and Taylor Thomas about this. So hopefully I will learn what I've gotten wrong about this run through. But I am interested. It's like Lua is a fun little language, and it's cool to have the idea of like we're just going to go full bore and not try to shoehorn logic into what's supposed to be a data model template, but actually give you the power and expressiveness of a real language. Pulumi, we just had a very energetic talk about Pulumi, so I'm probably not going to cover it too much. The idea is just, Terraform programmers, as we heard. There are multiple language bindings, so again, the idea is that if you want to go full on and interact with it with a programming language, you can do that. Paul both has a talk later today. I think he's doing a whole workshop on Wednesday too, if you really want to dig into it. One interesting thing relative to something like Terraform, which we'll talk about next, is that Pulumi uses cloud-based state by default, and although you can change out where that lives, by default, when you do the Pulumi up, it will store the state that it's managing on their service, and that way you can have multiple people interacting with it, and that's also incidentally how they make money. So it's an interesting quirk of both a technical design plus a business model. Next up, we'll talk about some domain-specific languages. And I probably don't need to introduce Terraform for this crowd, so I didn't have a code sample here. We've got a whole track, basically, here at the conference of Terraform content in B1 105. James Nugent is going to talk about organizing your code, and my former colleague from Puppet, Shobha Shasni, she's going to talk about Vault and Terraform integration. I think Terraform's great. I mean, there certainly is some devil in the details, but the main strength that it has going for it is this provider ecosystem that's just massive. I've been using the cloud service for some of my own projects, and I think it's really cool to have the Terraform plan functionality available as a CI step. If you set up Terraform Cloud with the GitLab or GitHub integrations, it will register itself as a CI for your Terraform repo and run plan whenever a new change gets checked in, and make sure that you know, sort of like you see when you do Travis CI, if it fails a plan, you'll see that in your pull request, which I think is awesome. I've talked to a lot of Terraform users over the past year and a half. I hear some similar complaints about the language that feel really similar to me, of the things that people complain about the Puppet DSL for years. I think the most relevant for this talk is that the language has very strong guardrails around what you can and can't do with it. But sometimes you need to do things outside of the model. In Puppet, people had execs, or you can just, you know, put shell scripts in there. You can do whatever you want with it. In Terraform, there's like null resources and provisioners where you can effectively like circumvent the model and put anything that doesn't fit inside of those things. For example, for the service that I'm working on for the Nebula service, our deployment Terraform has a remote exec provisioner that just has like a 200-line SQL migration inside of that inside of the provisioner line, and there's no resources in there to do ordering for Helm deployments. And I'm not saying that's bad or like we're terrible at Terraform, although we might be, but that when there's restrictions on the tool that go against the way users need to use it, people will find a way, like Jeff Goldblum said in Jurassic Park. Like, life will find a way, and it's incumbent upon, you know, if you really want your stuff to be broadly applicable, to provide a built-in way for people to be able to accomplish what they want. Otherwise, they're going to go around the edges of it, and it push people into weird behavior. Has anybody heard of Gyro? Sort of, Bob, a little bit. Nearly nobody. That circumvents the next two questions about whether anybody's using it in production. It was just announced, to be fair, just announced in October, had a first formal release in October. It's a tool from a company called Perfect Sense that uses it internally for their hosting operations and decided to open source it, kind of clean it up and publish it. These are some examples from the doc. It has a custom DSL and a CLI for interacting with it, for mostly for doing cloud provisioning. I'm not definitely not dunking on the project or the people that are working on it, but I do want to point out that this is, like, number one, a really difficult way to get an open source project off the ground these days, is to take an internal tool, flip the repo to public, and then expect that the world's going to beat a path to your doorstep. Maybe 5 or 6 years ago you could do that if people really caught into it and you had enough of a high enough clout score, people would come and use your stuff. But clout shut down, and the world has sort of moved on into these more foundation-driven open source models, and so it's really hard to go it alone as a single vendor, let alone a single sort of main author open source project, and get a ton of community traction. And they build all of the cloud providers themselves, and I have to ask why. It's written in, as I said, written in Java, and I just don't think there's going to be a huge open source community of people that are going to want to write Java to extend the tool to talk to the cloud resources that they care about. Plus, this DSL is heavy enough syntax, you have to spend some time and energy learning it that you can't then translate to other tools. So it's a question mark for me. Starlark is an interesting project. Starlark is a small dialect of Python. It's kind of a subset of Python that it's intended just for doing configuration. So you get the properties of Python's data manipulation syntax, but you can't write files or manipulate the underlying system. Starlark just runs at the beginning of a program's execution to produce configuration, and then exits and hands it off to the real program. It's interesting because it's sort of similar in concept to, kind of 2 stages of Puppet catalog compilation. The Starlark program, it just runs long enough to hand it off to the real program. Just like in Puppet, you generate a catalog, and then that's handed off to the agent, or for Bolt. It's got multiple implementations, so if your actual program is written in Java or Go or Rust, you can still use the same configuration syntax, or that's portable across programs. And I first got into this because there's a proposal to use this for Tecton, which I have, Nebula uses Tecton as an upstream open source, and we've been working with them. So this is sort of an interesting potential upstream change that might make it more expressive and powerful to write pipelines. Q, we'll talk about Q for a minute. I'm really interested in this. It's a language. Q stands for Configure, Unify, and Execute. And Marcel's here. He's the primary author of it, and is going to give a talk about Q, I think later today or tomorrow. It's a data constraint language. So it merges the idea of schemas and data definition. So a key feature of this idea about constraints is it's not about inheritance. You can't inherit a concrete value from a higher object and then override it. You can only override parts of the schema. So it makes it really easy to reason about why a field got a particular value, which is something that inheritance-based systems really lack, and something that in Hiera we've been, lots of people struggle with. If people have complicated Hiera setups, I've seen things that you wouldn't believe, like people that have 28, 29 levels of hierarchy in their Hiera, and it works for the one person that can have that entire thing in their brain. Everyone else on the team is like, what is even going on here? That sort of thing is not allowed in Q. If you see a concrete value for a field, it's guaranteed that that's going to be the final result. That's a really, really valuable property, and one I wish more systems really thought about. It builds all of these nice things directly into the language. It's kind of a domain-specific language over the domain of configuring things. So I think that it's very cool. I'm interested in working more with it. So let me wrap up with some lessons learned from all of this. The first one is that complexity is going to chase you. The world is a complicated place, and tools that are too simple, they end up shoehorning in that complexity instead of actually managing it. So you end up with YAML engineering, overloading simple things and making them unusable. But if you're writing something new or you're working on something, wait until the last minute that you have to in order to start running and start layering on more things, because it might not be necessary. You might end up with something that's like highly complicated and 2 people use it, and that makes, it's kind of a waste of time. So wait until you're actually getting chased. So the next lesson, constraints and specifications above all else. Whatever you end up using, think about that comment about Q. Constraints are really powerful, and the main win is just that, like I said, it's unambiguous about why you have a particular value. I think people that have used either the Chef attribute system or complicated Hiera setups or dynamic data injection that comes from an external system or dynamic inventory, that comes in from external systems for Ansible. If there's something hard to reason about, that means it's hard to troubleshoot. If it's hard to troubleshoot, that means it's hard to fix when something goes wrong with it. Something goes down at 3 a.m. You don't want to be groveling through that stuff trying to figure out where that value came from. I would say, too, that with apologies to Arthur C. Clarke, any sufficiently advanced YAML dialect is indistinguishable from a DSL. And if you have written a complicated set of YAML and do not have a specification written in your documentation for what fields exist, what fields need to exist, what fields are optional, then you have made things a worse place than when they started. So please do that. You can use something like JSON schema to describe the fields. There's a neat little library that we've been working on called Digo that uses kind of like a Puppet type system sort of syntax, but much simplified in order to do expressive type validation. At the bare minimum, just write a README somewhere that has the list of the fields that you have, because that'd be great. Next one, please. I beg of you, stop making new DSLs. I had a boss who had a sign on his wall that said, rule number 1, there's no new problems. Rule number 2, if you think you found a new problem, see rule number 1. I think about this a lot because as I've been going through this tool ecosystem, I see a ton of wheel reinvention. I don't know whether that's people don't know their history. They think they know it. They think it's something to be ignored because nobody else was as smart as them. I'm not sure. But we end up somewhere on that complexity clock regardless of the problem that you're trying to solve. And so if there's one thing that I hope they'll take away with this is please don't make DSLs if you can. What you can do is take one of these small languages that are made for configuration, like JSON or Q or Starlark, and build the minimum amount of tooling on top of it. Or better yet, again, find something else that's already out there that's close enough to what you are trying to accomplish, and just join forces with those people. People are much more, it's much better to have 10 people working on a project than have 5 people working on 2 projects each. So I'll close with another quote from a paper from Brian Grant and John Brewer, some of the original Kubernetes authors. They said one of the hardest problems that they have is this managing configurations, applying value. In fact, we could devoted an entire article to the subject and still have more to say. It seems like we could devote an entire conference to the subject for 8 years and still have more to say. So I think we're doing the right thing here. All right, thanks very much. Oh, thank you.
So we have 8 nights now, and there's a lot of people sitting in the stairs, and there's also a lot of empty spaces. So if you see an empty space next to you, please move to the middle of the row so people can squeeze in. And for all the Ignite speakers that are blocked in the middle of the row, please get out first.
Online there.
Yeah, I'm on. The one who is down first. Yeah, wait, and then it's
I think I lost the clip.
Let's do that with that. 20 seconds. Wat is er, Jonas? Moet die hoger? Oh. Who does not want to see the Ignite? If you don't want to see the Ignite, oh, you do want to see the Ignite, because most of you are still chatting too much for us to be able to start. Up first, Julien, and he's gonna talk about why this should be called YAML Camp.
So I have a title slide so that my talk will be a little less painful for you, because it is last a bit. It will be a bit less long than if I didn't have it. So I have like 18 slides of YAML for you. The first thing you should know about YAML is that when you have a YAML file, you can actually have multiple documents into it. Don't try to fit that into an actual software, because most of the time you will get unexpected results, right? Then, whether you have a value or you have something called null as a value will be exactly the same for YAML. And basically, if you actually want null as a string, you need to explicitly quote that. We are still in the beginning of the talk. Now we have a list of countries, except that one of them is not a country. So Norway in the top is not Norway, it's actually false in YAML. Because yes and no can be just true and false in YAML. So have fun with that. So when you have a version number, if you just put 1.3.0, it is a version number. But if you just put 1.3 like as a branch name, and then you want to put that in a Jenkins file, something like that, then 1.3 becomes like a float. So you can have spaces in keys. So this is actually a map in YAML, and if you can, you can also quote the key so that you can also have a colon inside your YAML key. So this is really something nice when you try to read YAML. Oh yeah, YAML doesn't care if you have duplicate keys also. So if by mistake you have multiple times the same key, yeah, you will get, I don't know which result. Some software like Ansible will actually warn you like, hey, I have found multiple keys. You can also have like something that's a number as a key, and then the end result will be maybe like 0.50, or it will depend on the parser what you will get at the end. Because most of the languages have maps with only strings at the beginning. Yeah, you can have new lines in key names. So this is a key with multiple lines into it. So if you really want to mess up with your software, you can also do this. So basically, this is a map, and the key has just 2 lines. Yeah. And yeah, of course, you can have empty keys. So this is a map, and the second key is empty. If you want more fun, you could duplicate that empty key. So you can. That one is actually useful. So you can have multi-lines in YAML. So this is maybe the first useful slide you will have in this talk. And sometimes you want to write multi-line, but that it ends up in just one line. So this one is also sometimes useful if you want to wrap your text. So enjoy this useful slide, because there is still some good stuff coming. So now you can decide that you don't want the new line at the end. So this is the same as the previous one. So you have multiple lines, but then it will not end with a new line, which in some cases are quite useful. But sometimes you actually want the new lines, and you want a lot of new lines, so you can add the plus sign. And then you can have as many new lines as you want at the end of your string, which I guess a lot of people want that all the time, right? We are not done yet. 18 slides. Oh yeah, you have sets in YAML. So it means that if you have a duplicate element, then it will not be duplicated in the output. The issue is that then you cannot have values, so it is just a map with empty values. Yeah, you have ensure, so instead of repeating yourself, you can just say, okay, in this case, Ghent is a Belgian city, so Antwerp is a Belgian city, so I will not repeat the map inside it. So in this case, you have the duplication of code. This is sometimes useful. And then you can decide to just do inheritance, so that Ghent is a country in Belgium, it has a TLD, but Antwerp doesn't. But so we take the map of Antwerp and we just override this as TLD. And at the end, you have the resulting map at the bottom. So at the end, maybe you just want to write JSON and be done with that, so that you have the expected output, because YAML is a superset of JSON in the version 1.2. So everywhere you have YAML, you can just use JSON, which is also fix the issue that you know if your file is finished or not. Yeah, so you can just use all those nice YAML trips, but when it's 3 AM and your coworkers look at the YAML files and they say, what is wrong with this, they might not like you anymore. So thank you for listening.
Are you going to talk about the YAML provider for August?
No. That's not possible. Hi. So I'm Raphael Pinson, and this is your yearly reminder about the OGS project. I'm apparently the only OGS developer that's still attending this conference, so I wouldn't miss that. So who am I? I'm an infrastructure developer. I've been contributing to OGS and OGS providers for a few years and contributing quite a bit to Puppet and the Puppet ecosystem. Yeah, sorry. I'm working for Camp, which is a company based in Switzerland, France, and Germany. We do open source development and integration in different fields, GIS, business, so ERPs and infrastructure. And we've been using and contributing to Puppet since 2008 and contributing to Forge. So when it comes to manipulating files in Puppet, there's different ways of doing it. There's lots of different tools. You can do file with static or dynamic content. You can do concat. You can do file line. So which one is the best option? And there's various debates about this. The first thing, and I think it applies to a lot of other tools as well, is that we tend to make the tools want to do a bit too much than what they should do. And this tool should really do the bare minimum and be like a glue. For example, when you want to deploy software, package it. If you want to manage a whole configuration instead of several little bits, the easiest is still to use a simple file. Or use, if you have multiple contexts, a conf.d directory when it's supported by the software with purge or concat or another approach that is similar. But if you want to manage discrete configuration entries, so not the whole configuration, you can use conf.d directory or native resource types, which will edit the configuration as you see fit. And when it comes to these resource types, there's native resource types that exist in Puppet and in other tools in a similar way, like host, mail alias that will edit the files, etc. host, etc. aliases. There's modules such as in setting. And in all other situations, a lot of people just resort to using file line, which is kind of, edit if no such line in CF engine, which is kind of horrible. And that's where OGS comes in. Oh, sorry, this is horrible, this picture. OGS is kind of a scalpel for configuration management where you can edit configuration files, and it's got over 300 parsers that allow to do this with very specific syntax. There's been an OGS type in Puppet that allows you to use it directly and make changes to your configurations for a very long time. But in a lot of cases, it's not very easy to use, and it's not very easy to make idempotent when you want to make very specific changes. So that's why the OGS Providers project was born, and it was created by Dominique Cleal originally, and then I joined a bit later. And it provides a resource abstraction. It provides a declarative API to create types and resources for Puppet, and there's about 20 existing types. So it benefits from OGS's power and flexibility, but you don't need to know OGS and how the library works in order to use it. So it hides the complexity, and it provides enhanced resource types that you can use directly in Puppet. For example, for shellvar to modify configuration files for bash. So there's lots of different types that exist that are provided in the project. For Apache, for Nagios, for PAM. The most used one is probably shellvar because you've got a lot of configuration files using just shell. And they're not as simple to edit as one may think. So here are some examples, just with shellvar and sshd config, the most used ones. So here, using shellvar to make sure one parameter is present in an array in etc default grab and not touch anything else in that file, or with SSH deconfiguring rules for a match group. You can just use this in your Puppet code. Simply install the module, so OGS providers shellvar, OGS providers SSH, and just use the types that are provided by that module. Moreover, because this is a library, this before, you can also purge resources, like a lot of resources in Puppet. If they're unshareable and you can list all the resources, you can also purge them, which allows you to manage, for example, your whole SSH config file in the form of several parameters that you manage separately and purge the whole thing. You can actually extend it because it's a library with a documentation and it's declarative. So it's already been used in various modules, such as the Puppet server module from Vox Populi, or some modules that we have at Camp2Camp. So essentially, I'm not going to get into details, but you can just declare, if you use to OGS a bit, you can declare the resource path, so where you will find your resource in the OGS tree based on the parameters of the resource, and then it will compute most of the way to manage that resource automatically. But you know, we don't do a lot of Ruby these days, and a lot of the new tools are based on Go, actually. So how about integrating this in new tools like Terraform, like Docker, and so on? There's a library called Narcissus, because of the joke on mythology and reflection, so you can check this out. Well, thanks for listening to me, and you can come see me if you have questions, and I have stickers as well.
Oh, yeah. That's the one.
Hi everyone, so I am Alexander, I come from France. Maybe some of you are used to Rudder. You know that we don't speak too much technical, we are more on a business purpose, so this talk will not be strange. It will be also basically on the business side of the config management. So what is config management and what is a compliance in config management? We are not the only one that talking about that anymore. And so I was asking myself, why should I just discuss with you of what is a configuration management? We are now, there is like 30 years that configuration management is existing. Everyone know here what is a configuration management. And for a few years now, maybe 1, 2, 3 years, there is more and more solution that talking about compliance. So why? Why of that? So I just began to say, okay, what is configuration management? So I just Google it and find in the Wikipedia the definition. And configuration management is not only a tool, but it's a process first that ensure consistency. This is why our tool is like that. So configuration management is automation, sure, but what it ensures? The consistency in IT environment is more about availability, it's about reliability and scalability, of course, because of automation. But more and more, there is also security. That was something very old that I think that every sysadmin thinks about also is security. And configuration management seems to be very good for that kind of purpose. But do you trust your configuration management? How many trust his configuration management and never check the log, for example? Pretty sure that no one gonna raise her hands or his hands because we're not sure about the consistency of our product. And it's very simple. It's automation, sure, but we don't automate just for the automation purpose. We are doing this because of a business purpose, because we're delivering a service to our customers. And so, of course, we have to make sure that everything is all right. Because every time you need a hack, you need a feedback about, does my compliance is okay? Does my configuration management is okay? Does my automation is okay? And we need that feedback. For example, when I first begin with just some scripts and others, you always doing, or even me, I'm always making this dollar question mark every time, because if I don't get the feedback as everything is okay, I'm not sure. So as I told you, configuration management now focusing on the compliance purpose. So we can see our friend of Puppet, our friend of SaltStack, and I probably missed some others. Of course, I put Rudder one. And Compliance is now a target for every business here in compliance, in configuration management. But don't be fooled about that. So every time on the marketing purpose, it's about security stuff. And yeah, there is money on the market of securities, of course. And compliance is very, very near on the risk assessment and risk remediation that all the chief information security officer get in mind and get you a budget for. But this is now how about the security stuff. It's about getting feedbacks and knowing that what you're doing and can proving it. So, yeah, I'm trying to find just some words of waiting that it come from the next slides. Sorry about that. So, security compliance is not the real purpose about this compliance approach of Puppet Remediate, of Rudder, on SecOps and others. Of course, there is business purpose for that and with a good focus on the security standards. But it's a side effect. Firstly, we need the feedbacks. We need feedbacks that have real meaning. We need to understand and we need to get it quick. So if you have an immediate feedback, then you know that it's all okay or maybe not, and you can make something against that. So remember that security is a good market purpose, but feedback is really important, and I think that it's really important, and I think this is why Rudder have this compliance approach even in the Rudder open source project for everyone, and not on an enterprise version or anything. Because without any feedbacks, you don't know what you are doing, and if you don't know what you are doing, you're probably going wrong. Thank you.
You ready? Hi, I'm Jay Goldberg, and I'm here to talk to you about how I'm doing way less configuration these days. Changing how we think about configuration management has saved us time and effort, reduced risk, and improved performance. So I used to develop the Unix operating system at Unix System Labs, IBM, and AT&T. I've been automating infrastructure for 25 years, and I'm now at 2 Sigma, a financial firm in New York. They say we learn from our failures, and so here's some of what I've learned at my current job. Our first configuration management system was conveniently written in a scripting language, which looked like an invitation to rewrite our scripts in the configuration management system. This caused us tremendous performance problems and was a really, really bad idea. So we switched to a new configuration management system. The new one was written in C with a domain-specific language that was declarative for configuration, and we re-implemented our scripts again, only now they didn't even make sense. So it cost us a fortune to drag this code along with us, and here's a CPU graph of a system that's doing nothing but configuration management in our old way of doing it. Our users complained bitterly about the impact that we were having on their systems. So in order to make a difference, we had to change how we think about configuration management. Since we had to solve the problem for containers and public cloud, we asked ourselves, well, can we consider all of our infrastructure to be immutable? We went down that path for a little while, and we found that we would have some other problems. So we knew that we would have at least hundreds of different configurations stored as system images, which would both increase and hide the complexity of configuration management. And that's like the exact opposite of what we wanted to optimize for. So thinking about timescales was a big help. I mean, there's very little that needs to change quickly on your systems. Things like self-service changes for users. There's some things that need to change by environment, like if you open a new data center. And the vast majority of things you only ever handle once in the lifetime of a system. So thinking in terms of this led us to the principle of least configuration, which is really simply provide a working configuration by default and do the least amount of configuration change possible for customization. It sounds obvious, but it took us a long while to get there, and we didn't really think about the problem. So we moved to tools that actually support these timescales, and our configuration management system now gets self-service changes out to users quickly. And for everything else, we use packages for the majority of things that never really change. Now, we use atomic operations for most of the things that we do. So, like instead of editing a system configuration file, we'll drop in a small override file in a .d directory. And we do the same thing by using systemd. So systemd, the units themselves are atomic, and it allows drop-in files, which lets you override the configuration of even a single parameter. This lets us do less configuration and do it more safely. And so we now build configuration packages that leverage these patterns. So here's one for how we configure how frequently our configuration management runs. In the package, we define a few curated self-service options, and we let users choose. Our configuration management database allows this self-service. So we store our business logic in the configuration management database, which unit tests and exports atomic files, which our configuration management system delivers to the hosts as they're needed, and only where we need to deliver change quickly. And our configuration management system is all data-driven now. It's back to kind of Eric's talk, I guess. So here's an example of updating app sources. All we do is we parse a common configuration file format, and the configuration management system just does its thing. What we get out of this is that our configuration changes are now smaller and safer. They rarely require any code. We've freed up 2 engineers to work on other interesting stuff. And any of the products that you're all using today can operate like this. So in practice, this is how it looks. We used to have 110 really redundant pieces of code for managing different parts of the operating system, and we replaced that with 9 data-driven items, mostly the atoms of the operating system, things like files, packages, and services. Back to that CPU graph, what we see now is that we have 93% less code. It runs 30 times faster than it used to, and best of all, it's completely transparent to the users. They don't even complain anymore. If it sounds like a great idea, it is, but it's not a panacea. We still have to do the hard work of configuring our systems. We have to be really careful about complexity because we've moved some configuration into packages. And so we have to think harder and talk more amongst ourselves than before. So it's our ideas that lead us to solutions that work for us. And just remember, the products that you use really don't influence how you think. Thank you very much for letting me share these ideas with you. If anybody wants some more detail, I'm happy to have a discussion with anyone.
Two more before the commercial break.
My name is Paul, and I am an award-winning DevOps thought lord. Paul went out for Ginny. She's with Tupac now. Before DevOps, obviously, we were sysadmins. Oh, sorry. I come here today not to praise DevOps, but to bury it. That's some Shakespeare, because as a DevOps thought leader, I am cultured as fuck. We weren't always DevOpsers. We used to be sysadmins, and we would spend a lot of time writing sendmail CF files, writing poetry in Perl, and playing Halo. And we didn't have a no asshole rule. It was actually encouraged. And then in like 2007, this guy Andrew shows up. You've probably heard of him, and he starts talking about agile infrastructure. We were like, that's never going to work. You're crazy. It turned out it did work, and he's been telling us I told you so ever since. A year later, we got John Allspore and some guy whose name no one ever remembers, did their 10+ deploys at Flickr Talk. And this was the first day we saw Dev and Ops together on a slide. So this was almost the birth of DevOps, but not quite. A year later, here in Ghent, Patrick Dubois used that creativity that Belgians are famous for and took the word development, operations, and days and jammed them together and created the very first DevOps Days event. Chris would like me to say that he was also involved in that. Being in Belgium, they drank a shit ton of beer and they spent 2 days arguing about how to capitalize the word DevOps. And they maybe never got around to giving it a definition. They later would say that is a feature and not a bug, and that it doesn't need a definition, and that's okay because only terrorists write manifestos. And that left us free to cargo cult DevOps however we wanted. So we fired all of our sysadmins and we hired DevOps teams. The smart sysadmins, we called ourselves DevOpsers. We got like $100,000 a year pay rise. It was fantastic. We were swimming in money. And our vendors were left to just stick a DevOps label in whatever it was they were currently selling, add a couple of zeros to the end, and boom, they were selling DevOps, and they were also making shitloads of money, and we were all really happy. But it turned out DevOps became really expensive. Amazon shows up and says, you don't need DevOps, you can do no-ops on our cloud, on our platform. And so we fired all of our DevOpsers that day, and we started doing no-ops, and we discovered that didn't work out as planned. Unfortunately, all of our DevOpsers had gone and gotten more rewarding jobs doing things like farming for chickens. And so we kind of got into this bind. We didn't have DevOpsers anymore. We didn't have sysadmins anymore. What were we going to do? Thankfully, Google comes along and says, we just invented this new thing. It's exactly like DevOps, but it's totally not DevOps, called Site Reliability Engineering. And we didn't just give a definition, we wrote a whole fucking book about it. Now, I haven't read the book myself, but I'm told that SRE is when a bunch of developers write some software and they give it to the SRE team to run that on Kubernetes. Now, that's a brand new way of working, and I'm sure it's going to work out wonderfully. Unfortunately, there's more to running complex systems and infrastructure than just cargo culting a bunch of cloud-native bullshit. Thankfully, Amazon comes along and says, don't worry, we get rid of the servers. We have this new thing, it's called serverless, there's no servers, therefore no SREs, no DevOpsers, no sysadmins, nothing. It's beautiful and it's amazing. And so we immediately fired all of our SREs as well. If you're not familiar with serverless, that's when you take your WordPress blog and you get the server and you simply throw it away. You might be thinking to yourself, how does that work? Where is my WordPress running? I don't understand. And that's where we have to admit you may need to modify your architecture just a little bit to work on top of this new serverless framework. But look how much simpler it is. Now, Google, not wanting to be outdone, came along and said, we've built this new thing called Knative, and that lets you do serverless on top of Kubernetes inside of your own serverless data centers. And so now we don't have servers anywhere at all. So we don't need sysadmins, we don't need DevOpsers. So I'm actually here today to let you all know that you are fired. I did, however, bring this list of things that you as a DevOps are qualified to do. I'm looking forward to my new job as an electric bath attendant. Thank you.
Didn't Michael tell us like 5 years ago we would all be goat herders?
I can't take this out.
You can.
But you need this for the recording.
We need that for the recording too.
Damn it.
Go.
Chris, how am I supposed to drop the mic if I can't take it out of this thing? Hi, so I'm Michael Ducey. I'm going to talk about rethinking open source in the age of cloud. You might have seen me here before giving various talks. So the roots of open source are really kind of in this foundation of the Free Software Foundation, GNU, and GCC. And I wear this shirt not because I think RMS is an asshole, which I do, but this shirt is very special to me for a number of reasons. Mainly, it's around how I got started in open source. So back in the day, you had these big, gigantic machines, and it was very, very hard to actually get access to these computers or to the hardware, to actually go and play around and explore the world of computer science. And this is the 80s timeframe. I wasn't doing open source then, by the way. I'm not that old. And then you also had tooling that you needed to actually go and use those big computers. And this tooling was all closed and ran by proprietary software companies. And also, if you had your own computer, it cost a lot of money. So around 1999, somebody wrote a book called, or an essay which turned into a book called The Cathedral and the Bazaar. And in this book, Eric Raymond compared the GNU model of having a bunch of dictators on how they worked and comparing it to the Linux model, which was a much more open model, which we can see in GitHub. But one thing that Eric said in this talk was, every good work of software starts by scratching a developer's personal itch. And I'll let that set while the slide switches. So back in the day, open source was really about this idea of itch scratching, and then also opening access up to compute. And I think this idea of opening up access to compute and data is really the foundational thing of open source that we tend to forget. And a good example of this is PHP versus Cold Fusion versus ASP. Now, PHP was completely free. You could run it on Linux. Cold Fusion was not free, but you could run it on a free OS. And ASP was a completely closed platform that you needed all of Microsoft's software to actually go and run. And the powerful thing about PHP, and at least for me, because this is really how I got started, is that it enabled you to have access to a rich and powerful language. It gave you access to OSS integration so you could start learning other open source software, and then you could run it yourself using open source software. And the other really important thing about open source is this idea of opening up access to compute to a broader range of people. And the one laptop per child is a great example of that, of trying to build a computing platform for under $100 to reach underserved individuals. But if you look at what open source is today, each one of these platinum member spots cost $500,000 US. So that's a lot of money. And now there's a lot of money involved in open source, and we've started to kind of get away from our roots. And so I go back to this quote from Eric Raymond, is that every good work of software starts by scratching a developer's personal itch. Next slide, please. Also an asshole, as someone has commentated. But I change this now to every good work of OSS software starts by scratching a cloud provider's itch. Or a VC venture capitalist's itch, right? And that's really how the game has really changed over the years as money has gotten involved. I won't read all the financial information, you can scan through it. But I want to read the quote at the end. Given the relative multiples that Wall Street and private investors are assigning to these open source companies, it seems pretty clear that something special is happening. And so now that there's a lot of money involved, people are starting to rethink the licensing. So MongoDB and Redis had a reactionary license against Amazon, so Amazon couldn't use, and other cloud providers couldn't use their software. Chef actually attacked their open source users by closing the packages. And then a good example was Elastic, which basically what Elastic was trying to do was they realized the bazaar model and the cathedral model didn't work, and so they wanted to move everything to a bazaar type model. So they open sourced all of the software, they restricted its use, but you can still work in the bazaar type model. And so for every reactionary licensing, there's an equal and opposite reaction from a cloud provider. And you saw that as basically what Amazon did was just rewrite MongoDB and put the MongoDB API in front of it. So you got to go back and look at what the cloud provider's motivations are. And so in open source communities, everyone here should know that. But a cloud provider wants to grow revenue, grow their profit margin, operate at a low cost, their metrics are stock price, and their itch is driving compute consumption, not a developer's itch of getting something done. And so where do we go? I think we should be honest about our intentions. Are we doing open source for open source? Are we doing open source to build a cloud or a business or a software company? Or are we doing open source to run our business? And as open source maintainers, I think we should look at enabling the community rights. So what happened with Chef and the packaging and licensing changes? Can you have community distributed packages? And then also I think important is that as maintainers, we need to partner with the people who are actually using open source to run their business. So the companies that are actually doing it to actually provide a service to consumers or to other businesses and things like that. And I thought I had less time than I did. But thank you very much. I'll be around if anyone wants to talk about open source licensing.
One or two Don't go away yet.
One more.
There's one more ignite. So don't go away yet. There's one more ignite before lunch. The best one.
We gave Toshan and Chris a lot of money, so the doors have been locked, so you can't leave yet.
That's against fire regulations, so no.
It's true. All right, so I'm Gareth. We're from SaltStack. So SaltStack is a automation platform. We do remote execution, we do configuration management, but we also do so much more. And we realize that a lot of people are probably not using Salt, but if you want to use Salt, if you're using something else, come talk to us. You don't have to use all of Salt. You can just use certain portions of it. None of it, it's up to you. Well, not up to you, I shouldn't say that. According to GitHub and Gartner, okay, we're skipping that one. So we have at the current 3,000 individual contributors. We've also started adding work groups because we want our community to have more of an ownership over the project. So we've added a cloud, Salt SSH, Windows, Mac OS, network, test and release, and a new documentation working group. So every month, Salt is downloaded by 3.5 million people, average about 5,000 downloads a day. So a lot of people are using it. Again, if you're interested in using it, just curious about it, come see us at the booth. So Salt is everywhere. We have contributors and users all over the world. Those little grayish dots are people that are just kind of curious about it. The black ones are really excited about it. So yeah, it's used everywhere. So we have a new programming paradigm that our CTO has developed that's pretty exciting. We have a talk tomorrow afternoon in the Salt room, which is B2011, I think, on that's programming, pop-oriented programming. So Heist is a disposable agent. So if you're interested in running Salt, but you can't or don't want to have a minion running on your systems, Heist will let you do that. It sneaks in, does its thing, and like any good Heist, cleans up after itself. Umbra is our venture into AI and machine learning. So come talk to us about that. 20 seconds is a long time. Item is our replacement for our Salt State system. So it's built on top of POP. It's very exciting stuff. Come talk to us about that. Can I skip? No. And I will turn things over to David, who's going to talk to you how you can give us money.
You're eating into my time. Hi, I'm Dave Fiddler. The timing on this is awful. Okay, so what do we offer at SaltStack? We offer 3 products. Enterprise, which is all about role-based access control, audit, reporting, that sort of stuff. No, go back. The other thing is we also have, sorry guys. So we also have two products in security. So Comply, which is hardening, because 99% of all vulnerabilities are known at the time. And we also do Protect, which is vulnerability management. See, this is how you take control of your architecture. All right, so yeah, we do infrastructure automation, end-to-end builds. I'm not going to talk too much about that because that's what this is about. It's a little weird, I know. Security automation, we are actually the only company out there that does certified CIS configuration scanning, really, and automation. So we'll scan it, we'll fix it, and all of our content is certified by CIS. A lot of big companies use it. This is that waster slide, right? Why do they use us? I'm going to hit the back key in a second. So, tremendous speed, a massive scale, massive flexibility. SaltStack is in and of itself very elegant. And action, that's kind of a throwaway word because it's an automation tool, so it does action. No, go back. So, everyone that uses an automation tool, if they get to a certain scale, they end up using us. And come and talk to us a little bit about why that is. So IBM Cloud, who do they own? They use us to manage 80,000 network switches and routers. They did not use any automation at the beginning. They use us now. I don't know how that's going to work with the acquisition. Hopefully they keep us. I don't see why their marketing department would. But last thing, SaltConf 2020. We are having our first conference in Europe in Geldermalsen. I've destroyed that one. Yeah, on June 10th and 11th in the Geldermalsen. I'm Canadian. I'm sorry. I'm really sorry. And I think that's it. Thank you very much.
Yeah, so for the people that didn't notice, that was a sponsor Ignite. Typically it's 15 seconds per slide, but okay.
The timing is wrong.
The lunch is when you go out from here, you go completely to the end, and the last entry. Don't use the middle entry, that's an exit. If you're a speaker or an organizer or a sponsor, find me or Chris, we still have vouchers. We start again at 2 o'clock. 2 o'clock? And we start again at 2 o'clock.
You already had the dinner. Whatever.
Go to the side, and then you'll come on. It'll look more professional.
Okay, man. That's recorded.
All right. Hi, everyone. I want you to welcome Peter Suter. He is a TAM from HashiCorp. TAM sounds like a drum, but it's not a drum. It's a real job. And he is actually an amateur powerlifter. And I think he's going to lift your spirits with his great talk. So please, a round of applause for Peter.
Hi, everyone. Hi. Is this one working? Can people hear me in the back with this, or? Hello?
Talking to this.
Sure, talking to this instead?
You have to use the mic on the stand.
Yeah, just use that.
For the audio in the room here.
Oh, okay.
The other one is for recording.
Oh, okay, cool, fine. Great. So hello, everyone. My name is Peter Suter, and yeah, this is my talk, Head in the Clouds, Testing Infrastructure as Code. So before we begin, I want to introduce myself. My name is Peter Suter. I'm a technical account manager at HashiCorp. So basically, I do kind of all the kind of post-sales engagement stuff on the technical side. So we have enterprise versions of all of our products, and then people buy them, which is awesome because it means that I get to feed my family. And then from there, we kind of engage on the technical side and kind of follow up stuff from this. This is my, I think it's my, whatever I've done there. Yeah, I've been coming to Config Management Camp since 2014, and yeah, it's been an awesome conference, and I really like it. And yeah, I've kind of worn a lot of hats in my time. I've done pro services, I've been a dev, I've been testing, I've kind of gone through all different things. So pretty important, what are we here to talk about? So this is Config Management Camp 2020. So infrastructure as code is a pretty big deal. And for anyone who doesn't know, hopefully most people have heard of this term before, but the idea is you're basically treating your infrastructure in the same way you'd be treating your code. And why do you want to do that? So there's a bunch of benefits. You can generate things from scratch. You can get code review and collaboration. You can kind of conceptualize everything because you have it in a code form rather than in a GUI or in someone's head. You get auditing and policies. You can kind of iterate over time, start with something small and build stuff later on. You can modularize, reuse, high complexity, and the bit we're going to talk about mostly here is testing. So why do we want to test in the first place? Well, ultimately, as we go through the list, basically everything there becomes easier with testing, because testing is mostly about being confident in your kind of code and deploys. If you want to regenerate from scratch, you want to be in a pretty secure idea that your code is doing exactly what you want to do. If you want to review and collaborate, if someone's opening a pull request, you don't want to have to just eye it. You want test to tell you that the code they've written isn't breaking things. It's a lot easier to conceptualize when things are tested. So essentially, everything kind of comes from testing, really, there. I've got a pretty good quote here from Devin Kim. He was in the HashiCorp Slack when I was talking about this kind of topic last year. And he was basically saying that in his eyes, infrastructure as code without testing is self-sabotage, which is pretty strong words, but I pretty much agree with him there. So we're here at Config Management Camp. We've been doing this for a while, but let's have a little quick history lesson of kind of config management and testing, really. And before we start, I'll give my caveats. I obviously currently work for HashiCorp. In the past, I've worked for Puppet. Before then, I kind of did DevOpsy government stuff in the UK. So I'm going to have biases. Obviously, I'm going to generally favor my company and my products and stuff. But a lot of the ideas that we're going to talk about can be, and I'll give some examples for other tools as well. But a lot of the ideas we'll be talking about are kind of general ideas for all the infrastructure as code, or anything that interacts with a cloud, really. But you'll see that there's probably a little bit of bias towards Puppet and Terraform here. And I should probably emphasize that I'm not on the engineering team. There are some people from the HashiCorp engineering team that are here currently and the DevRel team. But anything I say, like, it's not a commitment that we're going to do that, or any kind of questions I answer. I can't give you a definitive answer on things like roadmap and stuff. But the idea is that I have talked to those people and I work with those people a lot. So it gives you a general idea of what's going on there. And one funny thing is that Terraform technically isn't a config management tool. We see it as an infra management tool. The idea is that it's about focusing on the strengths there. Like, we don't try and do the same thing as other things like that. So technically doing something like this. So a little history lesson. People have probably heard of this analogy before, but in the old days, everyone kind of treated their infrastructure as pets, not livestock. If something went wrong, you kind of had to log in and nurse it back to health. You worried about it. Every time you did a deploy, you were kind of worried. If you had to bring it back from scratch, it's always going to be a big stressor. So we want to move to this new world of, if something goes wrong with a machine, you can just blow it away and bring it back up, and you're relatively sure that all the code that you've kind of done to set it up is going to set it up in the exact same way. So a bunch of tools were either created or invented or kind of developed around that idea. And you'd start deploying them to a pre-prod environment, so something like a staging or something like that, and that's kind of like the first way of doing the testing there. And people started saying, I don't want to have all these different environments for everything going on, so why don't we have some sort of lab or some sort of way of creating these as VMs instead? And then containers, which obviously had been around for a long while, like over 20 years if you count things like jails and things like that, kind of became more mainstream with things like Docker, which was simplifying the user experience. So then you started to do testing against containers, which is a lot faster than testing against the VM. And then the cloud came along. Obviously, this is not fully accurate time zone-wise because the cloud has been around for a long time. But in terms of what people are interested in, people started to say, like, OK, we're not doing stuff on bare metal or VMs anymore. We're doing things in a cloud. So then all these existing tools started doing more kind of tighter cloud integrations. And then a bunch of tools that were specifically designed for the cloud started to come out, and they started working that way as well. So then people started asking, like, how do we test these things? Because if you're testing a config management language and you're running it against a system that you control, like a VM or a Docker container, it's pretty easy to create it and destroy it afterwards. But how do you test something against a system that you don't really have direct control over, like a cloud? And how do you make sure that the infrastructure as code that's working against these clouds is actually doing what you expect it to do and is doing it in following policies and following governance and things like that? And how do you do it without spending too much money on the whole thing? So people start to ask, how do we test the cloud? And there's two kind of people interested in this kind of term. There's producers and consumers. So from a HashiCorp perspective, we're a bit of both. We produce these tools that talk to cloud APIs. We also consume our own code because we use our cloud APIs. We use our own tools to build our own products. And we also write things like modules for customers. So we're kind of both. I imagine that most people here are probably on the consumer side, unless you work for a company that produces a cloud tool. But generally, I'm going to try and emphasize the kind of differences in each approach and where it really benefits either a producer, a consumer, or both. So who here would describe themselves as a tester? No one? Oh, a few hands on there, okay. Who here has some ideas around testing or some of the theory behind testing? Okay, more hands there. So people at least know the ideas. But I'll give a brief introduction on the ideas of testing and where the kind of background came from. So you've probably seen something like this before, a test pyramid. This is from Martin Fowler's blog. But the idea is that the lower down on the stack, you want more, cheaper, faster to run unit tests that don't require integration. And as you go up the stack, they get more expensive, but they have tighter integration you have with your actual applications themselves. Obviously, this is talking about service tests and UI tests. In a config management world, we're probably doing something like this. So unit testing at the bottom, acceptance testing in the middle, and then kind of full stack integration testing at the top. What often happens is something like this. This is called the software testing ice cream cone anti-pattern. Generally, things like acceptance and integration tests and manual regressions are seen as more visible, and especially with something like manual user regression testing, a lot easier to do in theory because you just throw bodies at the problem. So this kind of became an anti-pattern where you wouldn't write many unit tests, but you just have an army of people just hitting your stuff and making sure it did stuff there. And this would be reflected in, someone does a Terraform run, and then someone kind of looks at it, eyeballs it, and goes, yeah, that'll probably be okay, and just merges it, bad stuff. So we want to eat the cone from the bottom. If anyone who here knows about cornettos, I don't know if they're called different things about in Europe. I get a few hands there. So the bottom of the cornetto, because it has a chocolate edge around the cone, it all kind of falls into the bottom and has this really awesome little chocolate core. So we want to try and get that. We want to eat the chocolate cornetto cone from the bottom and get those unit tests out there. So let's start with the most simple tests. And these are not really tests. These are almost like smoke, the most basic thing you need to do to get your infra management kind of code working. So depending on how your infra code is written, it's either a kind of framework that works with an existing code, you know, that's like templated in something like YAML. It's either its own language, something like HCL or TF or Puppet, or it's written in another language and then you can syntax check it that way, something like Chef, which is written in Ruby. So for Ruby, you're just going to run a compilation check against, so for Chef, you're going to run a compilation check against Ruby. For Terraform, we have to validate command. For anyone who's using Terraform currently? Bunch of hands. Who's using Terraform 0.12 currently? Most of the same hands, cool. So in the 0.12 release we just had, we added a bunch of really cool new features. One of my favorite is the fact that the debug messages you get and the error messages you get are a lot more, they're a lot richer and they give you much more information, and they can even tell you like line numbers and precisely where something is going wrong. So it's definitely something that I want you to check out if you're not on 0.12 currently. Ansible has the -- check command for playbook running, but obviously you can just run a YAML linter against a YAML file itself to make sure that the YAML you're giving it makes sense. And Puppet has the Puppet parser. So the next step after that is kind of basically a compilation check, but for rules that don't break the language itself. So that's linting. So depending on the language, there's generally some sort of linter that's been officially blessed by the company, or at least is being used by a lot of the community. And then you probably want to run something like that. You can even, a lot of these linters have their own custom rules that you can write. So if there's something that you're doing internally at your company that isn't like a kind of globally accepted idea, like we don't want to do this certain thing, you can generally write a linter for that. So for TF-lint, there's a tool that's been written called TF-lint. And basically this will go through and lint things. Right now it's very tied to the provider. So right now it's very focused on AWS. But he's working, the original creator of it is working on a plugin system. So hopefully in the future that could be more plugged in and do things like that. Chef has Food Critic. Puppet has Puppet lint. And Ansible has Ansible lint. And basically these all work in the same way. They highlight not errors, but things you probably shouldn't be doing. So I kind of sped through a lot of that because a lot of this stuff has been covered. I mean, a lot of that isn't really testing. It's like the most basic level of stuff you want to gate into part of your pipeline. But unit testing is when we really start getting into actual testing. So what do we talk about with unit testing? The idea is that you're building things to make sure you're building it right. So acceptance testing is making sure the thing kind of runs. Unit tests are making sure that the code you're writing actually is well done. And a really good tweet about basically the ideas around what is and is not a unit test. This is pretty strict. Like, I think half the unit tests I've seen probably don't follow this. But the idea is a unit test should be able to run in multi-threaded on a read-only environment system. It doesn't need a file system, it doesn't need a database, it doesn't even need, technically, a lot of the time, real internet connection. But the idea is it's something that you can run on any sort of system. You want to be able to run it in your CI, and it will pass in the same way you'd run it on a laptop. And then you have the red-green refactor loop. So you write a failing test, you then refactor your code so it passes the test, and then it's green. You then go through that code and then see if you can refactor it again, run the test again, it's green. So that's a quick run-through of testing theory and where it kind of comes from. And the unit test you write, especially when it comes to config management, it's very easy to write basically tautological unit tests. You don't want to write a test that just goes like, if you're writing some Puppet code that says install Apache, there's no point writing a test that just goes should contain package Apache. That's just a tautological test. You can see that just by looking at the code. You really want to test the edge cases. So if you're taking in variables in something like Terraform, if you're running differently depending on which platform you're on, like if you're on Debian, you want to use apt. If you're on Red Hat, you want to use Yum. That's the kind of thing that you should be testing in your unit tests. And producers and consumers really have different intents for unit tests. If you're a producer, you're probably testing your code in the language it's probably written. If you're a consumer, you're probably testing a pre-written module and kind of doing it on the language side. So for Puppet, there's RSpec Puppet. If you're familiar with the kind of Ruby ecosystem, RSpec is basically like a BDD style language, so it's all kind of behavioral style, should, if, when kind of thing. In this example, I'm using my fish repo, the fish shell, and I'm saying if I'm on, and I'm testing, I'm not doing a tautological test, I'm saying if I'm on CentOS, then expect this yum repo to be enabled if the parameter managed repo is true. And this is basically testing the edge cases there. And you have the same for Chef. There's something called Chef spec, and again, it's built on RSpec. You're doing the same thing. You're mocking out the Chef run with the platform it's on, and then it's doing changes based on that run. For Terraform, right now, there's nothing really official. There is a issue on the GitHub with some discussion around how we would do that, maybe building it in something like that. But honestly, we have a pretty big backlog. Like, I think in the time, I've taken this screenshot maybe 3 times over the last few weeks. I think the lowest it ever dipped in the kind of recent history, I think when 0.12 came out, we closed a lot of long-running 0.12 specific issues, and it got down to around 900, but they quickly filled up with all the issues that people have at 0.12. So it's not something that we're like actively looking to do right now, but it's always something that we'd be interested in the future. So there's a few contenders for this. A lot of them are kind of built meta, like on top of the reading the kind of language itself. So the first is Clarity. This is all kind of Gherkin style. It's all BDD, so it's all feature files that say, like, you know, if AWS instance is this, so you don't actually have to write anything in Go or in Terraform itself. You're writing this purely in a feature file format. And this will pass the HCL itself, so it can't do anything that's state-based. And we talked a lot about state this morning, and I'll talk a bit about state later on. But this is entirely on the code, not on the state that it will produce. So in this basic example, given Terraform an AWS instance of resource, I want to have an instance type of T1 micro, and there's only one of it. So this is a really basic test. I've got some Terraform code that's just one T micro instance, and it should be there. There's also Terraform compliance. It's very similar in how it works. It's more from a kind of policy compliance kind of setting, but this one will actually use the plan output, so it's real state, or at least state that's been simulated as part of a plan. So this one would require you're on a system that actually can run the Terraform, so it'll need the plugins there, and depending on how the plan is written, it might need to actually talk to the public internet. It depends on the provider and how it works. But yeah, it basically is the same sort of idea. It's Gherkin style formatting, and then it has Terraform specific matches. In this, I'm doing more of a kind of policy style check. I'm making sure that all of my resources are tagged. So it's going through anything that supports tags. It's making sure that there is a tag there for name. I've got a really basic tagging system here. And lastly, the kind of non-BDD style is Terraform validate. So this is written in Python. It uses the PyTest native unit testing that's part of Python itself. This uses HCL rather than plans, but the idea is that if you don't really like BDD style tests and you want to keep it more unit style, then you'd write it in this. You obviously need to know Python to do this. So in this example, I've got a similar sort of test where I'm basically saying, does my AWS instance have tags? So it's going to go through, and you can see it's failing on should have properties tags, and it's saying that the date tag should be there, and it wasn't, so it failed the test. So that's unit testing. It's pretty fast, easy to write, no environment really needed, but you're not really testing the actual outcome. So far, we're not actually interacting with the cloud at all. So this is the kind of first level of testing you can do, but it's still the kind of cheapest and easiest bit. So we're going to move on to the hard part, integration and acceptance. So people use the terms interchangeably, and honestly, depending on who you talk to, I've heard different answers about it, but the best summary I've heard is that acceptance is the kind of consumer or customer-facing style tests of like how the full system kind of works, interacts with each other. Integration is more on the kind of a unit test for a single piece, but then talks to real systems. But ultimately, the stuff we're talking about is the same. And it's a pretty good diagram of how people generally see this. But if we're going to write these tests and these integration acceptance tests against the cloud, how do we control something how do we test against something that we can't control? So there's 3 approaches that I've seen. So the first one, it kind of stays with testing in general. Use fixtures. So basically start mocking things out. So fixtures are basically a fixed baseline that you put inside your code repo, and then it will be able to run without having to actually talk to the real thing. So fixtures can be physical files on disk, but generally it's some sort of recording of like JSON requests and stuff like that. Depending on the tool you're using, there's generally some sort of automatic recording framework. In Ruby, there's a tool called WebMock and VCR. You can basically run with both of those on. It will download all the HTTP requests it's making and store the responses locally in your system. You can go through and kind of like remove any kind of sensitive information, and you have a pre-done VCRs that are then replayed every time you do the test. So ultimately, these kind of tests are pretty similar to unit tests. If we go back to our requirements for a unit test, we're mocking out those responses. So ultimately, they could run in the same way that a unit test does, because they're not actually interacting with real things. So for a real-life example of this, we have the Acme provider. If you don't know, Acme is the protocol that tools like Let's Encrypt use to have a kind of call and response style CA that gets certificates. We don't want to have to run our own Acme server, and we don't want to run it against the real Let's Encrypt server, because we'd probably get shadow banned when running acceptance tests. So instead, we're going to use fixtures. And then Golang itself has a built-in kind of fixture, kind of mocking tool called HTTP test. And it basically looks something like this. So this is a screenshot of the real code from the Acme provider. We've got a custom JSON response, what we want the mocked Acme provider to look like. We then have some definitions of a HTTP test server. And then later on in the code, we just refer to that test. So then every time it's doing it, instead of trying to talk to the real internet, it's talking to this mocked service that's running locally, basically. So fixture mocking is pretty good. No dependency on cloud, very quick to run, because essentially they're pretty much unit tests. But it's going to be a lot of work to maintain fixtures. And ultimately, the bit we care about is this isn't really testing the cloud, because right now we're still not talking to the cloud. We're taking what we think is the current state of it, and we talk about state a lot, and then taking a snapshot of that, keeping it locally within the repo, and then testing it against that. You're not really testing it yet. So to go beyond even that, you have simulated clouds. So if people are familiar with like microservices and Lambda and functions and things like that, generally you're writing code that's going to run in a kind of on-demand Lambda or serverless or whatever we call it these days. And the idea is that devs were writing this code and then they're like, I don't have to deploy to a real API every time I do this. I want some sort of simulated way of doing that. So the three big clouds, Azure, AWS, and GCP, have these emulators and simulators, and basically you can just download them and run them, and then they will simulate those APIs, and they give real responses, and some of the more complicated ones will even act like the real thing, but obviously just not backed by a bunch of cool HA and stuff behind the scenes. So you can actually do something like an S3 upload, and then call that API and actually get responses back and download data from it. So you can do quite deep testing with this. The most complex one I've seen is probably LocalStack. It's basically like a cloud in a box. They cover all of the AWS APIs, at least in the paid version. In the free version, or the open source kind of free version, I think it's about 80% coverage. It hits most of the stuff that you'd really care about, S3, RDS, EC2, and things like that. But you basically run it in Docker, and then the idea is that if you have something that has a hard requirement on AWS, including infrastructure as code, you can run it against that, and it'll work from there. I think I saw people taking a photo of that, so I'm just going to leave it up for a second. Cool. And now we have our first live demo warming, so let's see how this goes. Let's put this up here. Can everyone see that at the back? Thumbs up from there, cool. All right, so first we can look at the README file. And essentially, yeah, you run it as a Docker container, and then after that, you export dummy access key IDs and secret IDs, and then after that, it pretty much works in the same way. So let's run the commands. I'm going to try and look up there. So let's just copy and paste this bit. Oh, crap. That's what you get for trying to have a fancy preview there. And then we can actually open it up. So on the right, it basically has a GUI of the services that we've done so far. So I can do a Terraform init, and then do a Terraform apply. It's a good start so far. Yeah, I think basically because it checks for the latest version of the provider to make sure that you're on the latest version, and I think the internet's just going a bit slow right now, so let me see. Oh, there we go. Okay, cool. So essentially, we're running the same Terraform code, but as we said, we're mocking the region. We're skipping a bunch of stuff because otherwise it's going to actually try and talk to the real API. And then we're saying the S3 endpoint, instead of trying to talk to S3, the real life one, we're talking to the local one. So let's see if that's actually run. Right. I'm going to leave that cookie in the background because it looks like the internet's going pretty slow, but every so often it kind of speeds up, so hopefully we can get that working in a bit. But the idea is that you could run your Terraform against this simulated instance and it would work in the same way. I did warn you, live demo, so. So the pros of the kind of fixture mocking, you don't have any dependency on the cloud. You have more debugging than you would for a fixture, but ultimately it's just it's a fixture on steroids at this point. The cons are, it's not going to exist for every service. Even the ones that are officially maintained by AWS and Azure and Microsoft and Google and Amazon, they generally take two particular services, generally something like storage and Lambda, and kind of test it from there. You basically have to rely on the simulated service keeping in line. And again, we're still not really testing anything, because right now we're testing against a mock. A fancy mock, but still a mock. So lastly, the option is don't actually mock anything, do it for real. And unsurprisingly, as a producer of infrastructure as code tools, this is how we do it. So Terraform has a model where you have Terraform core, you have a bunch of provider plugins that talk to upstream APIs, and then we need to basically have tests that are kind of extensive and deep enough that every single one of our providers ends up testing every single resource that's in there. That's actually one of the things that we, as an engineering team, we don't generally accept things that we can't easily test. For example, the Azure API now has a way of creating users within the Azure API, but there's a hard limit of 200, and you have to go and talk to, I think it's help desk or something like that to get it extended. So it's not something we're going to actively work on until it's not like that anymore, because testing it would just be too much of a pain. If you run that test like maybe twice or 3 times, you're going to be locked out immediately. So we're going to make sure that testing works from there. And our kind of model is there are providers that we maintain officially. And then of those, they are generally helped maintain by partners or the community. And we want to make sure that all of those are tested in the same ways. Obviously, we generally do much more testing for the stuff that we work with the partners directly on, or we work on ourselves at HashiCorp. A lot of the time when a new feature comes out, we try and make sure that it's ready as part of the initial release of that feature. And we want to make sure that the testing covers that as well. So Terraform itself has like a bunch of providers. We talk to everything. We even talk to our own products. We have providers for Console and Nomad and Vault. So we want to make sure that these tests are pretty extensive and make sure they cover in the same ways. So for the Azure provider is a good example. We have a test suite that runs nightly, that basically runs literally every single resource that's in the provider. And this runs within our internal infrastructure. So the full suite, we've got it running. You can see that there's about 118 failing, and there's 1729 passing. So there's a lot of resources within the Azure provider. We're testing literally every single one of these. And you can probably see that this takes a pretty long time. For the full Azure suite, it's about 10 hours. And then obviously, depending on what you're trying to do, this can be shorter or longer. But if you're trying to test every single one, some resources, especially things like AKS, are a lot slower. They can be like 15, 20 minutes to spin up. So the more tests you're writing, the longer this is going to take. And generally, depending on how you do this, this is probably going to cost you a little bit of money, either literally in terms of like cloud resources, or if you're running a service that you maintain yourself, probably in terms of like developer time and figuring out from there. But ultimately, as HashiCorp, we have to do that because from a producer point of view, we're testing the tool and everything it does. Mitchell actually spoke, co-founder of HashiCorp, actually spoke at, I think it was Config Management Camp 2015, about Terraform. And then when the initial kind of acceptance test suite started being made, we actually found a few bugs in cloud APIs because we were hitting them with like really high concurrency, and a lot of the tools around at the time didn't really do that. So we actually managed to fix real life bugs with those cloud providers, which is pretty cool. But as a consumer, you probably don't need something this extensive. You probably want to test it more of an integration style. You want to test it based on your organization and your deployment and your infrastructure. You don't need to test the individual pieces. You test the final outcome that you get from it. And ultimately, you care about the state. So that's where something like TerraTest comes in. It's basically a full acceptance testing framework for Terraform. It was written by Gruntworks, who maintain a lot of modules to do this. So they wrote a Golang testing framework. It's written in Golang. It has a bunch of helpers for testing certain things. So it has helpers for testing the state itself. But then it has helpers for actually like logging onto the box and testing the actual creations inside there. The thing about, we talk about state a lot. Everything that happens after Terraform stops, so provisioning itself, that's not really part of Terraform state, as it were. That's something that's better handled by a config management tool. But if you want to test that, you probably want to use something like TerraTest or maybe Test Kitchen to log on to the box or log into however it is and kind of test it that way. And the folks from Gruntworks have said basically the ROI on this is pretty big. They've caught a lot of aggressions and problems. They also mentioned it does take a while, but and yeah, pretty basic test. You're literally running real Terraform when you do this and setting it up in certain ways. So the pros, you get pretty good end-to-end testing. You're interacting with real APIs and the closest to the real thing. The cons, obviously, it's slower, it can be costly, and depending on how you've got it set up, you might interfere with real infrastructure when you're doing this. So there's two extra steps I want to go beyond conventional testing. So the first one is observability, and I'm not going to go too deeply on this. There's a bunch of tools out there. I assume that most people are using at least one of these already. But ultimately, as operators of this software, we want to test it beyond the test suite. We want to see if it's actually working as the end user uses it. And there's only so much you can do with testing. It's a pretty good diagram from Weaveworks. They basically talk about how after you deploy something, you're going to observe it and use that observation to feedback. Maybe it's not a full failure, but maybe something you've written is quite slow, and maybe you detected that as part of your elk stack and said like, oh, I can see that there's a little bit more 500s, and we need to figure out from there. So that's observability. There's a really good talk from Charity Majors, who I think she just founded honeycomb.io. She was actually here last year and did a talk on that, so I recommend going watching that if you want to know more about observability. And the last is governance. There's been I can see even from the talks I've had before there's been more talks around kind of governance and policy. Every organization is going to have some form of policy, either official or unofficial, either dependent on real life legal requirements or not. So you have naming conventions, tagging, price guides, cost centers and limits, legal requirements, regulations, things like GDPR. We can't deploy outside of Europe and things like that. And they all fall under the umbrella of governance. And mostly it looks like this. It's dead tree format. So you have all this written stuff down, either physically or in some wiki somewhere, and someone has to go through with a fine-tooth comb and look at your code to make sure it's doing what it's expected to do. So if you can reflect policies as code, you get the same benefits you would as infrastructure as code. And at HashiCorp, we have HashiCorp Sentinel. It's basically an embedded policies code format. In this example, we're going for a TF run, similar to the things we talked about before, and it makes sure that all of your resources are tagged. So it just goes like if tags, then make sure they're greater than 0. For a more security-oriented thing, you're going to go through all of the security groups and make sure that you're not allowing public internet access through the 000. And yeah, I think I'm going to use my final 10 minutes to try another live demo and see how that goes. So let's see if that's running in the background. Right, that's just timing out, so we'll try this one instead. So in this example, I've just written some basic Terraform code. I'm finding the Ubuntu image, and right now I've got it set to T3 large. If I check my master branch, I've got it set to T2 micro. So if I jump back to this window, actually I'm going to mirror these so I don't have to crane my neck. There we go, it's a lot easier. All right, I think the internet's not going to work for this one either. So come and talk to me afterwards, I can do a demo of that. But the idea is that basically we have this Sentinel policy called block price increase. So this will basically go through your code, and it'll go through the Terraform that you've written, and it basically has an idea that it will look at the current cost based around the cost estimator, which is a part of Terraform Enterprise, and it will say if the cost that you've done increases 10%, then block the run from happening. And then you can set that to either hard failure, so nothing can be done about it, or soft failure, where someone on an admin level has to go through and approve it. So the idea is it's the kind of policy you probably already have, maybe even unofficially. There's a general idea of try not to spend too much. But this is a pretty easy way of turning that into real code and running it that way. So what have we learned? We've learned the benefits of testing infrastructure as code. You know, if you don't do it, you're basically setting yourself up for failure. We've talked about basic unit testing for infrastructure as code and the benefits you get from that. We've talked about actually interacting with a real cloud and how you can either go anywhere from mocking it to emulating it to actually running it against the real thing and all the kind of benefits and disadvantages that come with that. We talked about going a bit beyond conventional testing, so using something like observability to inform your next deploys, but you're not really testing it. You're doing it kind of more as a post-deploy step. And also, we talked about the benefits of policy as code. Unfortunately, the demo didn't work, but come talk to me afterwards if you want to talk about that. So that's it. Thanks very much, everyone.
So we have time for questions if you want, and if Peter Alexis is here, can you come up to the front, to the Netcoff gentleman? Ah, yeah, come over here and we'll get you ready.
Any questions from anyone?
Can you tell the difference between Teratest and Teach and Terraform?
The difference between?
Teratest and Teach and Terraform.
What was the last one?
The difference between Teratest and Teach and Terraform.
Oh, Kitchen Terraform. Okay. So Teratest is Kitchen Terraform. They kind of work in the same way. Ultimately, it's about using your Terraform code, running it, and doing stuff afterwards. But because Test Kitchen, sorry, to repeat the question, the difference between Terraform Test and Terraform Test Kitchen. Test Kitchen is more focused on the kind of more provisioning post deployment kind of side, because it's mostly around setting up a system under test, then logging in and actually making changes and checking things that way. So that's more testing about the state after it's completed, whereas Teratest is more about testing the Terraform itself. You can use both. If you're running something that's more testing something that's a real system that can be tested, and if you're using Terraform to even run like Docker containers themselves, you can use something like Teratest to test the Docker containers you're creating or working, depending on the plugins there. But it's more like a focus on what it's trying to do. Teratest is very much on like kind of full integration, Terraform specific. Test Kitchen is more about like post-engagement provisioning and things like that. Any other questions? No? Okay. Thanks very much, everyone.
Sorry. All right. Stay put. We have another talk in about 3 minutes, and hope you stay for it. It's going to be 8 minutes. One more round of applause for the first Peter.
Thanks so much. We actually have chocolates for you.
Oh, awesome.
But these aren't them, I think, and we'll get them for you shortly.
Yeah.
So stick around. In fact, if you want to stick around, I can maybe get them or...
Yeah.
There's no HDMI by the looks of it.
Yeah. Oh, sorry.
I mean, I know it's a very nice phone, but...
this is my wallet. Yeah, this is my wallet, yeah. I'm just so used to picking up my phone and wallet. Do you need one of these?
I have my own.
Okay.
Also, I'm running limit, so it's going to be a small flight.
Oh, you're running like a... You're running... Oh, yeah. I was going to say, I was like, that's an excellent place.
Yeah, that's not mine.
Hey, man.
Hey.
Die zijn ook alle twee goed.
I have these like 10-minute things. You want that or skip it or?
No, that would be great.
Yeah?
I do have a timer on my laptop, but it's good. Is
So
it,
it's 10-5-1-0.
Is it until the end of the talk or until like question time?
It's a good question. Let me double check because we have a break right after.
Zal ik deze even vast doen?
Je kunt dat je beter hier kan doen, want mijn baard zit er altijd voor. En dan klinkt hij heel erg gemuffeld.
Dan moet je wel hier in de buurt blijven.
Ja, dan hang ik hem gewoon een beetje zo.
Want deze, ik gebruik dit, hè?
Ja, dat is
niet
prima.
die.
Ja, deze is voor de zaal, toch?
Ja. Oké, dan doen we dat.
Nee, reverb-microfoons werken bij mij gewoon niet, omdat mijn baard er altijd voor zit en dan hoor je al dat
dat je allemaal geruis krijgt.
Ja.
Stick it on his ear instead.
That's also possible. I'll just stand here.
Yeah, we have the break right after, so I can give you. I'll give you the times till the 5-minute mark.
Right, that's fine.
So it goes to 3:40. So the times I show you will be to 35.
All right, that's fine.
So when it's 0, you have time for questions.
Perfect. Let me just see.
Unless you hate giving questions.
Oh no, I love getting questions. Let's see if he detects all the screens.
You're gonna have some live demos, right?
I'm not gonna have any demos.
Oh my God. This was the deal.
I'm sorry. Have you seen my content warnings?
So I push to have your talk at this conference because networking is always a proprietary black box, which we hate. So you have to help us break into this world and make it less proprietary, and you have to demo and show us as much as you can.
Right.
Pushing the pressure on you.
Right. Okay, that's fine. I work very well under pressure.
Sorry?
I work very well under pressure. Now, I'll probably won't do any demos, but there will be links to like open source stuff that uses this.
Chris and I are both anti. a Power DNS engineer, I think the company, but I'm sure his DNS skills are top notch. He claims he's a bit of an old man and has been around forever, but I don't buy it. I think he's young. I think he's going to give us a great talk on Yang and NetConf, which I kind of pushed for because, for me anyways, I've always felt that networking was kind of a little bit of a proprietary bubble outside of all the infrastructure automation. So hopefully he can bridge this gap and tell us how the future is going to look. Please, a large round of applause for Peter.
Let me just turn it up. All right, so welcome everybody. Thank you for attending the talk. So first off, some content warnings. So there will be no YAML in this talk. If you need your fix, I'm terribly sorry. I will mention XML and some related technologies. So if you are one of these people that really hate it, I'm so sorry. There will be ASCII diagrams. Yes.
Can you put the mic
A little bit closer? Yeah, sure. Is this better? Let me just. Right.
You talk. I'll mic.
All right. I'll just keep talking. There is a mention of DNS as well. Not that many, and I will have some bad memes as well for you. So the agenda. Firstly, I'm going to give some introduction, both on. Sorry. That's fine.
How's that?
I can almost pick my nose with it. That's fine.
I won't.
All right, perfect. So I'm going to give you a small introduction on both me, how I got here, and what I'm going to actually, what I did the last couple of months. Then I'll just talk about the solution, which means I'm going to talk about NetConf and Yang, what they are, how they work together, and how you can integrate it, and then how does this work in a more of a Unix-style environment, because this is networking technology, and as we know, the networking boxes are 100% different from all the machines that you and I touch daily. And then I'm going to do a wrap-up. If you have any questions, just interrupt me, or just do it at the end, whichever you like. So I have to, introduction. So who am I? I am Peter, and I work for a company called Power DNS. So I work for a company called Power DNS. You might have known them. We make a very nice open source name server. My title is Senior Power DNS Engineer, which means I have no clue. I just write some C++ and some Ansible in my life, and people are happy with it. Notice the lack of network engineer here. I have never done any networking except for like DNS, which people accuse me of being good at. And I've been doing CI/CD in my life. So how did I get here? A couple of months ago, the research department of one of our customers came to us and said, okay, listen, can you please Yangify the Power DNS authoritative server? And we're like, what the hell? What does this mean? What are you talking about? And we're like, well, you just create a model, and you create this model for the server config, and the data that's in there, and then magic happens, because then we can just see this as a network function. And I'm like, what? What does this all mean? So then he said, okay, listen, hear me out. This thing's falling down. Just have to bend over each further. Yeah, perfect. So he said, hear me out. We have a fully defined nationwide network that is 100% software defined. It goes so far as they even use this NetConf protocol that I'm going to describe a bit later on to provision and configure the modems at the customer premises. So there is no TR69 going on, there is no other protocol going on in the network to configure, there's only one thing. For them, the network is just a big machine that has one entry point, which is the NetConf protocol. And all of the devices are known as elements for some reason. So a switch is an element, a router is an element, and with and within this concept, there also exists the concept of functions. So there is a network function. For instance, DNS would be a network function. Routing would be a network function. Having a MPLS network or an MPLS route setup would be a function of the network. And most of the ISPs and telcos are moving towards this kind of a model, simply because the 5G standard requires you to do all kinds of what they call network function virtualization, which is even a European standard. So The issue currently with most of the networking devices that exist is the CLI is different. Has any of you ever done things on a Cisco and then had to switch to a Juniper or some other device and were crying over your keyboards because you forgot how this device works? That is a problem. The other one is if you want to script this or do some automation on this, you're going to need to use expect, and different CLI versions might have different outputs. So if you get a new device that might have just a newer OS, everything's gonna suck. Also, there are of course different configuration APIs that many of the vendors have. And if you have a heterogeneous environment, it's just going to be painful. You cannot switch out a Cisco switch for Arista or whatever. Then there's SNMP. Who here is old enough to still know what that is? Wow. Okay, now I feel not so old anymore. Who here has actually written an MIB file in their lives? How was it?
Painful.
Perfect. Okay. So one of the other problems with SNMP is, first of all, it's unreliable. It uses UDP. Secondly, there is no real state. So, for instance, I have a counter that just tells me the amount of packets that passed a port. You can retrieve them using SNMP walk, but there is no real easy way to connect this to the configuration of that port. So, at some point, the IETF, or at least the network operators, got tired of this. And they published RFC 3535, which just is called operator requirements. This is in the time that the IETF was actually making documents to tell you what actually is going on. So section 3 is just a 12 requirements, which boil down to just we need automation and it has to be standardized. So in short, heterogeneous environments are painful. You need some standard configuration, API, or however you want to call it. And we need configuration and data in the same way. And these networking people, they're not different from us. I got this from a book on network management, and it says the CLI is no longer the norm. If a feature cannot be automated, it does not exist. And I believe this comes very close to the way of thinking, especially this room in the config management conference. We want to automate things, and if it's not automatable, it's undeployable. So the solution, of course, is a ton of documents, because this is the IETF. This is what we do. And they've published a lot of documents. As you can see, they're about the first one is about 13 years old. And it consists of two parts. The first part is the actual communications protocol to do network configuration of devices, which is known as netconf and restconf. Netconf, I'll get to that, and restconf is some REST API-like thing. Yang then is the modeling language to actually describe a device or the function of a device. This is a tree structure that I'll get into later as well, where one would just model the whole device and say, okay, this part of the tree represents this switch port, and these are all the functions that the switch port has, and these are all the counters that it might have. Yang actually means yet another next generation, so now you know what it means. So, how does netconf work? It is a 4-layer protocol, if you disregard everything that's underneath the communications layer. And it mandates secure transport. So I think the only mandatory one to implement is SSH. So if you have a network device, it must talk SSH to do netconf. Then it has some message passing, which is all XML. And on top of that, there are some operations. The operations are very few, so there are a bunch of them. You have lock, unlock, so you can lock the configuration or the data store that you're working on, or unlock it. You can do some transactions, and there's a retrieve information, a set information call, or set data call, and that's about it. When you look at a more bigger picture of the whole stack, so you have the Yang, that's actually the modeling language. once you have described a device, it becomes what they call a model. This model, because it's just a tree structure, you can represent it in any way, shape, or form you'd like. Specified as XML, there is a JSON way of doing it, which also means you can probably do it in YAML, but nobody's doing it, and I guess we all know why. Then the transport mechanism is usually the netconf protocol, which I showed you is the XML-based messaging. Then there's also restconf that takes the model and then models the URL API on top of that. So that is also standardized how you translate the tree structure to a URL endpoint and the messages as well. There's also some gRPC and protobuf going on, although those are not that heavily used as far as I could see. Then you need, of course, some orchestration. There is the NSO, which is a Cisco proprietary orchestrator, although you can download it for free and play around with it. There's the Yang development kit, also from Cisco. There's Open Daylight, which is an open orchestrator for this. And there is also the ONAP project from the Linux Foundation, which is a full stack of tools to control and configure a whole network that also can do Kubernetes and all kinds of weird things, where netconf is just a small communication bit in there. So when talking about netconf, what features does the protocol actually have? So on the one hand, you get CRUD operations for all your configuration. The configuration is fully declarative. You have a device, it has a model, you know this device has this model, so your orchestrator can tell the device, hey, please, for these leaves in your nodes, set this configuration, and the device will say, yeah, sure, I know how to go from the state I'm currently in to the state that you ask me to go to. So the state will always be on the device, not in your orchestrator. Your orchestrator just has the view of how the system should be, and it pushes it out, and the devices will converge to this by themselves. The configuration and operational state is defined within this model, and it's quite human readable because you can get XML or JSON out, and even the models are very, very readable. There is a possibility to do network-wide transactions with full ACID properties, which is very neat. I can have a network of 50 different routers, and I want to have a couple of new routes between them. I can start a network-wide transaction from the orchestrator, tell all the devices, okay, here's your new configuration, and I do it a two-phase commit. Please apply this. If the configuration is bad, then the device will say, I'm sorry, I cannot apply this configuration for you. If that's all good, they will tell you, yes, I have committed this, but if I don't hear from you in 10 minutes, I will roll back to the previous configuration because you might have misconfigured me and I'm now unreachable. So you can do full transactions over your whole network to, for instance, deploy a MPLS VPN from one end to the other. And if one of the nodes in the middle fails, it will roll back the whole transaction. So there is no half state in your whole network. Additionally, because this is all modeled and the devices internally also have this tree structure, it is very easy to go from state A to state B simply because they just apply a diff on the tree, knows what changed, and take the appropriate actions. So who uses and/or implements all this? There is, of course, most of the big vendors. And by the big vendors, I mean Cisco uses it, Brocade uses it, Juniper uses it, HP, Alcatel-Lucent, Arista, Dell. Everybody has implemented this. I don't think there is any other standard that most vendors agree on that they should implement. So this is quite something. And I believe that Cisco, even if you log onto the CLI is just a wrapper around the Yang data store that they have internally. So it's not even, you're not even having something separate. It is the same thing. You just talk to it differently at that point. Like I said, there are a bunch of orchestration frameworks. There's ONAP, that is from the Linux Foundation. It is a very big suite of tools. And also the ETSI, so the European Technical Standards Institute, I believe that's the acronym, or it might be French, I don't know, because it's European. They actually have the NFV, so the Network Function Virtualization Standards, that require you to have netconf. So if you have customers in the telco world and they're moving to 5G, you're probably going to have to either read the NFV standard or just say, yes, I know what I'm talking about. Also, it is a huge standard. And there are several Unix applications that support this, and there are some libraries as well, and I'll get into that later. So, how do I model data? So Yang, like I said, yet another next generation, because they tried, I think, 3 times before to specify some next generation protocol for configuration, and at some point they just ran out of names. So the schema defines the data. Think of it as a DTD for XML, but not as shitty. I mean, DTDs are just very ugly. So the netconf server, by server then I mean a device that has netconf. It has a instantiation of this data tree, and this tree lives in memory or on disk. You have the concept of different data stores that I'll get into, but as you might know if you've ever touched a router, for instance, there is a copy run startup, whereas if you would pull the power, it would start up from the startup config, which can be different from the currently running configuration. The schema, like I said, it is a tree, and the cool thing about trees is you can make references within the tree to other parts of the tree, and the whole model and implementation ensures that if you make a reference to another part of the tree, it must exist on the other side as well. Otherwise, your configuration is rejected by the device. So how does this language look? And don't be scared. It is not as hard as one would expect. So I've been doing this for 2 months, 3-ish months, and I get most of it. And it's actually relatively easy to write these models. So here I create a grouping. A grouping is nothing more than a bunch of leaves, so end nodes of the tree combined. I call it endpoint. I give it a nice description, which means that if you ever would read this, you know what it means. And this has an IP address, which is of type IP address without a zone marker or without a zone information, and it has a port. I then have a container, which is configuration. It says it has a list of listen addresses. A list is as a dictionary in Python. It is keyed to a certain name, and it has an n amount of end leaves in there. The name is a string, and however, also the IP address and port must be unique within this list. So if I create a list where I have 2 IP addresses and ports that are the same, give it a different name, it will still be rejected by the device because it says no, these must be unique. And it uses the endpoint here as well. So I say, please take that grouping endpoint, which are these 2 nodes, and just put them in this container that is called listen addresses. However, I'm doing something special here. I'm saying, listen, it's nice that I have defined this IP endpoint. However, for this specific device, the endpoint is usually an SMTP server, for instance. So I refine the port leaf to have a default value of 25. If you then try to send me some configuration without the port leaf in there, that's fine. I'll just say it's port 25. And if the configuration then changes, I can do things with it. The bottom one, the container there, has the config false in there, which means this gives you some state. If you would inquire about the state of the device, this would probably be a counter on how many connections were on the server or whatever. I didn't put a description in it because this is just an example anyway. There are some tools to actually express this tree for you. So this is made by Pyang. And it's very simple. It just tells you I have a module, which is called my example module. It has a read-write container, which is called listen addresses. It then has a list in there, which is called listen address. The star indicates that it has 0 or more. One of the other constraints you can do in Yang is, for instance, say, okay, I have this list, and I need a minimal of n elements or a maximum of y elements. It tells me the port is optional, but the IP address is mandatory. And then there is a read-only counters container with a connection count in it, which is typed as a uint. So these things that I just talked about, here are some definitions. So the grouping, it's a set of nodes that you can reuse. So the IP endpoint, if I have a very big model which has multiple listen ports, or if I have a DNS server that needs a master but also something that can be notified, I could use the same grouping just within a different part of the tree. Container, just a set of related nodes, just to make things easy on yourself. You have the list, which is a keyed set of nodes, so it's like a hash map where the keys must be unique, and you can put some extra constraints in there. And then you have a leaf list, which is just a list of single items. So I could have a leaf list of IP addresses if I want, for whatever reason I need. Then there are a bunch of like built-in types. After that, you can actually redefine or revise some of these types. You have all the things you expect: integers, decimals, strings, bits, booleans, enumeration, and unions. Unions can be used, for instance, if I have a end node that describes a remote endpoint. I can say, well, it's either a string, or even better, if I have a type defined for URL, it's a URL, or it's going to be an IP address. There's some other tools within the language. So there's the import statement. Many of the standard organizations have created default modules. As you saw earlier, there's the inet IP address that I used. That is actually a module made by the IETF. They have taken all the IANA registries and all kinds of handy things that exist within the networking world and made ready-to-go modules for them. Which means that any vendor can just pull them in. So if I want to use an IP address no zone on a Cisco device, I can, because Cisco implements the same thing as Juniper does. There are also standards that you can import, like there's an SSH common, an SSH client, and an SSH server module from the IETF as well. This will allow you to model a SSH server. But because you have this, you also need suddenly certificates, so there's also X509 stuff. There are a lot of ready-to-go modules. You can use augment. Augment is a way of, once you have imported a module that, for instance, defines a network interface, but however your device that you're building does not support providing counters to you, you can say, okay, I have this interface, it has a name, it uses this basic module, however I augment this part of this path within the tree to not exist because I don't implement this specific part of the module. There's grouping, like I said, the set of nodes, containers, and there's a feature flag. This is very neat. You can have within the model a couple of features defined. For instance, a device can have the feature, I support a DHCP server. If you do not turn this on, parts of the tree are just not possible to see or set because they are marked as only enabled when the feature is enabled. So the tree is always the most minimal set of, is always as small as it can be. When you look at these upstream modules, so the port number that the IETF has, it's just a uint16, which is of course the proper size, and it has this range. That's nice. So if you ever have written a regular expression for an IP address, this is how you should do it, according to the IETF. But now you never ever have to do it because you can just reuse their module. Underneath, you see that they have defined also a IPv4 address no zone. So that means there is no % with an interface name behind it. And the pattern is way simpler. That is because if you make derived types and put in more constraints, the constraints are ended together. So if you have so here you have the first one is a proper regular expression for a real IP address. The second one just says, yeah, we don't need all that cruft in the back, so this regular expression combined with the first one is fine. And you can keep deriving types. I could even say, well, I'm going to take the IPv4 address no zone and going to derive my own type, which is an IP address with a 0 at the end always. And you can do that if you want. Then, like I said, we have unions that you can combine things. So because we have 2 IP versions on the internet, although many of the cool cloudy stuffs don't agree with that, they just have IPv4 and that's it. There are actually 2. So you can create a union type that is either an IPv4 or an IPv6 address at that point. So this is the model I showed you. So I'm just using the IP address no zone, and I know because of this it's going to be an IPv4 or an IPv6 address. If you try to insert any other data, the orchestrator is going to say no. If the orchestrator is badly written, it will try to push out this configuration information to the device, and the device will say, "Nah, that's not the right format for this thing." This is also what I said before. I'm using an endpoint. I refine the port. It's going to be default 25. If I would make a model and would say for the port the default is going to be foobar, I cannot even load this into my application because it says, sorry, this just is impossible based on the previous definition of port. The same for the counter. So it's just a type and it's fine. So the reuse of models. You can keep importing modules. So if there is a vendor that has something special, you can just import it and reuse it. Like I said, modules are published. ITF, Etsy, there's the Open Daylight project. They do very cool open source Yang modules that have, well, they're not basic, but they have all the building blocks that you need to ever describe a device, other weird things. There's a large collection of building blocks, TLS server, client, already discussed that. And many of the, let's say, downstream vendors use these modules to describe their devices. So you get a lot of bang for your buck if you have good groundwork. You can just take a different device, and with minimal changes, you will probably have the same configuration on there within a few minutes. And there is a GitHub project that collects all these, which is quite nice to look through. So if you're looking into a tree structure, there's always the point of addressing. The ITF, in all its wisdom, chose to do XPath because it's pretty good expression language. It's, I think, from the W3C actually. And it can do all kinds of weird things. You can do things by name. You can say, okay, give me the latest element of this list. You can even give me all the interfaces that have a Y in their name. I don't know why you would want to retrieve this information, but you could. So if you are running a big network, it is very simple to retrieve the most minimum set of data that you might need for whatever operations you're performing. So how do you create, or how are these servers built in the end? So a netconf server is just a device that exposes port 830 TCP, where you can connect via SSH and then talk netconf over that connection. So this the client app can be anything. It can be your laptop using a netconf client. It can be the orchestrator. It doesn't really matter. It just talks to the netconf engine to do all the RPCing. And then there are the models that have been loaded into the device that you see at the top. The server has a bunch of metadata. It has also its configuration database. It has its state data. It can do notifications. I'm not going to get into that real deep, but you can configure a device to send notifications over netconf. So you can tell it, okay, here is my netconf client or my orchestrator. If some counter reaches some certain threshold, please send me an RPC message so I can get alerting. So there is some pull or some pushing going on if you want. Although that's a very relatively recent specification. Before you had to pull data from the devices. And then there are software components that can be anything that is just running on the device. So if you now look at this describes any kind of computer. It has some input, has some output. You just need the right format. This is what I've been playing around with. So there are a bunch of data stores that are defined. There is the startup data store, so that is once your device boots up, this is the configuration that it gets. Usually one would copy the running configuration to the startup configuration every time you make a change, but you don't have to. There's the running configuration. This is a data store that tells you the exact configuration the device has at this moment. That is, I think, the only mandatory one that one should implement. The other ones are all not mandatory. When the device boots, startup is copied to the running config. And there is a certain candidate data store as well. The candidate data store can be used to do multiple changes in multiple different netconf transactions. And once you have a candidate data store, you think, okay, this is going to have to be the final configuration of the device. You can say commit, so you send a commit message to the device, and it will copy that to the running configuration. And if you do this two-phase commit thing, it will do it. And if it doesn't hear from you within 10 minutes saying yes, confirm, then it will go back to its previous configuration. And then the last one, that is the operational data store. It's kind of a virtual data store because it's kind of a view on the whole device. So it's a layer in front of your running data store that includes any other state data that might be on the device. So if you're, this is straight from the RFC, of course, as you can see by the nice font. The operational data store has configuration items, has non-configurable items, and is read-only, because that is the exact system state. And it just cobbles together the whole tree of everything that's on the device. Which we'd love to give some demos on this, but first of all, I don't like giving demos, and secondly, working with netconf from a command line is quite hard, I think, although many of the frameworks I described make it very easy to do small changes. So how would this work on a Unix kind of system? And first of all, why should you care about this? Because this was my first reaction when this customer came to us, like, why would we care? We're a software company. We deliver a Debian package or an RPM with some software, and here's the configuration information. Have fun. So, according to many telcos, which is our biggest line of customers, many of the applications that actually run on the Unix system can be considered a network function. So a DNS authoritative server would be a network function. A mail server could be a network function. So they would like to have this configured in the same way they are used to configure their whole network anyway. So with the right orchestration, you can even have a versioned infra, because the orchestrator keeps, of course, a log of everything that it did, and because it can just know the whole state, or at least the whole configuration in a tree structure, it only has to save the diffs. So if you want to go the other way around, it can easily generate a new message saying, okay, please, this is going to be a new configuration, and it's going to be a rollback of the previous one. Also, configuration management in telcos is not very common. Many of the departments, so from what I've seen, many of them are split. Either in well, we've outsourced everybody, so let's not talk about that. But there's going to be a Unix department and there's going to be a networking department, even though they have to work together and are basically in each other's, fishing in each other's pond at that point. In the Unix department, you see Ansible, you see Puppet, you see Chef, all these things. But the networking people don't want this, because that is not how their devices can ever work, general purpose computing devices. And even without netconf, when you think about it, Yang is actually a very powerful language, or a very powerful way to do the configuration of a single piece of software, because you can very strictly define how this configuration should be. You can have a configuration option that is of a unit that you call %, which means it's an integer between 0 and 100. And if somebody tries to configure anything else, it's just going to error. I have looked around a bit. I think there's like JSON schema that allows you to do this. There is a DAL language that is for Haskell. It's actually very neat. DAL actually also allows you to do some scripting inside the configuration definition language. But then you have to run Haskell and everything. And having just typed and constrained things in your configuration just makes a lot of sense, in my opinion. And of course, it integrates into telco environments. So if you have a customer that is a telco, you might get asked about this at some point. So what kind of software exists? So this is all open source. So there's libyang, which is made by the guys from CESnet, I think. Although many of these tools, like the first three, are I think written by the same guy, because every time I file a bug against one of them, the same guy responds. And so libyang is a Yang parser and toolkit. It is very neat. It gives you a way of loading a Yang schema and then just create nodes or retrieve nodes that have been configured beforehand. You can give it a bunch of JSON and say, hey, this is the configuration, by the way, and it will tell you, oh, but in the model you defined, this is not correct. You're trying to put a string where an integer should be. I've used this in one of my in the program that I'm going to talk about in the next slide. To model the PowerDNS configuration, and now it just errors out if you try to put a non-IP address in a field that needs an IP address, whereas the regular PowerDNS would just restart and then not start because I don't get it, but there is no check beforehand. There's also libyang has C++ bindings, which is nice for me. It also has Java, Python, and JavaScript language bindings. So if you would be interested, you can write a tool in any language and just have configuration modeled via Yang. Then there is sysrepo. This uses libyang as well, but this implements the actual data stores. So you can have on your Unix system a Yang data store, a running configuration, a startup configuration, and you can manipulate this. Netopere is a netconf server that also talks to sysrepo. So if you have a netconf server, if you have Netopere installed, it will talk to sysrepo, and if you have something that listens to that, that also just goes into the data store, you suddenly have a network device, according to many people in the networking world. There's the YDK from Cisco, which is a Yang development kit. This allows you, if you have a Yang schema, to create bindings in several languages for all the information that's in there. So it would just create a server stub for you that you can just have to fill for actually retrieve or for sending the right data. And then there is PyYang, which is a nice validator and transformer as well. So the thing I've been writing, it's called PDNS sysrepo because it's a sysrepo plugin. It uses libyang and sysrepo, and it can configure the PowerDNS authoritative server. Because PowerDNS doesn't actually use libyang or sysrepo by itself, mostly due to licensing issues, this is a separate tool that listens to sysrepo. Upon startup, it will actually pull down the configuration that is in the Yang data store and will write out a configuration file on disk, then ask systemd, please restart the service. And as we are templating all of this, we know that the configuration is going to be fine. We also know, because we have the model correctly, we know that every element that we're going to put in this configuration already has the right format. It can even store zone data in sysrepo. I was first very much against this because from my perspective as a DNS server writer, zone data is data. It is not part of the configuration of the device. But if you talk long enough to these networking people, they say, no. The data is also configuration for us because it is a function. So I just say, this device has a DNS function, and this is the configuration of the zones that it has. This is the data it needs to serve out. This was a source of a lot of confusion in the beginning. And for PowerDNS, those who know it, it exposes a remote backend. So it just has a small API that PowerDNS talks to actually retrieve this data from sysrepo. And it's actually quite fast because the whole Yang and sysrepo data store are in memory. So wrapping up. In conclusion, the network world is not as different as we are, although they just work on a very, very different level. Yang and NetConf are the industry standard, so there is no fighting between the different, well, fighting is maybe the wrong word, but there's no competition between the different configuration management methods. There is just one, or you're stuck with a CLI. I think it is a viable technology to use within your Unix applications to at least have nicely constrained configuration languages. And that's it. Thank you very much for having me. If you have any questions, I'll be here today, tomorrow, or you can do it now. Thank you.
Do you have some questions for our fabulous speaker? We have actually time. You're 5 minutes early.
Yeah, perfect.
So we have lots of time for questions. And if you don't ask 5 questions, we don't let you go on the break. So please.
or I can show you some demo if it's working. If you
see a demo?
All right. Let's see if I have to. Let me just close this one. All right.
And if David, Adam, or Matteo, the next 3 speakers, are here, please come up and see me. And if you know them, ask them to come see me. Please. Thank you.
Wait,
demo works. You get the chocolates. Otherwise, you.
Oh, okay. Let's see. All right, so let's hope it works. I'm just going to quickly copy my screen because otherwise it's going to be hell for me to actually know what I'm doing. All right, so let's go. All right, now I can actually see what I'm doing. All right, is it? Yeah. All right, good. So let's see. It has been a while. All right, let me just first look at the modules that I have installed. So I have, hopefully, everything ready. So, because I didn't expect to do a demo. That's not my password. Nope, that's not my password. There it is. All right, well, that's unfortunate. So, as you can see, I'm asking sysrepo, hey, can you tell me which modules I have installed? And I have a bunch of them installed. So I have a DNS zone common. I have some IANA things, I have a bunch of ITF things, and then I have the PDNS server one. And I have enabled a feature called RSet management. So if I have a look at the, let's see, yeah, there it is, good. So give me an export of the running data store. Let's make that through less, because otherwise it's going to probably be a lot. Oh, why are you, oh wait, I did the edit one. Hang on, give me a second. -e is edit. So this is my configuration at the moment. I have a master's endpoint, which just means this is a named endpoint for a master of a zone. I have some other configurations. So my service is called this, so it knows which service to restart. And please write the configuration file out to that. Because my tool, PDNS sysrepo, is configured with sysrepo. When I started out, it was a YAML configuration file, and then I realized, wait, I'm using a configuration data store for everything else. Why not for the tool itself? This is the server configuration itself. So I have a bunch of listen addresses, or actually I have one, and the one's called main. It listens on this IP address and this port. And I have slave turned on and master turned on. And I'm defining a bunch of zones. So to show you the power of this, so this is an IP address. This is not an IP address. And if I would want to store this, sysrepo tells me, nah, that is an invalid value that you're trying to put in there, and it just rejects all those changes at that point. Similarly, if I would have the port number on a very ridiculous number, it will also tell me, no, that's not valid. Also, so because I know the model, if I put a foo element here with the value false, and I try to store it, it will tell me, sorry, that's an unknown element. I don't know what to do with it because you have not defined any of this. Yep, so that's fine. So I have a zone. It's called master.example. It has a bunch of zone data in there. I'm going to show you that I can actually query this, hopefully. And it has SOA record, all kinds of stuff. And it has a slave zone as well. So it can actually slave zones and then store the data inside the Yang data store. At least hopefully, because I finished that feature 2 days ago in a bar while I was drunk. So let's just go to the build directory. Ninja. Well, yeah, I used the Maison build system. Oh wait, I have installed a new boost. Let's see if it just works. Right, so I have to build a new version because I installed an update to Boost yesterday. I'm sorry about that. In the meantime, let's just have a look at. There we go. Let's see if I can actually get the operational data store as well.
This should have been the talk.
Oh, I'm sorry. Well, let me just show you the model. So there it is. So although I'm not a big, so I started writing this a couple of months ago while I was very green with it. I would have done some things differently now. But as you can see, I am importing a bunch of things. So I am importing the INET types, which I prefix with a certain name. This is a draft that is now out. This just says, okay, this number is this record. It's very easy. A bunch of revision data, backend information. So here's the endpoint that I've shown you before, and let's see. This is So this is how I define all the data. So if I have a SOA record, it has a bunch of other information. So it has a bunch of leaves. It's the M name, so the name server name. It has the serial, the refresh. Well, all the fields you would get are separate leaves because they have their own rules. Millions of containers for all those tools. So what does the zone look like? Well, it has a name, it has a class, it has a zone type, native, master, slave. It can have a leaf of masters, but only, you can see there, when the zone type equals slave. And it will actually reference the masters I've showed you in the configuration beforehand. And this element only exists when the type is slave, and if you put in 0 masters, it will also error out because you need a master if you have a slave zone. Well, a bunch of other configuration, state, there's a web server information, and this is the sysrepo itself. So you can see here, I have a string for the service, however, it must be something.service in the end. And you could even do way better things than I did in the regular expression, but this is good enough. So let's see if we can, Right, let's see if it works. Okay, neat. I just need to start PowerDNS. So one of the things you notice here, because I'm running in debug mode, it actually tells you the configuration it generated from the data store. So I have no AXFR ACLs, I'm not notifying anybody else, and it's launching a backend that just listens, or that just goes to my tool itself, and the web server is disabled. And then a bunch of other information. So let's see, PD. I have a different directory with all the config because I am like that. Conf, netconf. All right, and I'm pretty sure that PowerDNS now won't start because it also has to be rebuilt against the boost. Yeah. Yeah, that's going to take too long. So just believe me when I say that the information that is in the data store can be retrieved through DNS, which then goes through my tool and looks in the data store and just gives you the information. And you can just online change this. And just before this talk, I had confirmation by our customer. They're running this in a test environment, that this is actually integrated with their Cisco NSO right now. So their orchestrator knows about this, and they can now serve data straight from Yang. So yeah, I guess that is the time, right?
That's it. One more large round of applause for Peter, please. So if you want to bother him for some questions, they're €1 each, but come up and ask him. Pay to me. And for everyone else, we have a 20-minute break, so go grab some water. I think there's coffee and other things in the main room. Be back at, 4 sharp, for 3 more talks in this room, and if you check the schedule, there's some other talks. So once more, round of applause for Peter, please.
Thank you very much.
Thank you so much.
Yeah.
Hello everyone. Are you ready for more talks? Sure. Everyone in the back, come closer. You'll have a better view because the screen is not very big. Is that? It's not a good joke, but I just didn't have time to write anything better. I'm sorry. So seriously, come closer. It's silly being spread out in the big room. Come down to the front, you'll have a better view. And the oxygen is better down here. Now we start. Yeah. We start in like 3 minutes, so you have some time. Is Adam the next speaker here at all? In the room? No. If anyone knows Adam, tell him to come find me. Left. He left? Left. That's okay. Sit. I will introduce you. You're gonna walk on. It's gonna feel like a big presentation. You can hide, pop out, and be like, "Hello." I don't know, whatever you want. Nice dinosaur.
Yeah.
Wait to let a few people come in. Because your talk is tight.
Well, I'm going to go through a workflow and can extend it or make it smaller.
When I put the 0 minutes, if you get to that far, you'll have the new speaker setting up, and there'll be still a few minutes for questions too. You can do them at the end of your talk or while the speakers.
Do you have a? You can put on a timer as well.
Yeah. Basically 45 minutes till the end, and then stuff like that. All right,
It just makes sense.
Hello, everyone. So, I have the pleasure of introducing David. I'm going to pronounce his last name wrong. Heikamp. Yeah. Close enough? Yeah? Yeah. All right. He studied some political science, but he's a hacker like us now. He's into cycling, and the word on the street is he likes hip hop, at least partly. So please give him a huge round of applause, and let's hear what he has to say. David.
That's a nice introduction. Yes, welcome to episode 2 of Doomed Are the Dinosaurs. How many of you went to FOSDEM? And how many of you saw the episode 1, so to say? Oh, that's a small number, so I'll do episode 1, kind of what happened in episode 1. First of all, in episode 1 we saw Trix, our T-Rex, being introduced. Trix lived 66 million years ago and is now one of the main attractions in our Natural History Museum in Leiden, Naturalis. And apart from the introduction you heard, my name is David Heikamp, as pronounced really well. I'm living and working in Leiden. I volunteer as well at Vrijplaats Leiden Social Center. I'm an open source enthusiast ever since installing Debian by hand in 2004. And this is my third year in config management camp, so it took me 9 years at FOSDEM to give a talk, and this is the third year config management, so that's going quite well. If you want to get in touch, you can send a mail. In episode 1, I introduced and explained a bit more about our use case. And that was basically to deploy and manage an entirely new natural history museum. So this is kind of the completely different use case than running something in the cloud or data center or stuff like that. Maybe it's kind of the opposite of the cloud. So we were asked to deploy 10 exhibitions with all kinds of media players, projectors, microcontrollers, everything except servers. It needed to run on a campus network. We needed some tools to manage the museum. So also in episode 1, I explained a bit about our circumstances. I told a bit about, especially at FOSDEM, but also on config management camp, you have all these like dozens and dozens of tools and approaches and best practices and stuff, and you, as an operator, well, in our case we need to build a museum, you have to select stuff and tools that best fit your specific circumstances at your job. So to give a bit of an overview of our circumstances, we work at Naturalis Biodiversity Center, which is first and foremost an institute that manages the natural history collection, which consists of 40 million specimens. We're running a research institute as well, so a lot of researchers doing all kinds of analyses related to biodiversity research. And of course we are a natural history museum that's popular especially with kids and families, which gives a special, well, let's say some of the kids tend to break stuff. And for a support organization, this means the fact that we basically, our institute does anything related to biodiversity is puts a fundamental challenge to you as a support organization, because you have to support a really diverse set of services. On the one hand, kind of running a cloud for research analyses, HPC kind of workflows, and on the other, doing media shows and stuff like that. When we started the project, we already had been to the first config management camp, and we also had quite a few years of experience with config management. So we used we're used to using Puppet and Foreman for deploying servers. For our web services, we have our OpenStack and Ceph infrastructure. We had some experiments with Kubernetes, and after the museum project decided to cancel those. We have a team of 35 people working in the IT department, I think, and some of them are operators, some of them are developers. We have some support staff, and as I said, we have to kind of manage a really broad set, so Kubernetes was a bit too tipping us over, so to say. And we had some experience, for example, with analytics tools like Sensu, ElkStack, and Grafana. Also an important aspect when building the museum was that it wasn't ready yet. So in this picture you see the actual building being constructed. The part on the left is an entirely new building for the museum, but the project was already started to actually build the museum and all the exhibitions. And for example, we had to also work with suppliers really fixated on proprietary solutions. So typically in the museum world, you have several companies in Holland that are really focused on building museums, and they're really used to bringing in their closed source equipment. Basically every setup is kind of special, considered as a special. So this whole kettle versus pets kind of debate they really are not aware of such thing. So it's really the stereotypical pet setup. Also, in a museum, there's a really broad set of technologies involved that are really different than the things you see in a typical data center. And of course, we had a tight schedule. So these were all a set of circumstances we had to work with. And our approach was to basically, in an effort to keep the diversity of technologies we have to support, to keep that down, like what was mentioned this morning, we decided, okay, we need to build on the existing infrastructure and the know-how within the organization. Also, we wanted to use as much as possible high-quality open source components in our museum, and apply this infrastructure as code and DevOps practice to not only the infrastructure but the museum as well. I think it was during another talk that someone asked, okay, how did you manage to convince basically the rest of the organization to do this? And it was actually a big part of the work to get the external suppliers, to get them working together with us. But also internally we had quite a bit of opposition to our plans. And basically we more or less built this architecture consisting of a lot of open source tools. So on the top you see different sets of user groups that are involved with the management of the museum. On the bottom you see a diverse set of equipment and devices that needed to be managed. And in the blue you see several management tools like GitLab for version control, Mattermost, etc. And we put Ansible in the center of it all. Ansible and AWX. Basically as the glue between all the systems, and as the automation tool for basically most of the automation tasks we had to perform. And the choice for Ansible for us wasn't maybe not, we didn't have a lot of experience with Ansible when we started the project. The experience we had was in another museum where we had to basically were rushed in pretty late in the process of building a new exhibition, and basically in that case a supplier had already installed Ubuntu Linux on several devices, and we had to make sure the applications were deployed. And based on a simple inventory file of all the computers, several simple playbooks, we were able to, in a really not ideal situation, to actually perform that task pretty well and pretty in a consistent manner. And also, Ansible was really the most popular config management tool. At least that was our impression for network automation. So the idea that we could use Ansible for basically not just the museum but the rest of our infrastructure as well was really appealing for us. So that was why we chose Ansible. And in episode 1 still, I went through the scope of automation we perform, and this is basically the end slide. So basically we, on several layers and dimensions, we use Ansible to automate several workflows. So for example, deployment of switches, we use only bootloader and zero touch provisioning for installing Cumulus Linux on white box switches. We do that process with Ansible and AWX as well. Installing computers with Metal as a Service MAS. Configuring the roles on these types of devices, getting content on them, having actually a workflow that goes over the switches and the computers as well, but also even updating firmware for our Arduino microcontrollers. Or getting the network configuration for our projectors or sensor checks ready for those devices, or putting on the power with KNX gateways and having workflows across these different types of devices, and even being able, because of AWX, to delegate or schedule those workflows. So this all resulted in a running museum, as you can see here, with games, projections with MPV, for example. And as I concluded in episode 1, I think our lesson at least was really that the specific local circumstances are really vital for technical and organizational choices we make. Especially if you have to, well, there's so much happening in IT, in open source, in DevOps. It's quite something to translate that to your specific situation. And we concluded really, okay, our fundamental challenge is to cover really broad scope, and we need tools like Ansible that are well suited to support all those different kind of automation requirements. And also sometimes you have to deal with a situation that doesn't really fit into a model, for example, that a tool like Kubernetes really you really need to translate everything into the Kubernetes world, and it's just not possible for certain situations to do that. And of course, we used a lot of open source tools for the entire museum. I think we came pretty far in basically switching or running everything on open source tools. So in the rest of this talk, which is basically in episode 2, I want to go through and show you a bit about the one of the more complex workflows we made in the museum. So what I'm going to show is deploying one of those interactive devices, one of those computers in the museum, and we do that in one workflow from AWX. Who's familiar with Ansible Tower AWX, by the way? Quite a bit of people. So basically, the idea about behind AWX is to have a central place from which to run playbooks and automation, Ansible-based automation. And it gives you the ability to, the fact that you work from a central place makes helps with getting an overview of what actually is running. When we were building the museum, we were still running stuff from our laptops because we didn't have everything ready yet, and sometimes that you have several versions and stuff like that. So it really helps to simplify stuff and to have go back to the logs of a certain workflow, and you have role-based access to all those automation steps. So it really allows you to one part of your department actually developing the automation workflows, and the other who isn't really familiar with Ansible even being able to execute specific tasks. So in this, no, it's not really a demo because we're gonna go over something which already ran, and basically it's all really starts with with the inventory. Is it big enough, or well, maybe a bit bigger? So in our case, the start of everything is with the inventory. So we have an asset management tool called Topdesk, and we decided, okay, we're gonna keep the inventory in a version-controlled repository because we want to be able to see the changes, who made what changes, and not use something kind of a dynamic inventory kind of thing. So basically what we wrote is a simple script to get data from our asset management tool and translate that to host variables, and it's just a subset of the variables that we work with. So for example, in the command you see here, you see a specific computer, Hardbank Computer 1, with mostly network-related variables, and basically this is the entire host file for that particular computer. And for example, you see here in the network interfaces, that's what we're going to configure first. The things you see below are related to the fact that it's a media player doing, in this case, having 2 physical buttons you can press to play an audio file. Let me get things. So in this workflow, this is the overview of a successfully run workflow. And a workflow basically consists of several steps. So basically in AWX you have job templates, which are basically specific settings to run a Ansible playbook. And a workflow consists of several job templates that are executed in order. So this is a linear order, but you can also diverge into do 2 steps at the same time, or only execute this job template if there was an error in the former job. But in this case, we just have do this, then that, etc. And when executing a workflow or a job, you can also have surveys. So for example, it's in Dutch this survey, but in this template you get the question, okay, which computer or group of computers do you want to install? Do you want to commission and or deploy the computer, and then proceed? Well, so you see, and you map the answers of a survey, you can map those to variable names. You see those here in the XR variables. Is this visible, by the way? Yeah, okay. So in this case, we answered yes to do the commission, or force the commission, force the deploy, yes, and we set a variable host exhibition to the name of the computer. Also, you see here, it's launched by something called redeploy Hardbank Computer 1, and that's actually a schedule. So it was a scheduled deploy. So you can basically, for us, it's useful to redeploy something after opening hours, and in this case we redeploy 1 computer, but we can redeploy a set of computers or the entire museum as well. So first step in this workflow is these are kind of special job templates. It's updating the project, basically the Git repository containing playbooks, and to update the inventory as well. So we always run these to get the latest versions on AWX. So those aren't the most interesting things, but the others are interesting, and especially the first, and this one runs the determined switches playbook. So the difficult thing for us was here that we needed to do a workflow across different sets of devices. So in this workflow we configure first a switch and then a specific computer. And we have 90 switches in the museum, but we don't necessarily want to update all those 90 switches because of deploying one computer. So we made a kind of a special playbook. It's a bit weird, I have to admit, but this specific playbook determines, okay, which switch do we need to configure in the next step. I'll show you how that looks. It's a bit weird, I warned you. So probably this is what you could consider as abusing Jinja. So in this step we will go back to the, so basically in this inventory for the specific computer we also have as a variable the switch and the switch port that the computer is connected to. And as a group variable it also gets a switch port configuration. I can show you how that looks as well. So for every port configuration, it's not, we want to get an abstraction a bit higher than just a untagged VLAN, because sometimes you need different settings on a interface port as well. So we called that we introduced a variable called switch port or port configs, and we could just name them and then attach different settings for them. So in servers it's just untagged VLAN 115, but you can also get the power over Ethernet, priority high, and tagged VLANs, quality of service, etc. So as you can see here, we have you can't see that here, but we have group variables for all the computers in a specific exhibition. Have switch port config, the name of the exhibition, and then basically this playbook determines, based on the host exhibition variable, which switches need to be configured, and basically the host exhibition is now just the name of the computer, and as an artifact the result of this playbook is, okay, that's connected to this switch, and you do that by the set_stats module, and that is a way that's really nice if you want to have workflows and where you have a result from one job and transfer that to the next job. So in the next step we see, you can see it a bit better now, you see still all the variables that were set in the survey, so force commission, force deploy, you see an Ansible SSH thing that's connected to this job. But you also see here the host switches variable being set by the former job. And then it goes on. I can show you the playbook. We set the host variable with the value for host switches, and that's the specific switch that was set by the other job. And that basically configures that specific switch, and in this case the interfaces on that switch. And for some more Jinja templating, we have here also the template we use for setting all the interfaces on the Cumulus Linux switches. So that includes also quite a bit of a search through the whole inventory to actually, and we introduce kind of a layered approach. So we have basically for all the interfaces a default setting, and then we start here. And for every, we loop over all the ports on the switch. We have a default port config variable that's set as a default. And then we can set the port configurations on the host var of the switch as well. And we can override that one with the host vars set in the specific computers. So it's really, I'm still not sure if this was the best approach to the problem, but it's as a result we can now specify in our asset management tool, okay, this is connected to this outlet, which translates really to this port on this switch, and then configure everything related to that from the perspective of the host. And we didn't have really another way to kind of introduce the variables from the host to the switch than what we came up with this way. And basically this way the correct switch port configuration for this interactive computer is configured. So in the next step, we actually start deploying the computer, and we start with an empty Linux box. Basically, we use these small form factor computers, Intel NUCs in our case, and use canonical MAS, Metal as a Service, to actually deploy those. I'm not sure how many people are familiar with MAS, maybe a couple of them. So basically MAS also is used for bare metal deployments, typically in data centers, with servers typically having some kind of IP-MI interface that allows MAS to turn on the server when it needs to be deployed over Pixie, and then basically manage the whole flow. Well, it's impossible to get affordable devices that run a media player with IP-MI, so we had to come up with something else. Because we actually wanted to have this kind of destroy deploy kind of setup, so we could just from scratch and do an installation from scratch and apply with Ansible all the roles we wanted to do, and be sure the end result was actually a result of our code and not someone doing something manually or something. So let me open the So basically what we do is use wake on LAN to power on the computer, and actually use Ansible to power off computers, and in the process of redeploying we use those two things to actually manage the power state. In practice, sometimes it's not 100% a guarantee when you send a wake on LAN message that it's actually powering on. But yeah, these are the things you have to live with if you're not 100% in control of the hardware. So let me show you the. So here's the setting. Host exhibition is set to hardbound computer 1, and that sets the host variable for this playbook. And basically, we always make sure it's powered off first, and if it's not already powered off, or check if it's powered off. If it's not powered off, enable the wake on LAN. It's a kind of a weird thing, wake on LAN, because it can get disabled within a deployment process if something fails in the middle. So at several stages in the process, we just enable it again to make sure it actually works. Also, a trick to power off a computer without having an error in Ansible. We use systemd run, because sometimes if you just power off a computer, it's not a typical thing you do in Ansible, I think. But yeah, if you send the power off command just straight, sometimes your SSH connection is already gone before reporting back. So with systemd run, we can delay the power off and then report back that actually executed well, and then power off the computer. Then we check if it's still in reach, if it's actually off, then start deploying and configuring the interactives. And we do that with MAS. And when we started with the project, and actually we started with deploying MAS itself with Ansible, and there weren't any existing roles available, but it was a kind of a mind shift, because first when we wrote it, it was really from the perspective of MAS. So for example, we said, okay, MAS, deploy now these and these computers, and then it would deploy a certain set of computers and then report back. But in this workflow, we start from the perspective of the host. So we want to, with the host or the limit statement in Ansible, we want to select the set of computers, in this case one computer, and then say to MAS, okay, go and deploy this computer and report me back if it's actually deployed. So we had to rewrite a bit the role to fit into this Ansible model. And basically in in MAS you have two steps. First you have the commission step, and that basically makes sure the computer is scanned and an inventory is made of the computer. I can show you how that looks. So this is a typical, this is the MAS interface with the page of the machine. And in the commissioning stage, it will get all kinds of information about the computer, actually run some tests as well. Well, one test in this case. And then after it's commissioned, it's ready to be deployed, released, etc. So here you see the output of an installation. Let me see. It's even a nice one of the nice things in this process was, okay, when do you know the computer is actually deployed? Because you want to, from the mass, installing the mass role, or actually deploying the computer, from there you want to continue with the other parts of the playbook. So I really enjoyed this part as a loop, and so in this task we basically ask mass, okay, is it actually deployed already? And if that's not the case, retry in 30 seconds. Because it typically would take 5 to 6 minutes to deploy a computer. So, and if it actually reported back deployed, we could continue with the further installation. So after installation, so it's just a fresh Ubuntu Linux installation. We would power on the machine by Wake on LAN from the mass server in this case, and then actually install some base, a base role for the interactives as well, some monitoring, Prometheus, and then basically based on group memberships, install a role for Unity games or media players or MPV or MPV kiosks, monitoring screens, and then reboot the machine to have it finished. So basically it would run this playbook and be finished in, let's say, 15 minutes on average. So as you can see, we had with this workflow in AWX, we could run over several groups of devices by using the setFacts module, and actually facilitate a deployment of of one specific computer from start to finish, from a completely blank computer up until a fully provisioned interactive device with content, monitoring, etc. And we were able to actually delegate or schedule these workflows in this way. So basically, in conclusion, we're now gonna start building more and more of our infrastructure in our data center based a bit more on this model as well. But I think there's still also quite a bit of improvement to our code and things we do in the museum as well. So, but it really helps us to kind of get the diversity of technologies down and to keep it manageable for a relatively small team. So basically that was about it. Thank you.
We have time for questions if you want, so if you have a question, just raise your hand or something. And like before, if you do not ask questions, you're not allowed to leave, so we need your questions, please.
How did you convince the network and the certain people you were together?
Just repeat the question.
Yeah, I couldn't hear it completely.
Well, you have people with a typical company, you have silos, you have a team, you have a certain team, everything is done with a single playbook.
Yeah, so the question is, okay, in a typical company you have silos like network teams, system administrator team. How do you convince all those people to do it with the same tools?
And if the next speaker is here, please come up.
Yeah, well, you can give
Adam.
probably traditional.
No, yeah. In answering the question, we already had a bit of a cultural shift from a traditional approach for a museum, kind of small-scale company. So we already were using open source tools for our data center stuff. So for us it was more a question of trying to convince the other silo in, let's say in our company, the museum department, and they had really, they were basically just the project managers working with external companies that weren't used to this kind of way of working, and that was difficult to get that message across, but we had the support of our management that helped, and also we had a lot of experience with managing the old museum as well, which didn't really work really well because at a certain stage we were still running Windows 2000 machines because it couldn't be migrated and stuff like that, you know. Like, so that helped also, like bad examples. Yeah.
Yeah, I have a question. So looking at the initial, the first part, architecture, the diagram, it looked like all of that was basically running on OpenStack.
Yep.
So you still needed to put up OpenStack and all of the supporting infrastructure for it.
Yeah, it's just something. Oh, maybe to repeat the question, did you have to set up OpenStack to run basically all the management tools?
So my question is, this is all running on OpenStack. My question is, did you, and how was the experience with actually putting up OpenStack and all of the supporting infrastructure? I mean, there's monitoring on OpenStack, but something needs to be monitoring OpenStack, I'm guessing.
Yeah.
So where is that one?
So it was existing infrastructure for us. We run OpenStack. Originally, we set up OpenStack to support our researchers. So they have, like, they used to have like these big machines under their desk, on their desk to run analyses, and it didn't really scale. So we set up OpenStack to do that, and then we also started hosting web services. So it was existing infrastructure that was already there. So it was a bit out of scope of the museum project. So we basically used what was available internally.
Thank you.
Just before you start, sir, is Adam here, the next speaker? Adam? If not, we'll give your talk to the next. Are you Adam? No. You have time. One more question, if you want. All right, yeah. Big round of applause. So the next talk, if we can find the speaker, is it you? You're Adam? Oh, he was hiding. So in 5 minutes we'll start again. You're here. This is for you, by the way. Thank you for speaking. And hope you enjoyed coming.
Yeah.
So, hi. Where have you been?
I was with Russian. Cool. Yeah, you can get your laptop set up.
After you're set up,
So I would need a power socket and a VGA or...
will you find something? This is yours? It works. There you go. Which connection you're using? This one?
Yeah, I was. But
I don't know. Did you use the VGA before? Audio guy. Sorry, I don't know your name. Is it okay if we use the VGA? Is it okay if we use the VGA? I don't mind you. Try it. You don't mind if we use the VGA, will you?
I don't know about this, so I don't mind.
Perfect.
it's on the other side of the laptop. Do we have it on there?
Can sit here?
Yeah, sure. That will be fine.
Wat is het? For what?
Don't worry, I'll show you. I wasn't sure if, for a second I thought...
Oh, maybe you thought I was in between with
No,
my,
I realized you're
my
not,
mixer, but I'm not. No.
Never mind.
I could do it, but it's complicated for the PCs.
So, we're going to do on this side. believe this.
Yeah.
We have success.
Right.
Okay.
Cool. So which ones are you using? This one?
That's good. Then in that case he needs to put this one on his shirt.
Which one is for the room? That's the room,
Yeah,
and this is for your
and
recording,
that's
right?
also for the room. This one. So if he uses this one, he's going to.
And this one is for the recording, right?
Yeah.
Okay.
But I have another one for recording here.
No problem. We just do this.
I cannot.
Do you want to stand or sit?
I'll sit, please.
Okay. So there's a chair.
I'll be doing some typing, so.
Yeah, I do the same thing. Have a seat. Get you comfortable.
Okay.
So that means I'll have to sit the entire time, right?
Well,
I
if
can't
you want
just
to walk around, it's also possible. But
just take the microphone.
What do you want? Do you want to walk around?
Never mind. I'll sit the entire time.
Up to you.
What do you want?
Well, there are two parts of the talk, and one is more talking, and the other one is
Yeah.
more me typing something.
So how about let's do-
If he's going to
But
walk,
that's fine. I'll sit the entire time. It will be fine.
How about this?
what you want?
I will take care of this. This is for your recording, right?
Yeah.
Okay, I'll take care of it. Don't worry. Here, put this on. Hey, I said do not get naked here, huh? This is not part of the deal. We have to pay extra for the copyrights this way, and it's not allowed. Okay, so this is for his recording, and that's for the room.
Okay.
So it's kind of silly. I would put it in your collar. No? Hey, up in your post.
Oh, well, you have to do it right because otherwise.
I used to be a sound guy.
I have to
Yeah, cool.
throw the recordings away.
Check it. Go check your.
No, it's not going to work. It's going to do like this, and
it's gonna be perfect.
then you will be.
I have a tape. As you want. Everyone in the back, come closer, please. And we don't have to use the microphone if you're.
Okay.
If you're. Yeah. There's someone looking at porn in his laptop in the very back. Don't worry, you can do it in the front. Come.
By the way, you people in the back, is the font large enough? Yeah. Okay.
Come talk with me.
I
just wanted to make sure I pronounce your name right. I guess Adam is easy, but just tell me something about you so I can introduce you properly.
Okay. The surname is Ružička. If
Yeah.
it's something you can do.
My Czech is not very good.
Okay.
It's Czech, right?
Never mind. Yeah, it is.
Veľmi dobrá. Maybe Česky?
Yeah.
Yeah. Okay.
That's good.
Tell
I'm
me something different about you.
I'm a software engineer from Red Hat.
I know that.
I worked there for, I don't know, a little bit over 5 years.
And Purple Idea. I used to work there too.
Oh,
yeah.
Cool. I don't know. I'm not the actual original author of this.
What do you do for fun when you're not?
For fun, I ride a motorcycle and I play the bass guitar.
What kind of bike do you ride?
So far I have Suzuki GS 500.
GS 500?
Yeah, but I'm looking at advertisements and planning on getting something.
Yeah?
Yeah.
Okay.
Beefier.
I'll come and I'll do the time for you. Do you want them or no?
Yes, please.
Okay.
Almost.
I'm not gonna try, but I will have to walk out for a bit of the room possibly. So if I do, I apologize for that.
No problem.
Hello everyone. How are you? Good. I'm not sure anyone's here. Hang on. Hello everyone. Is it working? Can you hear me?
Yep.
Are you awake? Are you shy? Okay, we have a great talk for you. Adam is a software engineer from Red Hat, and he's come to talk to you about DynFlow. Apparently he rides a motorcycle. He's got a 500. I bought a 500 about a year or two ago, so I'm in that danger group. But as long as he doesn't die, he's going to come back next year and give us more talks maybe. So please give me a large round of applause. Adam.
All right, thank you very much for having me. The title of this talk is, sorry about this. The title of the talk is DynFlow, Orchestration for Your Ruby Project. But it doesn't necessarily, be Ruby. Like DynFlow is, but your project doesn't have to be. A bit about me. As you already heard, I'm a software engineer at Red Hat. I joined Red Hat around 5 and something years ago. And Dimeflow was actually the first thing I worked on. I joined as an intern, and then I was just thrown into this, and I tried to make some sense from it. I must admit, I'm not the original author. When I joined Red Hat, it was already ongoing, and both of the original authors already moved on. So now it's up to me and Andrzej in the audience to maintain it. I am Adam Ruzicka on GitHub, Ruzicka on Freenode in case you want to get in touch over IRC, or _Arus_ on Twitter. Now, what you will see in this talk, we will take a look at what it is. We will take a look at why it was created in the first place. We will introduce a demo project I will be implementing during this talk. We'll take a look at the basic building blocks of Dimeflow, because it has several concepts which can be confusing when you don't really know what they are. Then we will take a look at the high-level deployment. Whoops, what just happened? Okay, resume presentation. Next, we will take a look at common patterns used in Dimeflow. And this will be probably the biggest part of the talk. It will be the one where I will be sitting at my computer and typing stuff, and you will all be able to see how bad I am at this when someone is watching me. Then we will quickly go over some other cool things which Dimeflow can do, but we probably have time to go over them fully, because if I did that, the talk would be like 5 hours long. Then we will take a look at more depth into how it can be deployed. And at the end, we will have questions and answers. So what? What is it? Please raise your hands who ever heard of Dimeflow before coming to this talk. Okay, 1, 2, but those are foreman guys, those don't count. And one of them is the other maintainer, so yeah, okay. So the official site says that Dimeflow is a workflow engine written in Ruby. Usually when I tell people this, they don't really know what to expect. So I tend to say that it's smart background processing engine, but not really a background processing engine. The smart part is it allows you to manage dependencies between the things that have to be run, and you can order them, and you have better control over what gets run when. That's why I say it's smart. Also, it's not really a background processing engine, because if you don't need these dependencies, there are projects which do it better. Like, if you don't need the full force, you could be better off with, I don't know, Sidekick, Rescue, maybe ActiveJob. It's a solution for when just the pure background processing isn't enough. Like, if all you need is just, okay, I need to do this one single thing, and I need to unblock this thread, then, you know, Dimeflow is a bit of an overkill for that. It is currently used by Foreman and its plugins quite heavily. Okay, now why did we write this thing, or why the original authors did? To be honest, we needed to scratch our itch. The itch was that we were integrating with 2 other systems which had their own tasking system and an asynchronous API. That means it wasn't like, do this thing and you would get the response, but it was, we told the system to do something and we would get back, okay, I'm tracking this as task XYZ, check later. And then we would have to poll if it is done. And when it was done, we had to trigger something else in the other system, and we had to keep those 2 in sync. That's why this project was written. That's it. Additionally, we wanted to have a better insight into what is going on and when, and it delivers, I'd say. Okay, so just an outline of what I will be trying to implement in this talk. It will be a CI-like thing. You know, so if you imagine Travis or GitLab CI, sometimes some change happens to a repository, and then a pipeline is kicked off. So the workflow will be, we will clone a Git repository, we will install dependencies, run some lints, run some tests, optionally build a Docker image, for example, and that's the thing we will be making. It will be using Dyneflow under the hood. I created a repository, Dyneflow CI, where there's a skeleton of the project with some helpers that I will be using later. And an example project which we will be cloning and testing and linting and whatever. So now the tricky part, the building blocks. Please ignore the action 2 and the plan, run step, and finalize step below it. Let's take a look at the action roughly in the center first. The core concept of Dyneflow is an action. Action is a recipe how to do a single thing. It may be cloning a Git repository, running a command, building a Docker image, something like that. The good thing about actions in Dyneflow is they can be composed, and we can have an action which depends on others. So, for example, if we were implementing a CI, we may have an action representing the entire pipeline, and it would be composed of cloning the repository, installing the dependencies, running tests, and all the following things. Next is probably the execution plan. It's hard to say what to describe first because all the things are interconnected. But the execution plan is a realized action. It's a concrete thing. It's again a kind of recipe, but this time with data. So if action is how to clone a Git repository, then an execution plan is clone a Git repository which lives at this URL. So it's the action plus input, so it is able to do the thing it is supposed to do. Now, what are the steps? The steps are runtime units of Dyneflow. So it's the most granular thing that Dyneflow can execute. And they are divided into phases. First phase is the plan phase. That's the one where you're basically creating the execution plan. So during the plan phase, you are preparing how to do the entire action top to bottom. The run steps are then when you take a prepared execution plan and you actually try to perform it. And then in the end, there is a finalized phase which can be used to perform cleanup after the action was done, or anything basically you may want to do. Now the same thing in text. So action describes how to do a single thing. It can be composed. It has up to 3 steps. Each is in one phase. There is always one step in plan phase if the action is in an execution plan. Always. With run steps and finalize steps, it doesn't have to be. There can be an action which doesn't have a run step. There can be an action which doesn't have a finalize step. It may miss both of those, but it always has a plan step. Now the execution plan is concrete description how the action should be performed. It contains at least one action, usually called entry action. And it can transitively have more actions as children of the entry action. This is what I mentioned when I said that there could be an action representing the entire CI pipeline, and it would be composed from different actions. Those different actions would be, in the execution plan, they would be as children of the entry action, and that would be it. And finally, the last item, the step is a unit of execution. It belongs to a single phase, so you can't have a plan step in a run phase. It would not really work. And that's it. So let's take this example, how planning might go. Here we have actions 1 to 5, and we are saying, hey, Dimeflow, create for me or plan for me an execution plan to perform action 1. So what happens is that an execution plan gets created, a plan step for action 1 gets created, and then the plan step 1 gets executed. Inside that plan step, the action can say, okay, I want to have my own run and finalize step scheduled to be executed later in the run or finalize phase. Or it can say, I need another action. So in this case, action 1 could say, okay, I want to have my steps, and then I want action 2. So what would happen is that action 1 said, I want my own steps, so the run and finalize steps would be created for it. And then it would say, I want action 2. So plan step would be created for action 2, and it would be executed. So we go one block to the right, we're inside action 2, and action 2 can say, okay, I want to have my own steps, and then I want action 3 and action 4. And I don't really care in which order, so if you can execute them side by side, I don't care, it's fine by me. And this way it goes through the entire graph, so it goes 1, 2, 3, 4, then it backtracks to 2, 1, and then it goes to 5. This is the order in which things would get planned. Now, once the execution plan is ready, it can be executed, and that means that we are moving from the plan phase to the run phase. Coincidentally, execution plan has a status. At this point, it gets turned over to running. So in the start, it was pending, then it was planning, that it was planned, and now that someone is actually working on it, it's running. And if we planned the actions the way like we did on the previous slide, they would be executed like this. First, action 1, and action 2 couldn't be executed until action 1 is. So action 1 gets executed, action 2 gets executed, then action 3 and 4 can be executed at once. And Dimeflow knows how to do that, so it would. And action 5 would wait until both 3 and 4 are executed. So those are the dependencies I talked about. It's really simple, and you could probably work around that, make your own solution. But in the wild, I've seen execution plans which had, I think the biggest one was 300,000 steps. So if you want to micromanage that by hand, good luck to you. But Dimeflow is able to keep up with that. And then once the run phase is done, we move over to finalize. And in finalize, everything gets executed in the order in which it was planned, one by one. And it runs in a transaction. So either all of these succeed or none. And if it fails some way, halfway through, you can just resume it. It will roll back to the start of the transaction, and it will try it again. Okay, those were the most important concepts in Dimeflow. I promise if they don't make sense now, they will start making more sense when there are examples and you can actually see the real code and what it creates. Now, a bit about high-level deployment. In this talk, I will be using a deployment which looks like this. It's a box. It's a single process. It has a built-in in-memory SQLi database. And it has several worker threads which are hidden. We don't really need to care about them for now. But just bear in mind that this is, the development deployment, let's say. When you're running it in production, it may look be more like this. where there is a shared database, which is external. It doesn't live inside the Downflow processes anymore. And there's a distinction between executors and clients. In Downflow terminology, those are worlds. The executor worlds can do everything. They can plan execution plans, they can run the run phase, they can run the finalize phase, they can do all of that. The clients can only plan the execution plans. That means the clients can prepare what needs to be done, and then they have to ask some of the executors to actually do it for them. But don't worry, it's not up to you to do this, prepare and tell. It works out of the box on its own. Now, we're getting to the code. So, I mentioned that an action is a recipe, how to do a thing. Now, an example. An action is a Ruby class, which has to inherit it from Downflow for.action. And actually, this example is a bit misleading because it's not the simplest action that you can create. So, okay, I'm in the Downflow CI project, and I have a run me script which triggers the Downflow, runs the web console, because Downflow has a web console where you can see what's going on, and then it spawns a Pry instance so I can interactively interact with that. So let's do the simplest possible action we can and run it. So let's do class test inherits from Downflow action, and that's it. You don't need to do anything. And then I can trigger it by calling world.trigger and the name of the class. Boom. Okay, it's planned, running, something. Let's look at the Downflow console to see what it's doing. Okay, /Downflow. This is what I was talking about when I said I can't really type when people are watching. Oh, here we are. This is the Downflow console. By default, it shows only tasks which aren't stopped, and the one we created ran really quickly. It's already done by now, so we can filter by that, and we can see that it stopped. It was successful, and if we look at the details, we can see that it didn't do much. It had a single plan step, but it didn't really do anything. It had no run step. It had no finalize step. So you can probably see where this is coming from and what is the mapping between the methods and the things which actually get created. So there is the plan method, which is by default in the Downflow action class. So since it's already defined in its ancestor, you don't have to define it yourself. Then there's the run, which is what should be done when the run step is run. And then there's finalize, which is obviously what should be run when the finalize is run. Now, inside the plan action, inside the plan method, you can use either plan self, which will make Downflow create the run and finalize steps for the current action, or you can use plan action to plan other actions. There's this distinction, and it will be seen in further examples. And one more thing to notice, both run and finalize are optional. That means if you don't define them, and then even if you call plan self, there won't be run and finalize steps created for this action. Okay, so let's do our first real action, which actually does something. It will be an action which will create or clone a Git repository. So let's go into lib, Downflow CI, clone Git RB. So it's module, Downflow CI, class, clone git, and it is inheriting from dimeflow action. How should it look? It should receive a URL to the repository we want to clone, and in the plan phase it doesn't really have to do anything else. It just has to make sure that it will have its own run and finalize steps. So in plan it will plan self and pass a hash as an option. Oops. Okay. Next we need to define the run method, and here we can access the actions input. I haven't mentioned this yet, but actions have input and output, and that's a storage which gets serialized and stored in the database. An action can use it to pass data between phases. So in here I can use input, it's just a hash, and I can use that to access the URL which was originally passed to the plan phase, and then it was passed on as parameter. So all I need to do is just create a temporary directory. Then I will store path to the directory in the actions output. So the later steps, which will follow, like the tests, installing dependencies, will know where the checkout is placed. And the last thing I will do is just run git clone the URL to the directory. Why not? Let's do this as a full example, and let's have it have a finalized method as well. And there we will file utils rmrf the checkout. So this action is self-contained. It gets an URL, it clones the repository somewhere, and when it's done, it removes it. And all that's remaining is to add it in here. Required flow CI slash oh. Okay, clone git. Now we can go over to the console and we can try running it. I have a repository defined as this constant, and we can try running the action. So it will be world.trigger dimeflow CI clone git, and we will give it the URL, which is the repo. Okay, and it blew up. That's the thing with live demos. Okay, undefined method mktemp. Okay, there's an. Okay, this method is called differently. So if we do this again, okay, success. We can inspect the dimeflow console, and we can see that it ran. It had the run and the finalized steps. We can see that it was cloned into /tmp/d2020 something. But if you looked there right now, it wouldn't be there because the entire execution plan is done, and in the finalized phase, we removed the directory again. So let's just believe it does what we need it to do for now and move on with the slides. I have several examples here. They are more for like, if what I was doing went terribly wrong. So we will have an action which receives two inputs. One is the directory in which it should run, and the other one is a command it should run. And it changes the working directory to the directory, it runs the command, and that's it. Either it succeeds or not. If it succeeds, we raise an exception and mark the step as failed. Alternatively, there is a different way for changing of the directory. The way it is right now, it works, it could be done, but let's imagine you had another action which would need to change its working directory as well. Then you would have to duplicate the changing of the directory in every single place where you wanted to do it. But Dimeflow allows you to define middlewares, which allow you to run pieces of code around execution of steps. So in here, I'm declaring a middleware, which will change the working directory and then pass the execution forward to the step. So what's going on here? It assumes that the action has the directory dir key in its input, and when this gets run, the middleware takes the directory, changes the current working directory into there, and then calls pass, which moves down the middleware stack and calls the next step in there. The next step could be another middleware. You can stack them however you want, or it could be the step, in which case it starts, after the step is done, it starts going up back the stack. So we could use this. And then you just have to tell the action to use the middleware. So instead of having everywhere the dir.change dir something, you can just do middleware.use and the class of the middleware, and that's it. Now, we define several other actions. We are inheriting from the run command action and just overriding several inputs and so on. So, for example, installing dependencies is just planning self with command bundle install and running it in a given directory. Running tests is basically just a run command, and we will pass all the things it needs to it. And then there's build docker, which takes the path, label, and a tag, optionally, and plans self with, again, it's a run command, takes a directory and a command, and it does that. Now, the composition. We have seen how actions can plan other actions, and that's using the plan action method. Again, it takes the class of the action and then all the parameters. And all the parameters get passed to the plan method of that given class. That's the binding between the two. What's also interesting is the line below it, the one with the output. If you remember the clone git class, it sets the output in the run phase. But here we are still in plan, and we are taking its output, taking a value which lives under a specific key, and we are passing it forward to other actions. The thing here is that at this moment, the output is not the actual output, it's a reference to a future output which will eventually be there. So we can pass only a subset of the action's output to another action, and once we get to the run phase, it will all start fitting together. Like now we're just passing the reference around, and when it turns over to run, there will be the actual values. So this is how a simple CI pipeline could look. We take a URL, we clone it somewhere, we clone the repository somewhere, we go there, we install the dependencies, then we concurrently run tests and run the linting. You may want to run them, in sequence, but this is just to demonstrate how Dimeflow can handle the concurrency. And in the end, we plan the build Docker action to actually build the Docker image. Do you want to see this live, or can I move on? I'll keep going, and if you have time, then we will take a look at it. Basically, I would just have to copy and paste from the slides, and it should just work. Should. Another thing that is quite common are rescue strategies. There are 3 options for those, and that is pause, skip, and fail. Rescue strategies are basically a way of telling Dimeflow what to do with a specific step if it fails. The default is pause, so that means there was a step, it failed, we don't know what to do with it, but it's important, so we just stop at this place and we will wait for the user to resolve it. And the entire execution comes to a stop and waits until the user fixes it and resumes the stop. Next, there is skip, which is basically a way of saying, okay, this step is not really all that important, so if it failed, we don't really care, and we just mark it as skipped, go over it, and continue. And then there's failed, and that is embracing the let it crash. So if there was an exception within the step, we just failed hard, we stop the execution plan, and we don't give the user any option to resume it or try to fix it. It's stopped, it's done, it's finished. Those two can be overridden by defining the rescue strategy for self and rescue strategy methods on the action. The strategy for self says, okay, I as an action, if I fail, I can be skipped. And then if this action is planned as a child of other action, the other action can take this into consideration when deciding what to do. Alternatively, you can define the rescue strategy, and it will say, okay, I say we want to do this, and I don't care what my child actions want to do. So it will override the decision. Another quite common pattern is suspending. Because when steps are running, they are keeping the workers busy. I can actually show you that. I will quickly define a busy class, which inside of its run method, it will block for 60 seconds. And then I create 25 of them. Okay, we can see they got planned. And if I switch over to the Damflow console, I can see they are all running, pending. But if I go to the status and load execution item counts, I can see that there are no free workers and that there are 20 items which are waiting to be executed. That is because you can define the number of workers you want Damflow to have, and these are threads. But if you keep them busy, they are busy and they can't do anything else. That's why we have suspending. If you just want to inject a delay into the pipeline, don't know why, you can suspend the steps. You can say, okay, I as a step am running and I want to suspend, and then the suspended step can be awakened by sending them events. They can be sent by external processes, they can be sent by internal clocks, so you can have an action which says, okay, I will sleep for a minute and then wake me up. This is the example. Then the run method actually accepts a single argument, and by default it's nil. And what all this action would do is it would start running, it would go to sleep, but before it went to sleep it would set up a clock to wake itself up in 10 seconds. And this way you could inject the delay without blocking the workers. Now if we had this, we're just a step away from polling. Damflow actually includes a module for doing easy polling. It's a wrapper which leverages suspending events and clock. And it's defined in the Damflow action polling module. And all you need to do is define those three methods. The first one is invoke external task, which is used for kicking off the thing you are waiting for. And then Damflow will call the poll external task for you. And what you do in there, it's up to you. For example, when we did this, we used invoke external task to call to the external service. Then we used poll external task to ask the external service, hey, what's the status? And then there's the done method, which actually takes the data from poll external task. It's handled by you. The done method should not do additional polling. And it's used to determine if we are done or not, and if we should keep polling more or not. There are several methods additional that you can define which will fine-tune the behavior of this. You can override the interval in which it polls. You can limit the number of polls and everything. Then another pattern is canceling. It's included in the action cancelable module. And what it allows the user is to go to the web UI and cancel a step which is suspended. So we usually use it with polling actions and so on. So if it is polling and you know it's never going to finish, for example, then you can go into the UI and say, okay, let's cancel this, let's abort. You need to define the cancel method. That's the thing which gets executed when actually user clicks the cancel button. And inside run, you can't override it completely. You have to use super somewhere in there to actually go one level up to the cancelable module, which handles the canceling. And the last piece are subplans, which are useful for a matrix-like usage. So let's say we had the class which would run a CI pipeline, and then we would have a CI matrix, which would run this pipeline with, I don't know, different databases or something. And again, all you have to do is include this module and define the create subplans method. This method should return an array of execution plans. And that's exactly what we are doing here. We're taking the databases from the input, and for each one we trigger a CI pipeline job. Now, those were the things which would probably use if we were to start using Dimeflow right now, because it solves a problem for you. But Dimeflow can do many different things, some of which are more advanced. For example, with Dimeflow you can do a publish subscribe kind of like usage using subscriptions. So you can say plan this action when another action is planned, and Dimeflow will do that for you. Dimeflow can do execution plan hooks, so when the entire execution plan turns over to stopped, paused, or something, you can run a code. It can do future execution. You can say, hey, let's run this action for me in, I don't know, 12 days. Why not? It can do singleton actions, which means there can be only one running instance of them. It can do subplans in batches, but that's if you're having a lot of subplans and you need better performance. And there's actually a proof of concept branch on GitHub which implements a rollback rescue strategy, which allows you, well, to roll back in case the execution plan hits an error. Now quickly about the deployment. Inside the Dimeflow executor there are several things. It's a single process which has a clock. It has orchestrator which tells the workers what they should do, which step they should be working on. The orchestrator has some local state. There are some queues, and the workers are actually consuming the work items from the queues. There's a client, in this case Foreman, and it communicates with the executor through Postgres. We can also do split deployment, which is a new thing. In Foreman, it's in Nightly currently, and that's where we split the orchestrator into multiple processes, and we added Redis into the mix. So the queues are now living in Redis, and it should scale better and be more performant. And of course, it allows us to scale the workers independently on the rest, so you can just add more instances, and this image could grow probably almost infinitely. We are almost out of time, so I will open this for questions and answers. I'm sorry about not delivering on the live coding part, because there was a lot to go over. So questions, please.
Have a good 5 minutes. Someone have some questions? We have a good 5 minutes for questions. And like before, if we don't have any questions, you don't get free beer tonight, and non-beer alcohol beverages.
Okay, so did I do a good job? So I did so good job that it's clear to all of you, and we will just go out of the room and start using it right now.
Yes.
Yes, success. No, seriously.
This is a quiet audience. There's a lot of shy people, so you've got to scream at them a little bit. Someone has a question.
Come on, I'm not a drill sergeant. I won't shout at you. Okay, so let me ask you, is anyone after seeing this considering using it for something? Just raise your hand, you don't have to talk. Okay, one person, two, awesome. Three, sure.
Twist the question around. What do you think are the most common use cases for
Can you repeat the question?
Okay, so the question is what I think is the most common use case for Dimeflow. For me, it's orchestration. You need to call external systems, you need to track the execution, how it's going, and you need to have granular control over what happens when, and being able to somehow work with that when things go wrong. Does that work?
Yes, do you have any more specific examples? But you look like you were sort of running a sort of CI pipeline. Is that the kind of typical use case?
Well, you can do. Sorry, the question was is if the CI-like pipeline is the thing that Dimeflow should be used for. My answer: why not? You can do almost anything. For example, in Foreman, it's used for synchronizing between different backend projects. But you can use it basically for anything, really. There are no limitations put on it.
We have time for one more question if anyone wants to be brave. If you're shy, I'll just pick on you. Yes, this person over here has a question. If you think I'm pointing at you, it's just arbitrary pointing. Anyone? If not, let's give Adam a huge round of applause, please.
Thank you, everyone.
Thank you. So Matteo, I guess we don't need the microphone, but Matteo's going to be giving our last talk of the day. It's a shorter talk, it's only 25 minutes. And then after his talk is over, then I will tell you about the fun stuff for this evening. So come get set up. Do you want to have the podium or do you want to sit?
Can I just pull the cable out, or do I need to?
Just pull. No! Of course, that's fine. Thank you for not having a Mac. This one or that one? HDMI? Yes. And before you start, I'll introduce you. Okay. So I'll let you do that. Is this yours? Yes. You want some power? Yeah. You take this side. This is for the recording, and the big microphone is for the room.
Okay.
Want to flip it somewhere?
On?
Hello?
Red light?
Hello?
No.
Yes? They're the sound guys here again. You want to talk to him? Okay, talk to him.
Oh yeah, that's right.
You turned off your other mic. The battery is dead anyways.
Oh yeah?
Could be.
Okay.
You want that in your pocket?
Yes.
There's nothing. Oh, this one you mean?
Yeah.
That is not mine. That's from the university.
Okay.
This one.
Okay.
We have to load this for tomorrow. I don't know how it works. Yeah.
You want HDMI? So I'll give you this one. Give it a second. Oh yeah, clicker.
Yeah. Okay.
I do mirror too.
Okay,
Okay.
perfect.
Give me a minute. We'll wait a few minutes, and then I will introduce you, and then you can
Okay.
come on.
Are we going to wait?
Yeah, 3 minutes.
All right. 3 minutes for nicotine. 3 minute nicotine.
You better hurry.
Yeah.
I'm starting. 2.5 minutes now.
Impossible. Yeah.
You're addicted like crazy.
Yeah. Terrible.
Thanks for coming.
Thank you.
Sorry, it's at the end of the day. Someone has to be the victim.
I know.
But did you get a bracelet for?
Yes.
Okay, good.
Toshi have already announced the start of the meeting, so yeah.
Anyone want to come closer in the back? It's scary. It's scary. We like our action. He is sitting in the front, so it's even scarier, right? So we like our action. The next. Ah. Let's see how bad it is. Ow! Ow! Help! I'm stuck. You can just lean your head back and.
Is it possible to get the air bracelets after the talk, or will it not be time?
You find out, yeah, I think so. Possibly. It's for people who have been visiting the sponsors during the day. Aha! Tricked you. Yeah. Got a few minutes.
Okay.
I just wait.
Worry.
I'll give you a nice introduction,
Mhm.
and then if someone is running to another talk, they won't miss it.
Yeah.
There might be someone who's
Yeah.
like, I don't know.
Yeah, no problem.
And you'll speak into this one too?
Sure.
All right, everyone, we're going to start in a minute. I want to introduce Matteo. He's working for a company called Nethesis.
Yeah.
Am I saying it okay? I always feel bad about pronouncing things bad or poorly. He has told me he's hacking on a bunch of things, including a bit of Golang, but also he's getting married, and his life will be much busier, so his coding skills might go downhill a little bit. So I want you to encourage him with a large round of applause. Please give it up to Matteo.
Thank you. Thank you, everybody. I want to say hello to my future wife, Akemi. Okay. Oh, okay. Can you listen? Can you hear me now?
Hi.
Okay, better. So, hi everybody. In this talk, I'm going to show you how you can manage your DNS infrastructure as code and why this problem came to me. So, the problem was started almost a year ago when we use a web-based interface for manage our DNS configuration, and we have some problem like who have created the records, why this record was created, what does these records do, and most important, are still using, someone still using it. So, I was assigned to the task to solve this problem, to migrate from a web-based console to something more modern that can be on-premise or on the cloud. I have only two constraints. The one is that the solution must be versionable and or programmable, but most important, I have only one day. So I have to start in the morning and production in the afternoon. After some thinking, I think that the maybe on-premise solution full managed is too complicated, will be hard to maintain, and too high learning step. Remember that I have only one day. If we use a provider for our infrastructure, there are so many, like, I don't know, DNS Simple, Amazon, Digital Ocean, and I was afraid that I I can make the wrong choice and suffer from vendor lock-in. So I came out with a solution to use OctoDNS. OctoDNS is, because it's a file-based configuration, so I can easily version it with Git. It supports multiple providers, so I don't have to choose one. And is provider agnostic, so I can use the same syntax configuration for every provider. Not like, for example, Terraform, where you have to use a different syntax for every resource, for every provider. OctoDNS was made by GitHub and usually internally for manage their infrastructure until it was released as open source project. And the configuration file are in YAML. Let's see a simple setup of OctoDNS. Here we can see in the providers block the definition of our provider. In this case, we have the config provider, that is the type of YAML providers, that is the directory where we are going to store the configuration of our records, and OctoDNS will be read from there. Then we have the DO provider, that is the type of DigitalOcean provider, and the token property will tell to OctoDNS to read the token for the authentication from the environment variable DO token. Then we have the zone configuration, where, where if we have our example zone, in the source field we can find where OctoDNS will read the configuration, and in the target zone that you can see, we'll find the provider where OctoDNS will apply the actual configuration. So we are going to read from the source and applying the target. This is the simple example of a configuration. We define an Apex domain with the record MX, the record A, and a simple www subdomain. How we can use OctoDNS? We can simply install with pip. We can verify the configuration with OctoDNS validate. With OctoDNS sync, we can test the configuration, and we can apply the configuration with OctoDNS sync with the option do it. The resulting directory layout of our project, of our zones, will be the configuration for OctoDNS and a directory with the zone configuration. I told you before, we are going to version all the changes, so we are going to use Git. Why Git? Because she allows us to have an history of all the DNS change. We can relatively easily roll back in case of error, so with Git reset or Git revert. We can add a who and why to the DNS changes, and we can facilitate the process of the review of the proposed DNS changes. We are going to automatize all the things with Travis A, but what is the benefit of automation? One of the first benefits is that now we can apply a continuous integration to DNS changes, because for every proposed change we are going to test it with Travis A. We can also apply a continuous deployment, because we are going to actually apply the change when we are going to merge to the master. And we can try to avoiding a credential leak, because will be not the user to apply the actual change, but Travis C. So we are going to store the credential in Travis C. This is the simple configuration of Travis C. We can see that in the install part we are going to install OctoDNS. Then, for every pull request, we are going to first validate the configuration. It's only a syntax validation. Then we are going to test the configuration to the actual production environment. And when we are going to merge the pull request to the master, we are going to apply the actual configuration with Octodine-S sync with the option do it. As told you before, Octodine-S, we are going to read the provider's credential from the environment variables. And in the case of Travis CE, we are going to set this variable as secure, so the pull request from another repository can't read the variables. The resulting workflow will be that a user make a pull request with the requested change. Travis CE will test the change, and user asks a review of the pull request. Administrator can start the review, and if you want, can approve the change. Most important here that will be the user to actually merge the pull request, so he can decide when is the case to do it, not early, not later. At the end, Travis CE will apply all the change. Be warning that for Octodine-S, the only source of truth is the configuration. So if you are going to modify the configuration outside Travis CE will delete the records, because he can know if the record is present in the production environment, because we have deleted from the configuration of added outside the Octodine-S. Some advanced usage of Octodine-S can be the backup provider, so we can easily add a backup provider. Like in this case, I have added the configuration for the Cloudflare provider, as we can see in the last, in the CF block, with the credentials stored in the environment variables. At the end, sorry you can see it, but we have our source provider like before, and we have the DigitalOcean and under the Cloudflare provider. So when we are going to apply the modification, Octodine-S will read the configuration from the config provider and apply to the DigitalOcean provider and to the Cloudflare provider. This type of configuration is used by my company in production for a backup provider in case of failure. Another another use of Octodine-S is for migrate between two providers. We have the same configuration of the provider as before, but in this case, as source, we have DigitalOcean, so Octodine-S will read the configuration from DigitalOcean and apply to Cloudflare. So you can see, but behind is the Cloudflare provider. So all the record will be copied from DigitalOcean to Cloudflare. Other useful commands are the Octodine-S dump. In this case, Octodine-S will dump all the configuration from one supported provider to the YAML file. It can be useful for the migration. And Octodine-S compare. So Octodine-S will compare the configuration from the YAML file to the actual production provider. You can use this for see if there is some configuration drift. So, some quick recommendation if you want to use this solution. One of the fields is the quirks. As told you before, we are going to make secure the variable of the DNS providers. Travis CE will not allow the pull request from another repository to access to this variable. In this case, we have to modify the scripts for the validation of the pull request with the check that if the Travis CE secure and vars are false, then we are going to set the variable with the credential to blank. Because with OctoDNS validate, we are going also, OctoDNS, when do the validation, the synchronous validation, want also to access to the variables. And if we don't declare, we will see OctoDNS that complain because we are going to access to an existing variables. The other line is that if we are going to test a pull request from another repository, we can't, because we can't access to the secure variable, we can't also test the proposed change to the providers. Some recommendation is to protect the master branch, so permit the write only via pull request. Make mandatory for a pull request to be up to date before merge, so we are going to see what is actually applied, and maybe block the merge until almost one review approve the change. Okay, it was very quick. So at the end of the day, for me, it was mission accomplished. We move from a base point-and-click paradigm to an infrastructure as code paradigm. The DNS are now versionable, and we start in the morning and in production in the afternoon. Not actually not exactly that day, but the day after, when we have make sure that all the record was migrated correctly. So for us was a success, and what happened a year later? We still use it, so we find it useful. We have 59 commit, 34 pull requests, 3 contributors. We start with one zone, and now we have 4 zones managed with OctoDNS. And at the moment we have only 88 records. Before, I don't know if it's more than 88, because everyone can create and forget about it. So it's, the low number of records is a success. And that's all. I'm maybe too quickly, but I'm Matteo Valentini, a developer in Italian open source company called Netedis. This is my contact in case you want to reach me later, and if there is any question, I'm happy to answer.
So you still have some more time if you want to ask questions, and you're ahead of time, so we won't be mad if you play the party.
Okay, so yeah.
Are you aware of any kind of integration between OctoDNS and like old school bind?
Yes.
And stuff?
Yes, there is an integration also for this. I don't remember right now, but yeah, it's possible to integrate also OctoDNS with bind, and you can, with OctoDNS dump, you can easily dump your configuration from bind to OctoDNS. So it's possible. Oui. Okay. If there isn't
an easy way to have a difference between providers, one used internally and one used for only external?
Okay, sorry. So the question was if there is any easy way?
If you have 2 providers, one to use both for external and internal records, and the other one only for external records, is there an easy way to combine that?
With this, so do you mean a split record view, a split DNS view? Yeah. Yes, but you have to maintain 2 different configurations. Otherwise, no. It's no.
We have up to 10 more minutes, so if you have questions, don't be shy. Okay, you have to start your talk over at the beginning.
Okay, hello. So, yeah.
Do you like beer?
Yes, pretty, yeah. Much, pretty well.
Someone in the back also?
Maybe you can say something, how easy is it to implement my own provider for this thing?
Okay. So the question is how easy is to implement a new provider? I don't have a clear idea, but for what I read is in Python, and the implementation of the various provider is very, very simple. You can read it, you can modify it, so I think that it is not so complicated to implement another provider once you have the provider accessible via API.
Maybe you can show us
Yeah.
Welcome to live demo.
Time to an expected demo.
Needs a round of applause for using a GNU machine, not some Mac, right?
Thank you. Okay, let's see. Think provider. Okay. So let's take the DigitalOcean. Okay. Client. So you have the initialization for the request. Wait a moment. It'll pass some time, the last time that I read the code. Okay, maybe it's better with the documentation. Let's see. Support the pro. Eccolo. Oh, yeah. There is also a custom source and providers. So, I think that if you know Python, this part is the key for you. Okay, so there is also the possibility to write a custom provider almost on the fly, and this is the all provider supported. So,
Nice.
no, and thank you.
Useful.
Yeah.
Scroll it a bit.
Yeah. Okay, let's see if I bind, where is bind? Wait. No, wait a moment. I remember it. No. Sorry. But there is something for bind. I don't remember where, but there is something. I already answered this question.
It's in the zones files.
Maybe, yeah.
You can see that in the table.
Wait a moment. Yeah. Sorry. This one.
Oh, yeah.
Okay. Obviously, the documentation is the code. So yeah, support the zone files.
Okay, I'll look into it. Cool.
Okay. Thanks again.
Okay, so wait. No, we have to thank you first. We need a big round of applause for Matteo. Okay. So before you leave, in case you don't know, so we're going across the street to the zone. If you